Hello everyone and welcome you to the day 2 of the Azure Community Conference 2021. So there was a lot of session lineups on today where we'll be checking out a lot of new technologies, lot of new practices. So as a first session which is going to present by David Mayuri in regards to the architecting the modern cloud solutions and take advantage of database using scale-out abilities. And welcome you on stage.
Hello, good morning.
Hello, able to hear me, right?
Yeah, perfectly, perfectly.
Okay, sure. So, can you share the screen so that we can confirm as further step?
Yeah, I think it's already shared.
I will add it to it.
Perfect.
And the stage is yours, David Mayuri
Yeah, so just a
and
quick check
online
on
session.
the timings. I have 1 hour, right? Can you hear me?
Unable to hear.
Can you hear me? Hmm. Okay, I guess we can just get started. Okay, let's get started. Yeah, so let's start and let's go to the topic of this session of this evening for me, morning for you, I guess. Architecting modern cloud solution to take advantage of database scale outability, which is a word I created. I'm very proud of it. I will be using as much as possible, and I think it really gives the sense of what we are discussing. So let's start. Well, first of all, thanking the sponsors that make this conference possible. And let's just spend just a couple of minutes on myself, who I am and what I do. So I'm Davide Mauri. I am a SQL Server actually an Azure Data, Azure SQL PM, and I was a SQL Server and Azure Data MVP for 12 years, but now I'm in the Azure SQL group since 2019, and I take care of making sure that Azure SQL is really the best database for developers, and it will still be in future. I love speaking at events, blogging, sharing what I learn. So you can see a couple of resources you can use to connect with me and to see what I share. And then also something I really want to share here is that last year we published a book dedicated to all the new developers that are starting to work right now or in the last years, and maybe they are just starting in the cloud with no on-premises experience. So we created this book to help all developers that never used SQL Server before but only used Azure SQL to have a very smooth learning path so that they can start from zero and reach to medium high level in a very practical way. So this book is very practically focused. There are also a lot of references to theoretical documentation that you can go and check for deeper knowledge. This is really the book I would have loved to have when I started developing, because I discovered database can help so much a developer to create amazing stuff, and so I really recommend this book to anyone with any language, any platform. So let's move now to the session goal. Session goal is something that it's different than usual because I want to kind of provoke a little bit of discussion, see things from a different perspective. In general, review what has been well known for so many years, but now the cloud is disrupting a little bit the things, and with the latest kind of evolution of databases, I think it's time to review, how we architect and what we think about the behavior of the data access layer, the otherwise known as DAL. And for that, we will use a little bit of, lateral thinking or out of the box thinking to try to see things from a different perspective. So let's start from the point that application needs to scale out today in the cloud world. So you want to deploy an application that is very easy, not to only to scale up, which is of course still good, but especially you want to scale out. So create many instances of the application running on different nodes so that they can elastically scale out and handle as much as workload or as many requests as you want. Now, to do that, typically use Azure Function. In Azure, use Azure Function or web apps or containers, all things that are very easy to scale out, and actually you don't even have to think too much about how they can scale out. You just make sure that your application is stateless. So it's very easy to scale out because you don't have to keep the state, which would require, for example, to have all the connection or all the requests going to exactly the same instance. So typically, and actually this is the best practice, to create a very scalable solution, you really want to make it stateless. But the trick that you use to do that is usually that you simply push the state to something else, to somewhere else, right? So you don't want to manage the state, fine, but then you just push it to another layer, typically the database layer. So typically you have a database, relational or relational, key value store or whatever, that is actually handling the state, right? So it turns out that maybe at some point you also start to say, hey, maybe we should also scale out database. Well, if you start to think that, and of course, I really encourage you to think that, because even database needs to scale out, because we want to handle more and more queries, more and more workload. So it's good to think in terms of scale outability for what concerns database. So not only scaling up, which is great again, but scaling out is also good. And the moment you start to do that, you may realize that is way more complex than you may have thought at the beginning, and definitely way more complex than a single instance database. So when you only have a single instance database, everything is easy. The moment you start to distribute database, a lot of problems start to arise. You may have heard of the CAP theorem. That's just the tip of the iceberg, because actually, if you ever use a distributed system in general, but specifically database, and just a couple of examples could be Spark, which is not, of course, a database, it's a distributed computing platform, but it can behave like a database sometimes. Or Synapse, for example, to stay in the Azure realm, you have definitely, or even Cosmos, for example, you definitely have face the challenge of correctly sharding the data or correctly partitioning the data, where how do I want to split my data in all the nodes I have? How do I distribute the data? Or, for example, for data warehouses, does it make sense to distribute the data, or it's better to duplicate some data in different nodes? For example, when you want to have local joins between facts and, for example, dimension, if you are into the BI space, then maybe you need also to have different nodes that are able to update, so modify different data. But maybe the data is not so different, so at some point you end up having conflicts, because different node tries to modify the same data, so you need to have conflict resolution. This is typically in a multi-master environment, or problems like data availability, like if you have a distributed database and one node is down, is that data unavailable or it's duplicated somewhere else? And if it's available, for how long, and what happens to queries that tries to use that data? Latency is also another problem. Again, your data is distributed in different nodes. You have a query that spans different node. What if a node is sensibly sensibly slower than the other? Well, the problem is that it may slow down the entire query. So latency is definitely an issue here. Data movement is another big problem. If you have just a few megabytes of data to move around, that's not a problem. But what if you have terabytes of data? Maybe you have data in one node and the query is executing on another node. How you can make that data moving from one node to another quickly? Well, probably you can't. Traffic management. I mean, if you move data, you need to make sure that you don't overload the internal network of database. So there's a lot of problems, right, when you start to think how to actually distribute the database. So maybe there could be a way out, but we need to start to think differently. So a new approach that I started to think is from the realization that all these issues that we have is that as a developer, and I consider myself as a developer, I still develop a lot. I think in the last 2 years I wrote I don't know how many end-to-end samples that could actually be a good starting point for production systems. Uh, and one thing I realized is that almost every time, until recently, I always tried to use a distributed database like if it was not distributed at all. For me, I was trying to completely abstract the complexity of the distributed database so that my application always connected to one virtual node. In my application behaved or actually treated database like if it was just a single instance database, absolutely shielded by the fact that it was actually a much more complex system. All because I really wanted to have abstraction, so my application should have been able to work with a single database or a distributed database. I don't know, but definitely on my machine when I was developing it was a single node. But then when I moved it to the cloud, I wanted to have a distributed database. So my application was architected to just connect to a single node and pretend that it was really a single node even in the cloud. So abstraction was very important for me, and also loose coupling, because again, I was working on my laptop and everything was on one node, one database, of course. And I didn't want to kind of have to bake into the application the idea that I might have more than one node to deal with, because I really want to be loosely coupled, so be able to completely be independent from the database I was using. But then I started to realize that all these good things, right? Loose coupling and abstraction are absolutely good things. Maybe can be relaxed a little bit without losing, I would say, anything, and still so keeping the real values. But maybe we can relax them a little bit to gain something, right? So, what if we start to say that our application is actually aware of the fact that the database that we are dealing with is actually a distributed database? Maybe we can take advantage of that knowledge. So, for example, if we start with this idea that I know many of you, especially the architect, will say, "Oh man, no, that's horrible. My application shouldn't know, how the database is actually laid out, because otherwise it will create too much coupling. It will not be, abstracted, so it will be very difficult to move from one database to another, or to even just an environment to another." But hold on with me and stay with me for a second. So let's start to say that. All the problem we want to avoid with basically abstracting the database away from the fact that it's distributed database are somehow resolved today by just again treating a distributed database like it's a single node. So you connect to a single node. And we don't know how many nodes there are behind the scene. We connect to the control node, we could call it, and we run the query there, right? And then it's up to the control node to solve all the problems I mentioned before. But what if we actually know, instead of having just one control node to connect to, we can connect to any of the nodes that are available in my distributed database? Every node. Let's say our database is made of 10 nodes or 3 nodes or 15 nodes, and of course they can vary during the day or the week or the year. So during over time they can vary from 1 to whatever we want. But let's say we can connect to specifically some node that we want, and that each node is freely usable for us, and each node is independent from the other. So let's start with this idea in mind. Of course, if we start to think about that, the immediate question you start to wonder is, well, yeah, that's good, but how my application would know to which node it should connect to? I mean, if I need to run a customer query and the customer query data is in node 1, I should know, my application must know that it has to connect to node 1 and not to node 2 or 3 or whatever, right? Now let's solve this problem once and for all. Let's say that all nodes that we can connect to will be able to see all the data, right? So this immediately resolves the problem that we need to know to which node we should connect to in order to get the current data, because all nodes will see and access exactly the same data. So the data is shared across all the nodes. Now, we can also say that since each node is independent from each other, we can also have, I don't know, we have 4 nodes, and one node specifically is 10 core and all the other are 2 vcores, for example. Well, maybe we can decide that we want to connect to the 10 vcores node when we do some special complex query, like reporting query or analytical query. So by being able to connect to any of the node, and specifically to one node that we decide to connect to, we can start to direct queries to the most appropriate node using all the features that that node allows us to use, like all the resources, all the memory, or the CPUs. So I think that having said that, we can start to think that our application should be smart enough to know how many nodes there are in our distributed system, each node which kind of feature or resources provides, and then can pick up the best node to execute the query that it has to execute, right? So for example, just a very super simple situation is where you have maybe one node that can be that can be used for writing, and another node that can be used only for reading. Now, if you do that, you can start to immediately split, read and write query into different nodes. And for example, maybe you can also add another node that says, okay, my write queries are done on node A, my read queries are done on node B, but my complex read queries, so like reporting queries with a lot of join, a lot of I/O to be crunched, are done on node 3, that I create twice the size of the other node in order to have more power, right? So by allowing the application to decide where to run the queries, we start to be in power of using the node at the best of their possibilities. How we can do that easily? Well, one thing I thought that could be clever is to use a technique with a slightly change. So a well-known technique in distributed system is called data-dependent routing, which basically you route the query to the node that contains the correct data, right? So let's say you want to, typically in distributed system, you have a query that needs to work on all the customers that start with D, and you know that the customer that start with the letter D are in the node 1. So you send all the queries related to customer with that starts with the letter D to the node 1. That's it. That is what is, data-dependent routing in very simple terms. Now, let's use the same idea, but instead of based on data, since all the nodes sees exactly the same data, let's try to color the query. Let's say that all queries with the color red are sent to node 1, and then all the queries with the color blue are sent to node 2, and so on. Now, instead of colors, maybe you can use tags, and a tag represents the weight or the type of the query. So for example, we can tag a query, say this is a reporting query, this is a analytical query, this is a singleton query, so a query that only needs to read one single row of data, and therefore is probably super cheap and fast. And this is a read query, so we will send read and more complex read queries to specific node and write queries to another node. Now, we will still have the problem of if all nodes could read and write, we still have the problem of resolving the conflict. Now, since we are in the OLTP world, and in the OLTP world, typically you have a 80 or 70% reads and 20-30% writes, we can start to simplify the problem, saying, let's only have one node that will do the data modification. So from that node, the primary node, we will call it primary, you can read and you can write. That's the only node where you can do read and write, because all the other node will actually only be read-only node. Which again, since 80% of our, or 70% of our workload is read-only, that's still a big help, because this means that we can offload the read from the primary node that at that point will only do write and data modification, and split the read workload across all the other nodes, right? So this is very good. And it happens that in Azure SQL, we have a database SKU, so a database flavor of Azure SQL called Hyperscale, that is perfect for this idea, because Hyperscale actually is SQL Server moved to the cloud. For those who doesn't know Hyperscale yet, is SQL Server moved to the cloud, and therefore named Azure SQL. where the query optimizer and the compute and the query engine is moved in a set of compute nodes. The storage engine is moved in other set of compute node. So there is basically a set of distributed services working together to basically provide the same support, exactly the same engine that you have on premises. But that engine has just been re-architected to the cloud as a set of distributed and scalable services. Now, in addition to that, so this means that our compute nodes can see all the data in my database because the data is stored in a set of services that can be connected to any of our compute node. How many compute nodes we can have in hyperscale? Well, there is a new feature that is still in preview, so it has been released in preview, public preview, in this summer, called named replicas, that allows you to have up to 30 secondary replicas that behave exactly like I described before. They are independent. They can each of these named replica can see all the data in the database. You can connect to a specific named replica, query run some query on the specific named replica already. That query is a isolated compute node, completely independent from all the others. So you can scale it up, scale it down without affecting any of the workload in the other replicas, which is exactly what we are looking for this idea, right? Now, why I like this idea and why I think it's very good, especially in the cloud environment, because basically I just borrowed the idea of the microservices architecture, where it says that the access to the database is actually always done by the API exposed by the service that owns the database, right? So basically I'm saying I'm putting in the API the routing logic to correctly execute the query in the correct node. And this is not going to be a limiting factor, because in the microservices architecture, this is exactly what you are required to do. Anyone who wants to access your database should do it through the API you expose. But then at that point, let's use that API layer and make it more smart so that it can choose the perfect node to run the query someone is asking it to run, right? So that's perfect, and this is exactly what we are going to realize, and what you can actually see in action, not only during the demo I will be doing in a few minutes, but also in the GitHub repo that you can clone and fork and deploy in your Azure subscription. So you will have an application, this is an end-to-end solution, so where you have an API, basically a backend API. So we have an API layer. Inside the API layer, actually, let me use it. Inside the API layer, we have the routing logic that will be showing in a second. But anytime a query comes into the API layer, the routing logic kicks in, and depending on the color of the query or the tag of the query, it will send the query to the read-write replica, the primary one. Let's say that we have 4 cores here. But then if we have singleton read, maybe we have many, because we have several mobile application connected to our API layer to get data about, for example, let's say we are going to do e-commerce. So you want to access your shopping cart, right? And the access to a shopping cart is probably done millions of times per day in a very successful e-commerce. So, but each shopping cart is saved as a hybrid. Let's say it's saved as a hybrid document. Some columns, some properties are stored as columns because the schema is well known. Some other are stored as JSON. So we have one row that contains some columns, some JSON, but you always access it by the ID of the document or the primary key. So it's a singleton read. So you want to redirect the singleton read to 2 different replicas, starting with 2, but it's easy to add more. And maybe, of course, at some point, you also have a maintenance application or backend application that will access your API layer, and maybe you want to run some analytics or some complex query on the shopping cart. And so all this analytical and reporting query can be sent to another replica, maybe much bigger than the other, because here you're not going to do singleton reads, but you are going to do complex analytical query, and you don't want to use the resources of this replica and steal those resources from any of the other replica, right? And all these replicas are only the compute part of the database, because the storage is provided by this servers that we call page servers that will make all the data that is changed and updated by the read-write replica to all the replicas. So we are in the situation with all the replicas can see all the data. That's exactly what we wanted, right? Now let's go a little bit deeper into the API layer. So basically we will receive a request. It could be, a post or a get or a patch or a put request. We'll turn it into a query. Let's say we turn it into a select. And when we create the select query, could be using an entity framework, if you're using .NET, Prisma if you're using TypeScript, SQLize if you're using Node, SQL Alchemy if you're using Python, for example. And then you can create the query, and then maybe you can tag that query so that you tell the routing mechanism that you are going to build into your API that query is, a read query or a reporting query or a search query. And once you tag the query, you just need to load from somewhere in this specific demo that I will do. It will be another table in the same database, but it could be Redis, key value store. It could be a file. It could be whatever you want. That says that all the search queries, let's say that are the red queries here, can be executed on node 1 and 2. All the green queries can be executed in node 3 or whatever. So basically, you have a list that tells which tag can be executed on which node, and then the routing query basically only read the node and associated with the tag that is being executed, has been requested, generate a connection string, connect to the server, connect to the node, and execute the query. Easy, but very effective. So let me show the demo. I think it's very interesting. So let me go here. So let me just first of all here go. This is the address of the GitHub repo. Later it will be more legible and visible from in the slide, but I will share with you even later. And here you have everything needed. So you have the application and even a test application. Actually, you can just clone it as I did it right now. And in my application, I have a regular web app, .NET web app, where I have my controllers and I have a shopping cart controller. The shopping cart controller, as you can easily imagine, simulates a shopping cart where you can, starting from here, you can put your shopping cart, which is basically just some JSON data. Then you can get your shopping cart by ID. You can get shopping cart by internal property of the that is found in the JSON called the package ID, or you can search for any property in the JSON using, for example, full text search here. So I did search by term. And for all of these queries, sometimes here I will tag my query. Now, as you can see, the controller is super easy. Is always calling a query method. So let's take a look at this query method here. And the query method is super simple. So you will be basically the query method generates a procedure name that it has to call, and the procedure is in the API schema. It is created. The name of the procedure to call is created by using the verb of the HTTP request. So it will be get, for example, and then the entity name. My entity name in this case is the shopping cart. So if I go and take a look at the database, and here you have also the script, you will see that, for example, I have a get shopping cart. Let's take the get shopping cart, the basic one. Yeah, this get shopping cart is the storage procedure that will be called if a get request is received. And there is the important thing is this one here is when I start to create the connection to execute to call the storage procedure, I actually use this scale out service that returns to me the connection string. And that service is super simple, but super effective. It basically, so this is the get connection string method you showed before. First of all, I check if the connection needs to read and write. If it needs to write, I immediately return the connection to the primary. So in my application config, there is only one connection string specified, in this case, that is the primary, so where I can read and write. But then if I if I know that I don't need to write, I need to read, for example, I will get the connection string from here from a system storage procedure that I created. And this system storage procedure will return a list of available replicas. Now, in this case, this is the table that contains which replicas are available. Right now is empty, so this means that I always connect to the primary node, right? So we will see later what happened when I add more replicas. But this means that if I don't have any replicas, no worries. I always fall back to the primary, right? Which is great because it means that my application can run with one single database, one single node, or it can scale, excuse me, to as many replica I can add. So let me show you. So let's go here and first of all start the test application. The test application very quickly is a Python application that use Locust to simulate some workload. So I'm simulating getting, application getting a shopping cart by ID, or searching the shopping cart by some specific property or package, or adding a new shopping cart, simulating some complex shopping cart here. So let me start that. Let's go here. This is something that it will be deployed also with the repository you can clone. So let's simulate 100 users and with a spawn rate of 10, so 10 new user every second. And this will start to submit a request, and this means that here we'll start to get some data. Nice. And if I take a look at my shopping cart, each line represents a line in the shopping cart, so a product put in a shopping cart. The cart ID is an entire shopping cart. This is the user that created that shopping cart, and these are all the line of the product in the shopping cart. So since in the shopping cart I can have different product, I decided to simulate the fact that each product details is saved in the shopping cart as a JSON, which is typical, I would say, today's. And the JSON is completely random, but simulates a JSON that is not trivial, as this is complex enough to be potentially a realistic JSON, despite the fact that contains, of course, mock data. Okay, so what the solution we can deploy will do is that it will allow me to say, for example, let me go here. Let's take a cart ID. Perfect. I can go here and say, okay, I want to get my cart number 17817. Perfect. This is my cart, and in the API I created, I also return from which replica this data is coming from. Now, what I want to do is add more replica, because for any reason I decided, my workload is increasing and my database is not able to keep up with all the incoming requests. So I just want to create more replicas. So to create a new replica is super easy. All I have to do is do something like alter database, the database I want to copy, or I want to create a new replica from. What is the target server? In this case will be exactly the same server. The type of the replica I am creating. The specific replicas are called named replicas, and the database name I want to give. I already created the 3, so let me create the 4. And here you will see that I have 1, 2, 3 database. This is the database from where we are starting from. And as soon as the creation of the replica is done, which is in progress, should take something, overall should take a minute, probably less. But as soon as this is done, you will see it here. But in the meantime, I already prepared the replicas, which means, let's say that I want to use also these replicas, because now the replicas are created, but my routing system doesn't know it has to use it. I just need to add this replica into the configuration table. So what I have to do is insert something in this table, and that's exactly what I'm doing. Let's say I want for now to insert only 2 replicas. So right now, all the read queries will be sent to replica 01 or 02. Right now, if I have several replicas that can be used to serve the same tag, the same tag, I will just pick one randomly. And so I can go here in my sample, and now I can do send, And you see now that the query is coming from the replica number 02. Now, if I try again, it's random, so it will pick one of the two. So I simply and very effectively just spread the workload from the primary replica to replica 01 and 02. I didn't have to stop my application. I didn't have to scale up anything that, as you know, require a little bit of offline times. Few seconds, but still, maybe you want to avoid it. So with this technique, by simply allowing my .NET controller to using this scale out service to basically ask which replica are available to serve which tag, I can simply match the tag with the replica that can serve that tag, and that's it. Then I will just return the connection string for that specific tag, and my query will be executed on the perfect replica for that query. Now, I refresh the metadata about which replica are available every 3.5 to 2.5 seconds, just to randomize also the caching mechanism and to avoid to have what is called the thundering herd problem in case we have a lot of replica that every a fixed amount of time, like say 5 seconds, always ask for updated metadata. So we don't want to have that situation. So that's why we want to randomize the time when we refresh the cache. And this is working beautifully. My application is working perfectly fine. It's still running. So yeah, it's just working right now. Let's say that what I want to do is also support, because I noticed that, for example, a lot of people do search queries, and the search query, let me go here, for example, the search query is something like that. Get shopping cart by search, and let's take a term here that I can use, for example, this one. Let's say I want to search this and I discovered for any reason that this is somehow very resource intensive, and I realize a lot of people are doing this kind of full text search. I want to move the full text search to another server to offload the singleton read and write. What I can do, again, very easily is create or add to the metadata that the fact that I have a new replica. So right now, the new replica will be picked up by the scale out service. Then that will be used for any time there is a query marked or tagged with the search tag. So if I go here right now, if I try to search with a shopping cart, I would expect my result to come from replica 03. Let's see. No, sorry, I have to use the correct API. Actually, let's also search something that will probably return a value. Here we go. This one and this one here. Nice. So this search method has been served by the replica 03. Now I could use probably the creation of the replica 0 write 04 as finished. Let's take a look. Yes. So my replica now is available. So what I can do if I really want is go here, also add, let's say I want to increase the power that my search can use. Let's do that. And now in a few seconds, this will be available, and this will probably come by the replica number 4. Let's try. Here we go. Very nice. So this is very easy. No disconnection, no any problem. I can easily scale up and down. Now, what happens if I decide that I need to remove a replica, or for any reason I want to say, oh, I don't want to use the replica 03 anymore, or anything, right? So here in my application, I decided that I can just disable a replica, but for the sake of the example, I can just delete all my replicas. Just like my API doesn't know that there are any replica it can use. So what will happen is that these will start to be answered by the only replica available. So as you can see, I can easily scale out. I'm just adding replica as I'm speaking, or back to only one. So we are still completely abstracted away from the fact that we are using a distributed system, in the sense that I can always go back to only one node, but even because the only change I did is basically in deciding to which node to connect to, which is not a big change, right? But this gives me a huge amount of flexibility, because I can tag my query and I can decide where my query will be executed, which allows me, developer, to be in power of deciding where to execute my query, which is a huge difference than when I just send database to my query to a database and it will try to run somewhere. I don't have all the problem I discussed before right now. So the other important thing of this replica is that they are all available and visible in Azure. So for example, here you can see, let me refresh this page, and you will see that now we have 4 replicas. So let me show you where you can find them, and also how you can create and manage them from the portal. So DM nr name replica OLTP, here we go. So we have the 4th replica. This is the one I created. For example, I can click on the replica I just created. I can see, just a regular database, because this is exactly what it is a regular database, with the only exception that is bound to its primary database. So everything that this primary database will do in terms of updating schema, updating data, this named replica will also see. And this named replica, of course, is only a read-only replica. Here you have the connection string. And for example, I can go here to the replicas blade, and I can see all the topology of my replica. So this is the primary, and these are all the name replicas related to this primary. Let's go again, click here. Let's go to the pricing tier, and let's say that I want this replica to become, I don't know, 10 vCore. Apply. My application will not be affected at all, because I am changing another replica. So there is literally no interruption of service here, because I'm not doing a scale up of the primary. And then as soon as the scale up is done, I can add my replica back, for example, to my metadata. So let's see, this should take a few seconds more, but then I can add the replica 4 back to my metadata, and then my service will start to use it again. So I really love this architecture, because put me in power of deciding where to send my query, and give me all the flexibility I need to be able to sustain even the most complex scenario. Now, let's simulate a complex scenario, for example, since we are here. So let's say that at some point, for any reason, and again, this is something that you can also do because everything is in the example. Let's say that at some point I make some change to my application, so that one of the most used storage procedure, the one that serves the simple get request, now take let's say 30 milliseconds always to be executed, and will let's simulate a contention, so that we are trying to access all the storage procedure are trying to access exactly the same resource. So here I'm simulating a heavy contention by getting one lock on a fictitious resource called dummy, and holding that lock for all the time that the storage procedure needs to be executed, and for 30 milliseconds. So all the other queries will actually queue, right? So this means that if I do that, and the wrong database here. So let me go to this one. Yes, perfect. So what will happen is that right now, since I don't have any other replica to scale, this performance here will go down dramatically, because I artificially created a queue, right? Now the problem is that even if I try to scale up, since for how I created this problem, and which simulates many problems where the resources are so scarce that requests start to queue up because there are not enough CPU power or IOs able to serve that request. Well, you just have a queue that keeps growing, right? And even if you if you add more CPU, maybe you are IO bound, you can solve the problem. Or maybe you are simply holding a lock for, I don't know, 10 milliseconds, 30 milliseconds like that, because you need to do some complex operation, and even adding more power, it doesn't solve the problem. So what we can do is simply add a new vCore, a new node, because that node will be another source of fresh resources that will not be containing the same resource here. So what I can do here very easily, let's add a couple of replicas, and I guess that's it. Because now the GET request will be split across two servers. And you know what? Let's do another one. Let's say that we will use 3 servers to split the replicas. Now I have 3 replicas that will be able to serve my request. And here I would expect this to go back up to the original value, up to 100 and something, because now I have 3 replicas serving the request. So it's true that my queries are still queuing up, but they are queuing up in 3 different replicas. So I split the contention across 3 nodes. Again, I'm back to the original amount, and probably I can go even higher. I can, try to go to 200, and that's will probably go up, or maybe I need to add more replicas, maybe, right? And to add more replicas, let's see if this one has finished doing the alter. Yes, so I can go here, say that also my replica 4 will be used for generic read. So now I have 4 replicas serving the generic read, so this should be, yes, go pretty high. So that's very nice. That's very nice because without, requiring any offline time, any special maintenance, any additional work, we can easily scale out our database to serve, more requests, or to solve contention problem, or to guide the queries to the right node to run the most complex reporting queries you may have in your application without affecting the primary. This is really empowering the developer to create the perfect architecture, and I love this. So now back to the slide for a second, and then I will be done. What are the results? Well, you tell me. Do you like the result? I love it. I really love it because it's simple and it's super efficient. It works very well. And so you can just, you just can create a solution and maybe never use it. You always stay with 1 replica or 2. But then the day you need it, you can easily scale out without any problem. Now there is another thing that I'm pretty sure you will be interested in. If you use named replicas, you will be saving money. You will be having better performance and saving money. Why? Because named replicas are priced using what in Azure we call the Azure Hybrid Benefit, which basically allows you to give at least 30% discount, but up to 71%. So this means that the same amount of vCores, if used with just 1 primary replica, is more expensive than if you can use the same amount of vCores but split across named replicas. For example, having 16 vCore as a primary will be way more expensive than having, for example, 4 vCore replicas. So if you architect your application so that they can take advantage of scale out ability, you not only will be having better performance, but you will also be saving money, which is, there's not many things that can give you better performance and allow you to save money, right? So the conclusion is that taking advantage of the ability to scale out or scale out ability is a win-win. And the hyperscale, Azure SQL Database Hyperscale is perfect for this scenario thanks to the named replicas architecture, because it allows you to make this scenario very simple to implement. So what are the conclusions here? So just the important point for me of this whole discussion is, first of all, to start to kind of put this idea in your mind. Second, to make sure that you understand that you always need at least 2 connection strings in your application. 1 for read and write, the primary, and 1 for read only, because it's very, very likely that you're going to need the ability to send all the read-only query to a different server. It doesn't need to always be this case. This is the case in the sense that maybe you don't have a read-only server and you start only with 1 node, but if you have 2 connection strings, you can always then decide to split the workload between the 2 different nodes. So this is the least kind of, the new base for me. Like I will never create a cloud application that doesn't have at least two connection string. Now, if I only want to have one connection string in my app settings, that's fine, or my configuration setting, that's fine, because I can create, just like I did in my repository, a solution that reads from some metadata, in this case a table, or again, whatever you want, and create a connection string on the fly to be able to connect to the current replica. Now, the best solution is the one I think I created and presented here, is using the tag. So you can do a tag-based routing. But there is another solution that if someone would like to help me to improve this example, I will be super happy. What if not only you can create, you have new replicas, but you saw that I had to create named replicas and then add it to my metadata in order to make it available. But this means that I don't need to have my named replicas active all the time of the day. If I have a machine learning technique that can forecast when my additional replicas needs to be in place in order to sustain the workload, well, I can create the named replicas, let's say 1 hour before, when I expect to have the additional workload, and then delete it 1 hour later, for example. So I can elastically add and remove named replicas, even having better, cost to ratio performance. Where is the code? I hope you are interested. So the code is in GitHub. This is the address. So it's very easy to find. It's very well documented. You can just deploy it. It deploys the Locust solution. It deploys, of course, the API, and then you can just read the documentation, the database, and you can just play with it. The database, the sample is available on GitHub and also in the code samples in the docs.microsoft.com website. There are many other examples here. Take a look. I really enjoyed creating many of them. They range from GraphQL to geospatial to, of course, scale out like this one. So take advantage of all the resources we created. And of course, you also find the repository here. Having said that, I think I am almost perfectly on time also to start to answer some of the question.
Hey, hi, David Maria.
Yep.
Okay. There was a question, or it's not like a question, there was a Manish Larkani asking us where was the code, or where you're diverting your
Yep.
replicas.
Yeah. So this one here, so let's say this is a GET request, right? So the GET request is simply saying, I want to, run a query in database that will serve the GET request. So let's take a look at this query method here. The query method says, in order to serve the GET request, you have to call the storage procedure called API.get_entity. The entity name is defined here and is just the shopping cart, okay? So the get is just trying to execute this storage procedure here. Get shopping cart. Now, how do this logic will execute the query on the right replica? By connecting to the connection string that we want to connect to, and the connection string is returned by this service called iScaleout. Here we go. The scale out service that basically takes the input, the tag, and loads the metadata from this table here that tell us which replica can serve which tag, and return the database name. The database name is then used, if you take a look here, to basically take the connection string from the primary, change the catalog name because the server is the same in this case. But here I could have added the entire connection string if I wanted. Now I just put database name because all my database are on the same server, so only database was the variant thing. And so here basically get a connection string, change the catalog to the database we want to connect to, and that's it, return the connection string, period. So if you go back here to the controller query, now we have the connection string that based on the tag will tell us exactly which is the node we have to connect to and then we just run the query. And the query is using just a regular execute. Here I'm using Dapper, and which is just a micro ORM that simplifies my life because I can just run execute scalar and then execute the storage procedure, get the response, and I'm doing everything with JSON. So, for example, tselect return JSON. As a developer, I find easier to use JSON also to communicate back and forth and from the database, because then I can just do a JSON parse, and then I have my object deserialized or my JSON document parsed. So I'm also using JSON as a way to communicate from the tweet and from the database. Hi Simon, nice to see you. So Lakshmi, hopefully I'm saying your names correctly, but man, this is hard for me as an Italian. Too many consonants. I'm not used to that. He's asking if a replica means only computer resource and not storage. You are absolutely right. So when we say replica, usually we mention the computer replica. Storage is completely separate, is not affected by anything we did here. Yes. So that means that we are dynamically increasing the compute, increasing the replica. You are increasing the number of replicas, so you are not scaling up. It's not that you are going from 2 to 4 vCores on the same instance. You are having 2 instances, for example, each one of 2 vCore, for example. But then you can scale up and out each replica. So the answer to the question is you can basically do whatever you think it's best for your application. You can scale out and you can scale up. And I think that's the nice kind of solution that I'm showing right now. I hopefully explained the entire idea. But then download the GitHub repo and play with it. It's very easy. I try to comment as much as possible, and otherwise just ping me. I will be glad to help you.
Thanks for your clarification.
Sure.
David Maria. So it was a great, and a lot of people have got a lot of information regarding scaling of their applications, because database is the thing which points to all applications, where it runs a lot of queries and a lot of challenges, where it may have some lot of problems while running query, timeouts, those kind of stuff.
Exactly.
Hope this session is exactly perfect for all the persons who is getting uneasy with the database also, and they can scale up and scale out.
Yes.
So that's what the application and the modern application goes on. Sorry.
Yeah, exactly. Scale out is the key of modern application, right? So I think it's very important that database allows you to kind of follow that pattern.
As from the front end application to the back end application, everything scale out right now.
Yes. Amazing.
And thank you for your valuable time and for this kind of session. So hope everyone will be able to useful and able to scale out their applications at last. And thank you, David Marian, and have a nice day. Hope.
Yeah, you too. Thanks a lot for having me.
Thanks a lot. And I will be sharing out the screens tracking where you can send the feedback about this session, so you can check out in the post here and provide a feedback for the session so that it will help on your options as well. So thank you and all, and thanks for your questions as further. So we'll be taking up as an offline so that directly the speaker will be engaging with your questions offline. Okay, and hope we'll be going up for the next session. Thank you. Hi everyone. So we are up on the next session, which is regards to the modernizing our .NET application with Azure and .NET Core by Shailendra Chauhan. So let me invite him. Hello, Shailendra Chauhan. Very good morning.
Yeah, very good morning. How are you?
So I'm good. Hope you are doing good. And
Yeah, I'm also doing good.
I will share your screen and hope everyone able to see it. And the stage is yours. The-
Hi, everyone. So, welcome to my session Modernizing Your Existing .NET Application with Microsoft Azure and .NET Core. It can be .NET 5 as well as .NET 6. So, my name is Shalin Chauhan. I am Microsoft MVP, founder and CEO of .NET 6. So, let's get started with the agenda of this session. What the things we are going to discuss in this session. So, So here you are going to learn about what are the common challenges faced by the business if they are willing to migrate or let's say modernize their existing .NET application to the .NET Core or .NET 5. I will share here some valuable steps which you can follow to modernize your existing .NET application. So here I just divided these steps into mainly three sections like assessment strategy, what the various assessment strategy you can follow, how you can estimate the time to modernize your existing .NET application, and what are the various tools are available for migrating purpose, and how you will decide what are the various Azure services are there to host your application in the cloud. And finally, I will take your question. So what are the question you are having? Please note down. Even you can ask in between as well. I will try to give the answer of each and every question, whatever you're asking about uh, migrating the things to the latest .NET version. So let's get started with the session here. So if you're looking at what are the common challenges faced by the businesses, so I'm just mentioning here mainly two challenges here. Like first one is let's say you can have a question. Let's say my business is not agile enough because I'm having the application like you having the existing .NET application, but your technical team is saying we cannot change it quickly. The reason is here it's application which you might be running from last 10 years. It might be you build using the ASP.NET 2.0, 3.5, 4.0. It can be with MVC 5 as well on any version. But now the requirement is as per the latest trend. Again, the latest trend, the people are using the microservices architecture. The people are using the DevOps. So how these things we can implement? Because if you're willing to uh, put the agility in your business, so your code should be written, your the system should be designed in such a way it can adopt the changes quickly. So the solution of this problem is you should modernize your application to increase the agility. Until you will not modernize your application with the help of .NET 5 or .NET 6 or Microsoft Azure, you will not able to implement the changes quickly as per the requirement, as per the need of the technology. Bigger technology are changing quickly. So you need to modernize your existing .NET application as well. The next challenge we having here, let's say think about how can I think differently and accelerate the speed of innovation at my company. Because nowadays innovation is the key of the success of any business. So if you're willing to run your business successfully, if you're willing to beat your competitor in terms of services, in terms of facility, so you need to innovate it. How can I add the innovation to my product? So innovation can be added into the product only until you will not upgrade it to the latest things. So innovation nowadays can be added into your business very easily if you will start building your application by focusing on cloud. So what this time you need to take here, you need to build cloud native application to accelerate the innovation. So these are the two things nowadays the business are facing, which actually already using the older application of .NET. So it might be the .NET 4.x application, it might be the ASP.NET 3.5 application, it can be the ASP.NET MVC3, ASP.NET MVC4 application. So there such things are very important. So these are the common things we discuss here. Now let's have a look at what are the steps are available. So I just designed mainly three steps. What are the main three steps you can consider while modernizing your existing .NET application to .NET 5 or .NET Core? So first step is here about the assessment. So first of all, you need to look into your existing application, what version of .NET you are using, what version of SQL Server you are using, assess the workload detail, and try to figure out what are the complexity you are having at the code level, whether you are using the third party controls like Telerik, or let's say Dev Express, or let's say any the third party control are you using, and decide a journey. Are you going to convert the complete project into the .NET Core, or you just shifting it to the cloud only? So mainly there are two journey which I will discuss in the next slide. So first, assess your application. First, know about your application. What are the things we are using in our application? Based upon that, the things would be decided. The next step we having here, estimation. So estimation would be decided here based upon the journey. If let's say you are willing to migrate your ASP.NET 4.x application to .NET 5, let's say .NET 6. So it would be a modernization journey. If let's say you are not willing to change the code much, you are just only lifting and shifting the application to the cloud, it would be the second journey. So based upon the journey, you need to plan how much manpower I need to put over there for modernizing my application. What are the various cloud services we are going to use? So calculate the estimate budget as well over there. So I will share some helpful tool as well. Using that, you can calculate the budget for that one. So here I'm not covering the PaaS services mainly. My focus would be on the infrastructure service in cloud available. But it's an older application. We are not talking about here to building a new application. We are talking about modernizing your existing application. So I'm sure your existing application is running somewhere on a virtual machine. It is running on a physical server. So in cloud, what option are available? So in cloud, obviously we having the virtual machine option. So figure out how much core you needed, what are the generation you need of the virtual machine, so that you can able to host your application, you will be able to manage the workload, whatever you are having in your on-prem environment. Then the third step we have been here about migration. So you have now figure out what are the challenges you will face. You figure out how much manpower you're going to put over there. You figure out what are the various services we are going to use, virtual machine, whether we are using containers, and what are the virtual machine size we are using. Everything we estimated. Now start doing the real work. Now migrate your .NET application to the .NET 5. So we having some tools, we having some practices we need to follow and start doing the migration. So now let's understand each step in detail. So I'm just going to start with the assessment. By looking at the assessment, the migration journey would be decided. So here I just created here a simple table for you so that it will help you to decide the journey. So here I'm taking the example of, let me open my highlighter. So what I did here, I just covering here, let's say you having application in ASP.NET MVC 1.0, or it can be 2.0, 3.0, 4.0, 5.0. So this application, let's say you're willing to migrate to ASP.NET Core. This is your target. This is my source, and this is my target over here. So my target is here ASP.NET Core. So what I can use over there? So here for hosting your application, you can use containers as well. In the containers, you can use Linux container because the ASP.NET Core application can be hosted on the Linux. And guys, when I'm using the .NET Core, my here I'm pointing to the .NET 5 or .NET 6. because the .NET Core name is only available till 3.1. Starting from 5.0 release, they just using the .NET 5 only. So Linux container is option over there because the ASP.NET Core application can be hosted on Linux as well as Windows. Here, Linux is the option you can use. Then we having the another scenario. Another scenario is, let's say you're having MVC again 1 to 5.2 application, but this time you're using SQL Server as well. So here you can target here SQL Server either 2017 or 2019. So benefit of 2017 and 2019 is here also you can again target the Linux. Because starting from the SQL Server 2017, now SQL Server can run on the Linux machine. You don't need to have the Windows machine over there. So this is the way how the .NET 5 or .NET 6 based application we can run on the Linux container along with the SQL Server database. There is a third scenario. So first two scenario are going to fit with the Linux and the Linux container over there. The next case is here, let's say you're having a SQL Server running on a Windows machine. Okay, so now here you can target the SQL Server 2017, 2019 if I'm willing to use the Linux one. So here again, we are using the SQL Server Linux addition with the Linux container, a Linux virtual machine you might be using over there. Then we having here again a next case. The next case is here, we having again MVC application from 1.0 to 5.0 with Web API. But this time, I'm not using the containers. I'm using the virtual machine. Or you are not willing to use the container for hosting your application. You are willing to use virtual machine only. So you can go ahead with virtual machine as well. So in the first case, I covered the container scenario. Now I'm covering the virtual machine scenario. So in the virtual machine, you can go ahead with the virtual machine for Linux as well as Windows. So it's up to you, whatever virtual machine you're willing to create. You can go ahead with Linux as well. You can go ahead with Windows as well. It's your choice. If you're willing to go ahead with the containers, in the container, Linux is the first choice in the container-based element when it is coming as a SQL Server. So these are the options available for the virtual machine. So in short, you having the choice to use either containers or you having the choice to use either virtual machine. If your application is running with ASP.NET MVC 1 to 5.0, and if you are targeting to completely migrate your application to .NET Core, remember it. I'm not talking about here to target the ASP.NET MVC 5. I'm changing it completely. I'm just changing it from 4.x .NET framework to .NET 5. So that's why it is able to run on the Linux one. Sorry. So if you're looking at how we will decide here the other things here, let's say I'm not willing to change it into the .NET 5 because it will take a lot of time. Obviously, when you are, if you build the application using ASP.NET MVC 3, I need to convert into the ASP.NET Core. So entire code, so many things need to change over there. So how do we have any other option for migrating the things to the cloud? So another journey is here, lift and shift journey. So first journey name I have given here, modernization journey, where I'm completely migrating my .NET Framework 4.x application to .NET 5 or .NET 6. Now what I'm doing, I'm not changing the code, I'm leaving it as it is, but I'm just using here cloud. So that is a lift and shift journey. So it is the easiest way to migrate your workload from on-prem to the cloud, because here you are not changing the things much. You just integrating your cloud services over there. So in this case, we also having some cases. The cases here, look at the source. So source is also same and the target is also same here. If you're looking at here, I'm targeting here MVC 1.2 5.0 release, and here also I'm targeting MVC 1.2 to 5.0. It is might having the WCF SQL Server. Again, here also it having WCF SQL Server. So what you can do here, you can just upgrade the .NET Framework version from 4.5, like 4.6 to 4.8, and you can run it on the Windows container. because Windows Container support the SQL Server, what are the features you are using in your on-prem environment. If you are not using the SQL Server more set of features, it can be used as it is over there. It is a lift and shift approach. I just lift my application from the on-prem environment and shift it to the cloud. Similar way, you can have a ASP.NET Web Form application. You can have WCF, you can have SQL Server. Target is also same here. You are not converting it to the .NET Core or .NET 5, and it might be running on .NET Framework 3.5. So here you can use again the Windows container. Okay, this is a Windows container approach. So here I cannot use the Linux container. The reason is here the .NET Framework 4.x application I cannot run on the Linux. I need only Windows machine. So that's why I mentioned here Windows container as an option. Same option we having here for .NET Framework, IES, SQL Server. So these things are available with Windows container. So this is the way we can lift and shift our application to the cloud with the help of Windows container. So these are one option using the Windows container, it can be done. But if let's say you're not willing to use Windows container, you can go ahead with the virtual machine as well. So next option we having a virtual machine. So now this is the option available here where I can use Azure Windows virtual machine. So what are the workload I'm having in my on-prem environment? Let's say I'm having a SQL Server, .NET Framework. I can have a legacy .NET application. You might having the .NET Framework 2.0. So those type of application also, I'm just going to target with Windows virtualization. So I can use here Windows virtual machine directly. So these are the two journeys you need to keep in the mind, whether you are modernizing, whether you are just lifting and shifting. Based upon the journey, the effort you have to estimate, the manpower you have to calculate, and the estimate you have to decide. I hope this will help you to understand. So this is about the assessment. Now let's understand the .NET version based the .NET version based complexity. The thing is, let's say I'm just going to migrate my existing .NET application .NET 5. So how I will calculate the complexity, like how complex the process would be over there. So here I just created a table based upon the complexity. If let's say you're having a application with .NET Framework 4.8, 4.7, so if your application already targeting this version, so it will have the low complexity in migration. So let's say it is targeting 4.6, 4.5. So complexity level you can mention here too. So let's say it is targeting the .NET Framework 4.0, so complexity level would be 3. For 3.5, it would be 4. For the 3.0 and the 2.0, and it would be very high complexity. So based upon the targeted version, you can decide your application complexity. You will have the idea how much effort you are going to put for migrating that application. So this table definitely will help you to understand your application complexity if you are going to decide to migrate it to the .NET 5 or .NET 6. Similarly, we can decide the complexity with respect to the SQL Server version as well. So ultimately, for managing the database, I'm sure you are using the SQL Server. So how the SQL Server complexity is going to be decided? If let's say you're already using the SQL Server 2017 or 2019, so it would be low complexity. You can easily migrate it to the cloud. There is no much challenges. If let's say you're using SQL Server 2016, 2014, so I can say the complexity level would be 2. For 12, I can say it would be 3. For let's say 2008 out, it would be let's say 4 over there this way. If let's say it is here, is it SQL Server 2005, 2008, it would be here very high complexity. So these things are very important to decide the estimate. So in the estimation, these things are very important. So this is about calculating the complexity of the application or calculating the effort over there. So now the question is here, let's say now we have decided the complexity, we have decided everything. So do we have any tools which can help us to migrate our .NET based application to .NET 5 or .NET 6? Yeah, obviously we having some tools so the tool name is a .NET Portability Analyzer. So .NET Portability Analyzer will analyze our application code and will let us know what are the things are supported in .NET 5, what are the things are not supported, like what is the percentage of code can be reused, what are the percentage of code you need to rewrite. Everything the .NET Portability Analyzer let us know. Even we can use a porting assistant for .NET as well. So there is another tool available, porting assistant for .NET by AWS. So the AWS team created the porting assistant for the .NET based application. It provides us the similar detail as the .NET Portability Analyzer is providing to us, like how much code can be reused, what are the APIs cannot be reused, what are the code you need to reuse. So it can be decided from the porting assistant for .NET. And if you're willing to migrate the things, so we having a .NET Upgrade Assistant. It's a CLI based option available. Even now we having the Visual Studio 1 as well. So Visual Studio extension also available now. So using that, the existing .NET 4.x application, I can upgrade to the .NET Core. Ultimately, it should not upgrade everything, but it will upgrade the target framework. It will do some necessary changes at the code level so that your application is now compatible to run on the .NET 5 or .NET 6. But you need to fix the API issues as well, because API issues is not going to fix automatically itself. So I will show the demo of all these three options so that you having the clear picture how we can decide how much code of our application can be reused into the later version of .NET 5 and how much code we need to rewrite. So these things are very important to understand before migration. And when it is coming to the database migration, so for the database migration, we having the DMA. So DMA is a data migration assistant. Using that, we can migrate our SQL Server 2008, 2005, and 2012 our database to the Azure. So Azure SQL, we can target here with the help of DMA and migrate the things. So first three options are migrating your .NET Core. The last option is about migrating your SQL Server database over there, simply. So now let's understand what is the .NET Portability Analyzer. So .NET Portability Analyzer will let the API missing for the application libraries to be portable. It can be used as a console application or as a Visual Studio extension over there. So these are the link I'm sharing with you from where it can be downloaded, the console app, or from where it can be downloaded the Visual Studio extension. Using that, it can be analyzed and do the things over there. Let me show the example of here how we can use the .NET Portability Analyzer. So I'm using here Visual Studio 2019, where I have already installed the .NET Portability Analyzer. And here I'm already having a .NET 5 application, not the .NET 5, sorry, it's a ASP.NET MVC 5 application. Let me open that solution, which I created to explain the things over here. So this is my folder. So I'm having a ASP.NET MVC 5 application where I'm targeting the .NET Framework 4.x. So it's a just a demo application where I'm having the various layers here. I'm the application core. I'm having the domain models, repositories, some services. I'm having some UI. And if you're looking at the target version of this framework, so this targeting here .NET Framework 4.5. So all the projects having the same target framework, they having the .NET Framework 4.5. Now the requirement is here, I'm willing to modernize this application with .NET 5 or .NET 6. So as I said here, we having a link from here, you can download the .NET Portability Analyzer tool. So this is the link I can use here to download. Even I'm just opening it so that you can go over there. So let me show you my browser here. So this is the link from where it can be downloaded. So download it. If you need the link, I can share with you. Okay. So I'm having this one now. After doing this one at the solution label, you need to just do right click, then you will get the option here, portability analyzer setting. Even here we having the option here, tools and the option. After downloading and installing, you need to set up it. Otherwise, you will not get it over here. So there is option available here, .NET Portability Analyzer. And here you can decide which framework you are willing to target. Are you targeting .NET 5? Are you targeting .NET 6? So right now we having the .NET 5 only in RTM. I'm sure after when the .NET 6 will release, you will get the .NET 6 as well. So decide your target platform, .NET 5, .NET Core, 3.1. Okay, so from here it can be decided, the target platform. So in my case, the target frame platform is .NET 5. And now decide here in which format you need the report. I need the report in Excel format. I need the report in HTML. So this setting you have to do here. From here, I just did these two setting already. Now just do right click. Now there is option here, analyze assembly portability. Just click over there. So what it is doing here now, it is analyzing my application for compatibility with .NET 5. And after that, it will generate a report. Okay, I think something is missing. So hold on. So Angular is creating the issue over here. So let me try again. Let me build the solution first. Okay, so what are the one thing I need to exclude? Let me exclude this client folder because it's a Angular based folder. I don't need it. In fact, I'm excluding this one. Now let's build it. Okay, now it's building successfully. There is no issue. Let me do right click here. And here we having the option. Analyze the port assembly portability. Now it is analyzing the assembly portability. It's generating the report now based upon the project. So what it did for us, it's created here HTML report. It's created here a report into the Excel. Let me open the HTML report here. So this is my HTML report has been generated based upon my code. So you can see here, I'm having a library application core. So application core is a project. It is 100% supported in .NET 5. I don't need to do any change over there. When it is coming domain model, in domain models, the portability percentage is 98.18. You can see here. When it is coming to the repository layer, it is also 100% portable. I don't need to do any change. When it is coming to the another layer here, service layer. So service layer can be migrated to 73.68% code can be reused. So you can see it's a very good tool here, which will give you the exact percentage, how much it can be reused, how much you need to convert it. Now let me show the one example, what things are not supported. Let me take the example of this domain models. In domain models, what are the things can be used, what are the things cannot be used here. If you're looking at here, Newton soft is supported here in 3.1, but in 5.0 it is not supported. If you're willing to target it with the .NET 5, just target the .NET standard platform. The next setting we have in here, Newton soft reference loop handling. This setting is perfectly supported in 3.1 and the .NET standard 2.0, but in 5.0 is not supported. So you can see here what is supported, what is not supported. That is completely letting us know. Then there is a namespace available here. This namespace it's supported here in .NET Standard, but not supported in .NET Core and in .NET 5. So complete detail it is giving to us. What are the namespaces need to change? What are the options are not supported? Everything is there is a detailed explanation about your code compatibility. So this is making our migration journey very smooth, very simple. I don't need to put much effort over there to understand the concept. I need to just analyze it and figure out what is supported, what is not supported. Similarly, let's look at the MVC at the UI layer as well. This is my UI layer where I'm having the system.web.http application. So this is not supported because this namespace, this assembly is not supported with .NET 5 and .NET Core. Simply the web HTTP context not also supported. The cookie is also not supported here based upon this namespace. I'm not saying the cookie is not supported in .NET Core. Cookie is there, but cookie available on this namespace not there. The namespace there has been changed. You can see here its complete information is available here. So this way I can analyze it here using my portability analyzer. There is a one more tool I want to show you here. That is again very important. The next one we having here AWS porting assistant for .NET. So we having a tool from the AWS team as well. Now the AWS team launched this tool as a Visual Studio extension as well. This is the extension URL from where you can download it. So I have already downloaded it. So I'm having here the AWS porting assistant. It's a porting assistant for .NET. Open this application. So here for doing the assessment, make sure you're having an account on AWS cloud, and from there you need to set up the thing. So those things actually I already set up. I'm already connected with my AWS account over there. Now there is option available assess a new solution. So I'm just going to click on assess a new solution, then select the file path where my solution is exist. So this is my location of solution. Let me copy it. I'm putting here. Now just select the solution file. This is my solution file. Now analyze it. So what is doing here is going to analyze my project solution, and after the analyzing it will generate a report to me. Same way as I got the report in using my Visual Studio 1, same way it is going to generate the report here. So let's wait here for a couple of minutes. After that my report would be generated. Meanwhile, if you have any query, you can ask. If somebody having the query, you can ask through the chat window. It is analyzing the solution and generate the report. Okay, meanwhile, what I can show you here, I can show you what are the things I already analyzed. This is the analyze things I'm already having. So here also you can see here in the application core layer, there is a one incompatible package. So out of 25, you can see complete detail is available here. 19 API are incompatible here. And if you need the detailed information, I can open the application core. And you can see the entity framework version 6.1.3 is incompatible. So suggested replacement is 6.3. Means upgrade your solution to upgrade the entity framework version to 6.3 at least. This is the project reference where this is going to use. This is the complete the dependency graph is coming here generated by this tool. These are the various APIs are coming which are using in entity framework 4.x, and these are the source file where changes actually you have to do. It's a great tool. I like it because it is generating me the detailed information in which file I need to do the change, and what are the NuGet packages are not supported. Even it is suggesting us some things as well, let's say, which I can replace over there. Let me show the another example where I already analyze my UI layer, because this is important over here. In the UI layer, you can see Bootstrap is compatible here. This package is not compatible. Alma is not compatible here. jQuery is compatible. ASP.NET MVC version 5.2.3 is not compatible here. Complete information it is giving to us. This is the project references, fine here. These are the APIs. So this API not supported here using these packages. So these packages you need to change. If you're willing to modernize your MVC5 application to .NET 5 or .NET 6 using ASP.NET Core. These are the source file where you need to do the changes, you can see. So it's a great tool. I like it when you are migrating the things over there. So this is about the .NET porting assistant we have. Now the next thing we having about the estimation. Now you having the complete idea and understanding how much effort you are going to put over there, because we already analyzed the solution. We already figure out what is the percentage of APIs can be reused and how much code we need to change. Everything now you assess already. So now we can estimate the manpower, we can estimate what are the compute services we need to use over there. That is coming the part of the estimation. So for estimation, when it is coming to the Azure, we having the Azure pricing calculator. So with the help of Azure pricing calculator, you can calculate the pricing of using a Microsoft Azure service. If let's say you're willing to use virtual machine, so you can calculate the pricing. Let's say this size virtual machine having 8 GB RAM. So whatever the on-prem environment virtual machine compute power you are having, I suggest you use the same compute power in the cloud as well and try to calculate the estimate over there. So this one will give you the estimate budget which you need to have to run the application in the cloud over there. Another one we having a total cost of ownership calculator. This calculator is also helpful if you're willing to differentiate between the on-prem budget and the cloud-based budget. So you can see in the left-hand side, this is the costing you having. Let's say this much costing you're putting for running the same application in the on-prem environment. If the same application you will run in the cloud, so this much of amount you can save over there. It's a comparison of on-prem environment costing and the Azure costing, because some people think about Azure is costly, but it would be decided how you are using it. So understand to use it wisely. If you are using it wisely, you will find out the Azure is not costly. Even your on-prem environment is costly than cloud over there. This is the way these two things really help you. Now we having the last step, that is about migration. How we can migrate the things? First we did the assessment using the tools, then we estimate the budget, we estimate the manpower. After assessing the code, after assessing the code compatibility, now we are ready to migrate the code. So for migration, I said you have to decide the journey. Which journey you are selecting? Are you selecting the journey of lift and shift? In the lift and shift, you are not changing the code. It would be as it is. This is the lift and shift journey. Second, the first journey was here, modernization journey. In the modernization journey, actually you are migrating your code to .NET 5. So that will take time. So for migration journey, or I can say for modernization journey, you need to use tool .NET Portability Analyzer, .NET Upgrade Assistant to do the migration. Even the same I just showed to you. Let me show the example of .NET Upgrade Assistant. How actually I can upgrade my ASP.NET MVC5 application to .NET 5 with the help of tool. So these are the set of commands I mentioned over there. This is a set of command you need to run on the command prompt to upgrade your ASP.NET MVC5 application to ASP.NET Core 5 or ASP.NET Core 6 over there. So for following this one, make sure you have downloaded the .NET 5 SDK or .NET 6 SDK, whatever the version you are using over there. And after installing that one, you need to run this set of command. So first command into run is here. First install the tool. Second is here install the upgrade assistant. Then run this command upgrade assistant. Upgrade is the command name here, then the solution name over there. So this is the final command. You're just going to run it here, and after that you will get the screen like this way. So let me show you here how it can be done. So I'm already having a solution. This is my solution where I can run this command over there. So upgrade assistant, sorry, MVC5 app. So I already opened the command prompt at the same location. So my solution name is MVC5 app, MVC5 app dot SLM. So what it will do here, it will now upgrade my ASP.NET MVC5 application to, okay, let me see, solution name is different, SLN, okay. So MVC5 map, let me copy. Okay, so the thing is I need to go inside first into the MVC5 app folder, MVC5 app folder. I was not inside that folder, that's why I was getting the error. Now let me run the same command again, and this time I'm inside that solution. So what it is doing now, it is upgrading my ASP.NET MVC5 application to the .NET 5. Now you have to just follow the step. So next step is just select an entry point. So entry point, it is asking to select. So these are the application layer. If you're looking at what are the various projects I'm having, these are the various projects I'm having in my project, in my solution, sorry. Application core, domain models, repository, service, and UI. So decide the entry point from here. So I'm just deciding here, let's say, I'm just going to start with one. So now press enter to continue, enter it. So now just press 1. Now it is asking me first you need to upgrade your domain models layer. Then upgrade the application core layer. That's fine. Let's first upgrade my domain models layer. Enter it. So it's did the upgrade. Then again next one. Now it is asking me, do you want to create a backup before upgrading? Obviously you should create the backup before upgrading. So it is giving me the default location for creating the backup. Go ahead with the default location for creating the backup here. Enter it. Now press continue. So backup file has been created. Now it is ready to upgrade it to the .NET 5. Now it is upgrading. So you don't need to worry about what are the new get packages are you are using, what are the target framework you are using at the project level. It automatically upgrade. It is going to simplify the process of upgrading. You don't need to do the manually upgrade. Do it through the code. Do it through this command prompt, and you can easily do it. I'm pressing enter. Just do follow. It's a simple step. Enter continue. It is updating my NuGet packages. You can see the entity framework version. It now upgraded from 6.1.3. You can see here what it is doing. This is my older version of entity framework version. Now what it did here, it just upgraded it with entity framework version 6.4. It's great. I don't need to upgrade it. Automatically it is upgrading to the 6.4 that is compatible with .NET 5. What it is doing, it is removing the package of system.web. So everything it is doing itself. The things which are not comfortable, it is removing. The things which are compatible, it is upgrading to the latest release over there. Enter it. Then one, press enter, one, So these steps you have to follow for each project, whether it's a application core layer, it's a domain model. So you can see now domain models layer of my code has been upgraded to the .NET 5. Now it is asking me to upgrade application core. Let me upgrade application core as well. Same way, take the backup, enter to continue. It is upgrading. Press enter to continue. Now it is going to clean up the NuGet packages. So now it is upgrading my second layer, that is application core layer. So here also it is doing the same thing. Enter, and then next, continue, continue, continue. So now you can see the upgrade has been completed. So finally I'm getting a message, the upgrade has completed, please review any change. Now let's look at the changes, what it did for us in this upgrade process. So the thing is, what are the solution actually I already opened, now it has been changed because it has been upgraded to the .NET 5. Let me reload them. So when you will reload it, now you will start getting the error because so many APIs are incompatible. Even the same list I share with you. So you can see here the application core properties. What is the target framework? It is now .NET 5. Great. So upgrade has been applied to the application core layer. Same thing you will get in the domain models properties. It is .NET 5. If you remembered when I opened the project first time, that time also I just shown you the target framework. It was .NET Framework 4.5, but now it is .NET 5.0. Same thing you will see for repositories. It is still 4.5 because if you remembered, so far I upgraded only these two layers, application core and domain models. I have not upgraded repository, service, and UI layer. So if we build the application core, and if you remember, the application core layer is 100% comfortable. So here only one thing is not compatible, that is coming from the domain models, not from the application core. Because in the domain models, there is a property I posted file base. This property is actually creating the issue. If I will comment out here for a while, and if I will run this code, which I upgraded to .NET 5, it is building correctly. Let me build the application core. So both the project has been successfully upgraded. Only I need to find out the alternative of this one in ASP.NET Core. Same thing, the same report I just shown to you here when we did here using the AWS. So here if you look at the application core, only one package is incompatible here that we already upgraded. In domain models also there is a one package that we already upgraded. So these two things don't have much challenges in upgrade process. It's working fine, perfectly. So this is the way how you can upgrade your existing application to .NET 5 with the help of this upgrade assistant. Now let's talk about the database migration. So for database migration, we having the DMA. So DMA you can download from the Microsoft Azure website. I'm going to install it. So let's say I'm opening the DMA, data migration assistant. I can open it. And what are the on-prem database you are having? It can be SQL Server 2005, it can be 2008. It is having the support actually from the 2005. Before 2005, it's not have the support. So if you're having the 2005, 2008, 2012, 17 version, it can be done. So I'm not willing to upgrade it. Let's go ahead as it is. So this is my data migration assistant. Here I can make a connection and just define the project name. So project name is, let's say, migrate local DB to cloud. I'm just mentioning this one. The assessment type is here database engine. It's fine. It's not assessment, it's a migration actually. Source a SQL server. What is the target server? Target server is here Azure SQL database. I'm using here Azure SQL database. Even you can use SQL server on Azure virtual machine as well. You can use SQL server. I'm just using here Azure SQL database. Create it. Now just do mention your source server detail. So what are the uh, local SQL server I'm having? I need to mention that local SQL server login detail over there. So I'm connecting to this one. This is my local detail, local server I'm having here. Now let me connect it. Then password we having here, connect with it. So what are the local database we having? It is giving to me. Let's say I'm just using here Adventure Works LT 2019. Go to the next label. Define the your target SQL server detail. What are the Azure SQL server you are having? You need to mention over there. So you can have a SQL server in your Azure portal. From there, you can connect with it. So I need to go to here portal.azure.com, and here you can create a Azure SQL. So I'm creating here SQL database. Let's say I'm using here DNT RG101 DNT SQL 101. So create a new server here. So this is the way the server we are creating here. Says admin password. I'm just putting here what I needed. Then click. So this is the way. I'm just going to mention public endpoint access from the SQL Azure, my current IP. Click to the security, and that's fine. Now let's create it. That's right. So this is my Azure SQL database. I'm going to create it. I need to just connect with this SQL database, and after that, what are the local things we having, we can migrate everything over there. Meanwhile, guys, if you have any query, please do ask. Because the session, I'm just going to wrap it now, because everything we discuss, how we can find, how we can assess the thing code, how we can estimate, and how we can migrate is the last things I'm just showing to you here. So guys, it will take some time. Meanwhile, you can ask your queries if you're having. So this has been created. I can connect with it using the connections. This is my server name, which I can mention here. SQL Server authentication. This is admin. Then password. Then connect with it. I'm connecting to my target Azure SQL database. Okay. It is in progress. It will take some more time. After that, I will able to connect it.
Hey Shailendra Chauhan. So hope that was not
Yeah, hi Lakshman, how are you?
hopefully I have some doubts. So okay. May I know what's the challenging things while migrating the existing projects to the new one? What are the main constraints where we need to consider? So that a lot of
Actually,
people
the
will
main
face.
challenges here you will get it. First of all, you need to figure out your migration journey. Whether you are doing the modernization, whether you are just doing the lift and shifting. Based upon that, the challenges you will have. So first decide your journey based upon that, the challenges you need to face.
Mm, fine. Thank you. Thanks for the answer.
Now it is connected in my case. Click on the next button over here to migrate the things. It is coming to prepare the source database schema. And you can see we having the SP, we having the tables, everything it is showing me. What I'm going to migrate to my Azure SQL database. Now from here I can generate the SQL script. So the SQL script has been generated. Now there is a button here to deploy the schema. Click on the deploy the schema. It is deploying my schema to Azure SQL database. And if you will face an issue, any error while executing the SQL command, those errors you will get it over here. So this is a tool. Using that you can migrate your existing database to the Azure SQL. And after doing the schema migration, it will ask me to migrate the data as well. On the next window, I will get the option to migrate the data as well. So depending upon your database size, it will take the time. If somebody having a huge database, so we having a paid service in Azure, that service can also be used. So in my case, I'm not getting any error. The reason is here, my local database already targeting the SQL Server 2019, so that's why I'm not getting the error. But if your database is having the older version of SQL Server, I'm sure you will have some incompatibility. Those things need to fix out. You can see database has been created successfully in my case. You need to just click on the migrate the data. So data migration would be done easily over there. So I have done from my side. Yeah, thank you, Lakshman, for providing this opportunity. Yeah,
Mm,
now you can proceed.
thank you. It was a great session. So that a lot of the people is able to migrate that legacy applications to the latest provisions that they can get started and having a new scale of applications as going forward, as we will be looking forward to the .NET 6.0 so that they will be compatible enough to get their applications up and running. I think so. And thank you for your valuable time on the session. So hope you've been able to got engaged and got to learn a lot. And thank you, Shalendra Chauhan, and it's a pleasure for you having a session like this.
Yeah, thank you.
And thank you. So thank you. And so on up of our next session, we are gonna see what a life at iMerge before and after AKS, which is Azure Kubernetes Services, which will be presented by Vishal Madan, and I've introduced him, Vishal Madan. And thank you for coming for Azure Dev Conference. Sorry, I can't hear you.
Oh, sorry. Am I audible?
As you are audible, thank you. And
Okay,
the screens will be get shared so that we
sure.
can get. And the stage
Uh,
is yours. Thank you.
Lakshmi, is there a way I can see the presentation and myself at the same time?
Yes, probably I can just check out the YouTube videos
It's
and
okay. It's okay. Don't worry. Don't worry.
yeah.
So good afternoon, everyone. Good afternoon, Lakshman, and good afternoon, everyone, or probably good morning, good evening, depending on where you are in the part of the world. So welcome to this is track six, day two. Lakshman, I believe it's the third session of the day, third or fourth.
Yes, it is the third session of the day.
Okay, great.
Third session of
So,
the day.
guys, welcome again, and just going over the sponsors of this particular event. So we have EY, we have Microsoft, and we have Elastic.io as a community partner. A quick introduction about myself. I'm Vishal Madan, a total of 21 years of experience. I currently head the engineering at iMocha. So something about iMocha. So iMocha is a world's largest skills assessment platform. We help our clients either in the recruitment space or in the L&D space to either recruit candidates, which means that we are not a staffing company for sure. What we do is that once the sourcing has been done, uh, our skills assessment platform can help filter out the candidates that have come from the sourcing to the point that they are funneled into the interview process. Also, as I said, that our platform can be used for L&D use case also, which means again we are not into content. iMocha is not into content, but once you deliver a learning content to your employees, to the client's employees, for example, how do you justify whether the learning program is successful or not, right? So the learning program followed by a pre-assessment. I mean, prior to the learning, a skills assessment just to check the skills before the learning program, and a post assessment after the learning program ends to justify whether the learning did provide any value to the employees or not. That is where the iMocha platform comes into picture. Uh, so let's quickly move. So today I'm going to talk about life at iMocha before and after the AKS, which is Azure Kubernetes Services. Before I deep dive into this, I would like to apologize because I was working on a demo environment and the demo and everything was all set yesterday night. But somehow to help the audience learn more from the demo, I tried to do something and something broke and I'm not able to recover before this particular demo. So I have to be a bit theoretical in this particular session, but I'll make sure that once the demo environment is ready, I can capture a video and I'll take the help from the Azure Conf organizers to share the demo with whoever audience was part of this particular session. Okay, so please accept my apologies, but I'll be there for the Q&A. So in case there are any particular questions that you have, I can answer it right now, or I can defer the answer and I can answer it later at a later stage. So let's start. Lakshman, would any particular question and answers in the chat window would be conveyed to me, because I'm not looking at the chat window right now.
Hi, Vishal Madan. So it will be conveyed to you or a chat window, so you can able to have a look. So hope if there was any of kind of question, I will put the screens into on your concern. Okay.
Sure. Okay, fine. Okay, great.
Hope.
So let's start. So guys, this was our life before the AKS, I would say. Okay, now when I said that we are into the recruitment use case wherein the skills assessment can be used for filtering candidates after sourcing till the interview funnel. Now the hiring can be of two types. The hiring can be a lateral hire. The hiring can be a campus drive, right? In the case of a lateral hire, for example, uh, the concurrency that most of the laterals taking, I mean, a lot of laterals taking the test at the same time. Uh, is not much, because uh, the sourcing happens, and then the recruiters talk to the candidates, and then they send out the skills assessment to the candidates, and the candidates can take their own time within 3 days period of time, or 4 days or 7 days period of time to give that particular test. So that's where though the concurrence is there, the concurrence is not that high. The problem happens when we have a campus drive, and during that campus drive, almost 1500s, in some cases, even 10,000 candidates, and in some cases, even 15,000 candidates might appear the skills assessment on the iBoka platform at the same time. So it might happen that a particular skills assessment, a campus drive is going in multiple campuses, for example, multiple colleges or multiple campuses of the colleges at the same time. That is where there is a lot of load put on a system. And what has changed slightly because of the pandemic situation is that prior to the pandemic situation, this campus drives were conducted in college. That means the remote proctoring was switched off, right? There was no proctoring required, because there was a invigilator in the room that was conducting that particular campus drives, and he was there to check whether there is particular uh, cheating being done by any of those candidates, kind of thing, right? But when these campus drives are now being conducted remotely, there is an additional ask, which is the proctoring ask. And with the proctoring, for example, there is additional load put on a system. So what was happening before we went for AKS is that every now and then we used to get a notification from the customer success team saying that our client is having a campus drive of almost so and so candidates, let's say tomorrow. Okay, now tomorrow is still a good amount of notification, advance notice, right? But sometimes what used to happen is that it used to come, let's say, a few hours before, because even the customer success guy did not have an information about such a drive, for example. So in this particular manual notification, there could have been any particular point wherein somebody forgot to tell someone something, or the communication or the information that was given was not correct. So instead of 15,000 candidates, for example, only 1,500 candidates were communicated, right? So what we used to do after every such communication is that we used to check whether our infrastructure at that particular point of time when the campus drive is going to happen is good enough to sustain that particular campus drive. Now, in case any information is incorrect, let's say number of candidates, number of campus test takers, the number goes high, okay, then also that the infrastructure that we had, for example, sometimes would not cater to that particular campus drive, wherein we had to, during the whole campus drive of 2 hours to 3 hours, for example, uh, our whole technical team, the support team, the customer specialist guy, for example, would have to be on the call, and we had to do any background corrections on the infrastructure while the campus drive was going on. But in this case also, I mean, in case most of you know that even if you're spinning up a virtual machine, for example, it does not spin up immediately, right? So even if we come to know that this particular current infrastructure is not sustainable, we have to add additional virtual machines, or we have to scale out the virtual machines, for example. It takes time. and which means that some of the other candidates during this campus drives were impacted, which resulted not only in a wrong branding of IMOCA, it also resulted in a wrong branding of a client uh, for that particular campus, for that particular university. So now there were some clients of ours, for example, that went to campus in IITs or triple ITs, for example, or NITs, right? And they might have fought for that particular slot that if you want to be part of your campus drive on day one or day two, for example. But what happens is that you get a slot and then the test assessments. I mean, there is some problem with this, with the whole campus drive. I don't think they will be able to secure the slot one or the day one slot or the day two slot in the next drive because of this first negative experience, right? So we do have to be careful. IMOCA does have to be careful that whenever a client uh, is planning a particular campus drive, it has to be successful. And again, it's not only about the branding of the client. It's not only about the uh, uh, it's not only about the commitment, right? It's also about the career of a candidate at stake, right? Now there might be a particular company that the people are really want to get into kind of thing, but just because of this infrastructure not sustainable kind of thing, there might be some deserving candidate that was not able to conduct give a test optimally, and he lost over there. Now he might go back to the client, he might say that I had this problems kind of thing, but again, uh, I'm not sure if he will be able to get a fair chance again in the other assessment, right? And that negative experience is already there. His trust on the IMOCA platform is already gone low, so he might give another test attempt, but maybe not in the right mindset. So guys, this was the issues that we faced before we had AKS in place. So what we had to think about is whether we should. So we had multiple options over here, right? Should we scale our infrastructure for rainy day? What that means is that uh, I know that the maximum campus that is happening is of 15,000 candidates, right? At a particular specific point of time. Now, can I scale the infrastructure for sustaining 15,000 candidates at the same time, which is the scaling for rainy day? Uh, Technically, I can, right? Candidate experience will be optimal, client experience will be optimal. But what of the infrastructure cost? Because my campus drives of 15,000 might happen once in a blue moon. But if I'm configuring my infrastructure to support that particular 15,000 candidates at the same time, for the rest of the time, I'm unnecessarily putting my infrastructure up and running without any reason, right? It might be used only 10% or even 20, even 5% of the time, and there's a problem, right? The only benefit I get is that customer success specialist does not have to inform us about any particular campus drive because the infrastructure is already capable of handling that. The only case is that if there are candidates, more than 15,000 candidates, for example, the customer success specialist would have to let us know that now it's 20,000. So iMocha platform is now being used for 20,000 concurrent attempts, and that is where we have to now again scale up the infrastructure for supporting 20,000 candidates. Now, whether it's a good solution, of course not. It might be a good solution for the candidate experience, for the client experience, but infrastructure cost wise, it's a worse solution. The other thing, what we did for some time was the manual scaling, right? When I say manual scaling, again, what I repeated that the customer success specialist, for example, would inform us about a campus drive, right? And then just before the campus drive, for example, we would scale up or scale out the infrastructure depending on what is the information that we have about the campus drive. Now, if any parameters change, if instead of 1,500 candidates, there are 2,500 or 3,000 candidates, again, a manual intervention actually during the campus drive would also happen. But again, cost-wise, I'm incurring that high cost only when required, right? But again, is an optimal solution? No, because there's a lot of manual intervention. And what if, again, the question arises, what if the client did not inform us about the campus drive or the customer specialist did not inform us about the campus drive, right? So again, not an optimal solution. So the only solution that we have is auto scaling, perfect choice. I don't think there was any other solution. So we had to go for auto scaling. Now comes the challenge. So I'll talk more about that. Now, in terms of auto scaling, we could have gone for multiple options. We could have gone for Azure Functions. We could have gone for App Service. Now, why not Azure Functions is because this particular process, the assessment process, is not a lightweight process. I mean, there are multiple steps in that particular assessment process. There is the candidate giving the test. There is a reporting happening of the after the test assessment. There is scoring happening, and the report generation is happening, right? So we could not use the Azure functions for this particular case, right? And in addition to that, iMocha test platform supports coding assessments are also, wherein whenever somebody writes a code, for example, the code is compiled, and based on the test cases, for example, we give the score for that particular coding assessment. So there is a lot of background work that is happening as part of the compilation, matching with the test cases, the compilers and everything. So there is a lot of heavy duty work that is happening. And if that particular question belongs to, let's say, a machine learning type of question, so Python with machine learning, that is one of the question type that we support in the iMocha platform. Then again, the work is almost tripled or increased beyond regular compilations of, let's say, Java, C hash, or regular Python without machine learning, right? We could not use the app service also because for similar reasons, for the compilations and everything, what I'm talking about, we require some configuration of kernel parameters, which a PaaS service cannot deliver. So we had to go for an infrastructure as a service. And before the AKS, we were purely using virtual machines. And as I said in my previous slide, that whenever we required additional infrastructure capacity, we either scaled out or we scaled up our virtual machines. Now, there was another option of using Azure virtual machine scale sets. Okay, so it's a good choice. And there is an option of advanced auto scaling in that particular Azure virtual machine scale sets. But whether it's easy to use, convenient to use, uh, probably not that much. We could have gone for that, but we decided to go for Azure Kubernetes Service. And Azure Kubernetes Service has been a perfect choice for us, but not only with Azure Kubernetes Service alone, with the use of something called as SCADA. And I'll come to the details of SCADA. Before that, I just wanted to tell you, I just wanted to show on the next slide on what are the basic auto scaling options that Azure provides, right? So let's go over there. So the basic auto scaling, which is provided by Azure Monitor, so it can be based on the current resource metrics. The current resource metrics are CPU percentage, something related to network, discrete bytes, discrete operations, CPU credits, HTTP queue length, memory percentage, socket count, TCP, and depending on the resource, there can be additional number of metrics, right? But in our case, in the iMocha case, for example, we did not want the scaling of our infrastructure to happen based on the CPU or the memory, for example, because I might be using less than 10% CPU per per request kind of thing, or less than that. But I had to support 15,000 concurrent candidates at the same time, which means that my concurrency is not based on the CPU percentage, but it's based on some particular mechanism that gives me details about how many candidates or how many candidate requests for a particular activity is pending to be handled, right? So we could not use any current resource metrics. Could we do it schedule based? We could not do it schedule based also, because what if, for example, what is schedule based? First of all, schedule based means that I can define my auto scaling based on the time of the day or the day of the week, right? I can mention that from 1 p.m. to 2 p.m. On Wednesday, for example, specific date, I want the virtual machines to be scaled out, and after 2 p.m. to be scaled down, kind of thing, right? I could have done that. Uh, but again, the problem is that it's very similar to my manual auto scaling, wherein we still have to be there during this particular schedule. That in case the information that was given by the client, or in case the information that was given by the customer success specialist on the number of concurrent attempts that are happening, okay, is incorrect, I still have to do a corrective action, right? So that's the reason that purely schedule based also would not have helped us. Then we have something called as instance based, but again, instance based does not really help us because we don't know how many instances are required for that particular test attempt. So whether 5 instances are good enough for those test attempts or not, I'll not be able to really figure that out because uh, different requests for different skills assessment might take different time and different consumption. So instance based was not an option for me. Then uh, so we do have something called as custom metrics. So custom metrics can be based on service bus, that how many messages are pending in that service bus, or how many messages are pending on a storage queue, for example. Based on that, if the number of messages in the service bus or the storage queue, for example, is more than 10, I can add additional instances, right, of the VM. And then there are other custom metrics. So we went through all this particular different options that we had, whether you to use Azure Virtual Machine scale sets and go with the custom metrics and use a service bus because most of our requests are coming on the service bus. So we could have got for custom metrics. But then when we looked at CADA, along with a combination of Azure Kubernetes Service, we thought that is the best option to go for. So I guess during this particular track 6 and the other tracks, Azure Kubernetes Services uh, has been discussed in a lot of details. I guess a lot of you would be familiar with the Azure Kubernetes Service, not probably part of the Azure Kubernetes Service or no, I mean, rather than a standard standalone Kubernetes service as well. Most of you might be familiar. Some of you might be familiar with the Azure versions of the Kubernetes service, right, which is a managed Kubernetes service on the Azure. But I thought of covering more of CADA in this particular in the next particular slide because not everyone might have heard about CADA. Most of the people might have done auto scaling of Kubernetes or any particular infrastructure of this using the supported resource metrics using Azure Monitor Auto Scale. But don't I really do not think that a lot of you have used CADA. So that's the reason that we'll go into CADA in a bit of more details. So what is CADA? So CADA, the full form of CADA, again, it's very simple Kubernetes event-driven auto scaling. And again, the motive is application auto scaling made simple. Now, CADA is an open source that comes with a collaboration of different open source parties, including Microsoft. So I believe Microsoft, Google, and then we have other parties in that as part of the open source forum, and they are developing CADA, the CADA utility. And this CADA is not specific to Azure Kubernetes or Google Kubernetes, for example. It's an open source that can be integrated with any Kubernetes implementation of yours. So again, CADA is a Kubernetes-based event-driven autoscaler. With CADA, you can drive the scaling of any containerized Kubernetes based on the number of events needing to be processed. The main thing about CADA is that it works alongside standard Kubernetes components like the horizontal pod autoscaler. So in the Kubernetes world, we have the horizontal pod autoscaler, right? The horizontal pod autoscaler can scale based on the custom metrics, but then when integrated with CADA, we can do the auto scaling more intelligently with much more custom metrics, with much more capabilities, and the ease of integration. Because of the ease of integration, you don't have to much worry about what is going on in the background. Once you are able to configure a CADA and integrate with the horizontal pods autoscaler, it's a very simple. It's all YAML based. So as long as you know what do you want to scale upon, what is the component that you are going to connect with using CADA, and what are the thresholds based on which you want to do the auto scaling, and how much auto scaling you have to do based on that particular threshold and everything. Once you're familiar with that, and once you know YAML, uh, the other part is, thanks to CADA, is much more simpler. Now, there are different inbuilt scalars that CADA supports. So it's a long list. But currently at iMocha, we are using the Azure Service Bus scaler, which means that KDA, depending on the messages on the Azure Service Bus, decides what is the scaling to be done, and then the pods are scaled based on those messages lying pending in the service bus. And again, based on the Kubernetes capacity, if the number of pods, for example, in a particular node uh, have gone beyond a particular limit, and the HPA, the horizontal pod autoscaler, thinks that the pod cannot fit into that particular node, then it also creates another node. Now, this is the capacity, this is the ability of Kubernetes, this is not the ability of KDA. And as I said, KDA works very closely with the HPA and delivers this. But mainly the use of KDA is for the intelligent autoscaling based on any particular scalar metrics that you see over here. Now, could we have used something different? Could we have used, let's say, could we have used other Kubernetes services, and the HPA could have fetched the information through a cron job or through Prometheus or through some particular different way of doing things? Yeah, of course, we could have done this, but the ease of using KDA attracted us towards KDA. I mean, I guess we ourselves had not heard about KDA before we tried to explore details of what can be used to get this custom metrics. So we tried to think about cron, whether cron can uh, get messages on a queue or a service bus, for example, and can trigger a particular thing to the Azure Kubernetes service to increase the number of pods, for example. That is what we thought about. We checked out Prometheus, for example, whether uh, a monitoring from Prometheus, for example, can send some insights, and based on that, whether we can take the decision. Now we could have gone for that, but then again, I'm repeating the same thing, that the ease of use with KDA attracted us towards KDA. And currently, what is the solution at iMocha is that all our test assessments are driven to Azure Kubernetes services connected with KDA. And whenever there is a campus drive that is happening, and I'm not saying that KDA does not get activated for non-campus drive, it does get activated for non-campus drive. In case, for example, two huge clients, for example, uh, are doing some lateral hiring, and the window that is given for lateral hiring is also not, let's say, 7 days or 3 days. Maybe the recruiters are asking the laterals to do the assessment in 1 day, and let's say we do see sometimes a hit of around 25,000 test assessments being taken, or even more than that, taken during a single minute. Okay, and need not be only campus; it can happen during the lateral hiring also. And at that time also, thanks to KDA, thanks to Azure Kubernetes services, we don't have to be involved. Of course, we have monitoring in place. Of course, we have alerting in place, kind of thing. But we do not have to be very actively involved in what is going to happen, what is happening in the background, kind of thing. Because we have a confidence in KDA, we have a confidence in AKS that whenever the load is beyond the current infrastructure's reach, it will increase the number of pods, it will increase the number of nodes. So that is currently our situation at iMocha. And whatever I talked about, that the customer specialist giving us a notification that there are two campus drives happening, or there is a campus drive with so and so X number of invitations, X number of items that are happening, in no longer relevant. Yeah, the customer success specialist do give us the information, but to be honest, since the day we put the AKS with the KDA in place, we did not have to bother about the such notifications of campus drives. So guys, again, that was a simple presentation from my side. I'll apologize again that I wanted to show a demo. I wanted to show you some configuration files and everything, but I'm unable to do so now because of some issues with the demo account, demo subscription. So I'll be taking help of the organizers to once the demo account is ready, I can create a video out of it, and I can pass on that particular video to all the audiences who are part of this particular session. And then we have, I just go to the partners. We have Packet, we have Daypost, we have RSA, we have Fitium, right? Uh, These are the communities that are supporting the Azure Community Conference. I'm personally uh, very close to Pune user group. I'm part of Pune, and the Pune user, one of the organizers of the Pune user group, is also a good friend of ours, and that's why I'm very connected with this particular community. Yeah, but of course, I do follow the other communities as well. So, question and answer.
Hi, Vishal Madan. So,
Hi, Lakshman.
so any questions from the viewer side? I have some uh, questions from my side. Okay. So,
Sure.
what is the main challenging or interesting thing where before and after on AKS? What's the exciting thing we have checked out on AKS cluster, AKS options?
So, if I understand your question correctly, Lakshman, what was the most thing that we liked about the AKS? Is that a question?
Yes, yes,
Okay.
that's so.
Yeah, I can sleep. I can sleep well. My team can sleep well without knowing that there is a campus drive happening, whether it's over the weekend, whether it's midnight, because we have clients all throughout the globe. There are clients in the US, there are clients in the Middle East, there are clients in the all the regions, right? So if there is a campus drive, for example, me and my team do not want to uh, be awake just to monitor that. So I believe that after AKS, we could sleep well for any campus that is happening. And that was the best interesting thing about AKS with the KEDA integration.
Nice, so that the developers can have that time and they have the
Right.
options so that everything runs perfectly. We could have a thing nice.
That's right.
And and what is the security constraints you have added into the KKS cluster so that the viewers can able to get the security constraints too?
Yeah. So whatever security Azure provides, for example, the similar thing can be applied to the AKS as well. So whether you want to keep some ports open or not, right? Whether we want to filter the traffic, a certain traffic, for example. So there are, there are configurations in the ingress, for example, that you can control, right? Uh, in addition to that, uh, in IMOCA, for example, we use Cloudflare also. So Cloudflare provides additional security, and once the traffic comes from Cloudflare to Azure, then we have another set of security. And then, of course, Kubernetes provides its own security so that I don't uh, call the Kubernetes API when I do not intend to call that particular thing. And though we are not using all the features of Kubernetes, for example, there are a lot of things in the Kubernetes, for example, called as administrator controls, for example. You can have validations in the request, for example. So whatever requests are coming to Kubernetes APIs, you can filter out in case you do not find a particular valid thing in that particular API, right? If it's not for you, you can reject that particular option, or you can. There is an also option also mutating that particular request so that it's more safe kind of thing. So there are a lot of options. Not every security constraint was applicable to IMOCA uh, because first of all, the IMOCA for IMOCA the cluster is not a service-based cluster. It's more of a deployment, and we are taking the request from the service bus. So not everything was applicable to us. But yeah, Kubernetes does provide a lot of security constraints, security features.
Fine, that's a great one. So we will have some couple of minutes so that we could have
Yeah.
any kind of questions. So then we are good to go. Let's wait for a few
So where,
moments.
Lakshman, where can I see the user comments? I mean,
You
any
can see
audience
the
comments?
questions in the comments where you can have
Okay,
can able to see it from there.
got it, got it.
Mm, let's wait for a few more minutes. And hope once we are able to get the demo thing, so we'll be providing the URLs with
That's
the
right.
viewers so that they can able to have visualize how the applications and how the
Exactly.
things to work.
Yeah. So So Lakshman, what happened is yesterday night the demo was working all fine, and today something I tried to enhance it, everything went wrong, and I had to start creating the presentation. So again, the presentation was a shorter one. I could not spend much time on that.
Fine.
Yeah,
So I think there was no more questions so that we could have, and it was a very great session so that they able to know how the AKF options, what are the provisions where we could get, and how we can able to scale out and scale the applications as going forward. So, and thank you for your valuable session, and it's a great and pleasure to have you in Azure Conference 2021.
thanks Lakshman, my pleasure, and a lovely organization, guys.
Thank you, and have a nice day.
You too, Lakshman. Take care. Bye bye.
Mm. Hey everyone. So we are going to upload our next session, which is regards to the automating management tasks using Elasticsearch in Azure SQL database. And let me introduce Michael Browansky.
Hello, good afternoon.
Hey, good afternoon.
How are you?
So, I'm good. How about you too?
Yes, I'm good. I worked late yesterday, so I just woke up, but I'm good.
Okay, so Michael Browansky is going to present about how to automate the tasks on Azure DevOps. So the stage is yours.
Thank you, Lakshman. Thank you very much, and welcome everyone to the Azure Community Conference. My name is Mike Bronowski, and the first thing I would like to thank the sponsors and partners for this event to happen. That's very important, and thanks for their support. And a few words about me. I have a son, 2.5-year-old Arthur, and a wonderful wife, Magda. And both of them are just eating breakfast right now. And I will eat my breakfast after the session. I worked as database engineer in the southern UK. Recently, I've been awarded the data platform MVP, and I'm also Microsoft trainer. And my pronouns are he, him. The session today is about Elastic jobs in Azure SQL database. So what was our plan for today? We will learn what are the Elastic jobs in SQL Server, well, Azure SQL Server, and I will show you how to create them in the portal and using just PowerShell. And I will mention why why the Elastic jobs are there and why you might need to use them in your environment. So let's start with what the Elastic jobs are. First of all, it's just a job scheduling service, very similar to the SQL Server agent for on-premises SQL Server, but the SQL agent is not available for Azure SQL database. The targets for the Elastic jobs can be Azure SQL databases, Azure SQL databases Elastic pools, or shards. And the other functionality of Elastic jobs is very similar to MSX and TSX, which is multi-server management, multi-server job management, where you have one server, which is a source server for the jobs, and then you can send the instructions to the target servers, and that's available for on-premises SQL Server. Also, one important thing for this feature, for this tool, Elastic Jobs, it's still in preview, and I think it's in preview. Maybe it's since 2019 or even 2018, but it's in preview for for quite a long time. So it might not be ideal. It might be missing some bits here and there. So it's worth remembering about this. The main components of the Elastic Jobs are the Elastic Job Agent, which is the Azure resource which we create, and it's like the agent in SQL Server. We also have a job database which stores all the metadata and the system procedures, system tables. So you can compare that to MSDB database on premises SQL Server. Also inside this database, we can create target groups, and it is a concept where we have a group of different destinations, and when we create the job, we can point to the specific target group. So we can point to the whole server Azure SQL. We can point just to specific databases. We can also point to the server and exclude some databases, which is very flexible in this area. And finally, the job. It's just a task of T-SQL to be executed against those target groups. And the plan, like from start to end, how to create the whole thing. First, we need some targets, and it can be anything from the list, like Azure SQL Database, Elastic Pool, or shard maps. And there is no restriction of the level or of the size of the target. The next thing, we need to have a job database, and there is one restriction. The Azure SQL server has to be at least S0. That's the minimum for the job database. And so that is the source, server source database. We need to also create the Elastic Job Agent on the job server. So that will be still on the source. And there is a set of credentials where we create a master key on job database, and then database scoped credentials for executing the jobs and refreshing the list of databases. And I will explain you that when I will be creating the Elastic job. We have lots of logins and users, and the recommended path by Microsoft is to separate them, so you don't the login, the users have the list required permissions, so for the safety reasons. And in addition to that, we can add extra permissions if the job is about to do something on the target, like create a table, on run some DML command. It needs some extra access, extra permissions. And as mentioned before, we also need to create the target groups and add the members. And finally, we just create the Elastic job that is working on top of the whole architecture that I mentioned previously. And then we can start or schedule the job. So let's see how we can create the Elastic jobs in Azure portal. Let's open my Azure. So Elastic jobs are here. If you search for Elastic job agents, it's here. I have a backup resource group just in case it just takes too long, so don't worry about this. And I think this one I can remove because that might take some time. No, not the agent. I will remove the resource group. That is just the thing we are going to create. So it was from my test before, just making sure it was working okay. And if I don't delete that, then I might have problems creating this again. So we can go, okay, so I said we need to have target and job server. Let's create the job database. So I'm going to SQL databases, and I'm going to create the SQL database for the job server. Let's create the new resource group, Azure portal. I can easily remove that after this demo. The database would be job DB portal. And I don't have the server in this resource group, so I just want to create a new one. And it will be job DB server portal. But I can leave it in the US. And here I'm going to provide the credentials for to get to the server. So it will be something like that. And I'm going to create that. Oh, sorry. More settings. And yeah, network. Just here we are going to configure the server. So I don't want to spend too much on this configuration. So I can change to the not here. I want to change to the minimum requirement. So it will be standard and S0. It's S0. Perfect. And it will cost about 13 euro per month, which is much less than the one that was selected by default. Now I need to add the permissions, the firewall rules to the Azure resources to talk to each other, and for my IP address, so I can connect with SQL Server Management Studio to do some more bits. That's okay. And now I'm going to create the job database. Perfect. And now, once it's being created, I am going to create the target database. And that will be now. So you can create that from Azure SQL and go this way, but when you select SQL databases, the creation wizard asks you for all this bits like Azure SQL, so you can create them in one go. AZ portal, and that will be target DB portal. Again, we will create the server. Target DB server portal. My credentials. That's correct.
Hello.
Hello.
Sorry to interrupt you, Michael. So your screen is not so visible. Could you zoom in a bit so that viewers can able to see it?
Sure. Oh, like this.
Yes, it's good. Thank you.
Yeah, sorry for that. And here I'm going to change the database as well to the cheapest option, which is basic, and it will be just basic. And when I apply that, that's here, networking again. I need to enable the access for myself, security, all good. 4 euro for this machine, so it's much cheaper than the previous one. And create. Yeah. So I'm just creating the virtual machines right now. Now the virtual machines, the SQL databases. So let's have a look. What was our plan? We have the targets, we have the job, and then we need to create the job agent. Let's see if the resources are done. It might take some time, and job DB portal is created. Awesome. It's quick today. Usually it's much slower. And now in the Elastic Job Agents, I can create the agent. And it will be just Elastic Agent portal. And I need to select the database for my the MSDB in Azure World. And my server in this case is job server portal, and the database is showing up here. And since my other server, the target server, is not built yet, so I will show you this in the backup. I have the database there, but it's not available here to be a job database because the server is the basic one. It's not S0, so that's the only difference. And if you see here, we have the job database. That's from my backup setup, just in case Azure is too slow. And I'm going to select the DB server portal, the database. Okay. And create. You can download the template if you want. So I'm going to create the Elastic Job Agent now. And it will take about a minute or so. I think we can clean this. Yeah, so the agent itself looks like that. We have information that this is currently in preview. The database has been created. Okay, it's not the agent. And yeah, that's all we have here. We can see the job executions. Let me go back. Oh yeah, here's the menu. A little bit, yeah. We can see the jobs if they are created there. I don't have any jobs in the backup yet. We can see the targets groups, and we can see the credentials. But this is a read-only view. You cannot change anything. When they start showing up here, you can just see them. You cannot add the new job. You cannot add the target groups or credentials from portal, which is a limitation of portal. Yeah, okay, so the agent is Elastic Agent portal is created. It's exactly the same. So nothing here is just empty. So the next step is to create the credentials. We need to create the master key on job database where the agent is, and the other credentials on job server and target server. So to do so, I'm going to use tsql, and I need to connect to my server, which was job DB server, if I remember correctly. Server. Oh, interesting. I thought I added that. Okay, let me. Huh. That's weird. Okay, let me see the SQL servers. Job server. Where are you? Job server portal and target server portal. Can I connect to this one? Oh, So I'm connected to the target one, but I'm not connected to the job. Let me see again. Mm-hmm. And now I'm connecting to not the target. Where is the job? It's job. Job. Oh, strange. Firewall. It's interesting. Let me see what I have in the target. Firewall. Is that this address? Default, yes. All good. No. Deny. No. Job server. Nah, not firewall. Not firewall. Firewall. Sorry for that. I must have missed something. The IP address is exactly the same. Interesting. Oh, okay. There's one spelling. Wow. No idea. It worked. Sorry for that. Yeah, something was not right. So I'm connected to. So this is the same SQL query, the same SQL file, because I don't want to switch between the servers. I just don't want to connect to the target and job from this one file. So I have opened two queries and I'm connected to two different servers. This is a job server, so we can open that in the Object Explorer. We can see the databases, the job DB portal. I will just show you that this is an empty database. Well, it was empty, but it has the, since I created the agent, it has the internal tables and procedures. Yep, all this similar to MSDB, SP add job, SP add job step, where the other one is my target database, and that is empty. We can see that target portal tables, and it will be empty because I haven't created any objects in this database. Okay, so the first thing, we need to switch to the job server and the job database. And I cannot use the command use and database to switch the context within the Azure SQL. And I need to create the master key for the on the job server. And now I'm going to switch to the job. Again, it is still in the job database, but I'm going to create the credentials, the two credentials. One is job credential to execute the jobs on the target servers, and the other one is to refresh the databases. So if the job connects to this server and there is multiple databases, it has to refresh the list of the databases. So that is the credential for this work. This goes to the target server. So I'm going to switch here, and I'm going to create corresponding logins and users in the master database. So logins have to be in the master database, both for credential and for job. And I'm also creating the user in master database to refresh the view. So that has to go to the master database on a target server. And the job credential, the one that executes the commands, goes to the target database. So I'm switching to target database, and I'm creating the job credential. And because my task is doing some DDL work, I will also add extra permission to add the DDL rights. And now I'm going to switch to the job database. So that is this part. I finished the logins and extra permissions, and now I'm on the target group and members. Apologies, it's probably small as well. I will share the scripts and T-SQL and PowerShell, so it can be reviewed later on. So now I'm on the job server and in the job database, and I need to create the target group. So that is my target group. And here I'm going to add the members. And I only have one member, which the name of the member is incorrect right now. It is this server. And you can see that the membership type is include. So I will include that server. The whole server. So whatever the databases are here, they will be included. And I can confirm that using the internal tables. The target groups have been created, and I can see the target name here. And now I'm going to create the job. So just create the job, which is the basic stuff, name, description, it will be enabled, and my schedule is once. And I'm adding the job steps to the job. In my case, it will just create one table. It will create the table. I'm not very original with the script. And yeah, that's what the job does. We can see the details of the job. It's like in MSDB. We can see the job name and all the properties, and we can see the steps as well. Exactly. And we can see the credential here as well. So that is the credential that runs the job. And now we can execute the job. Let's see the history, the executions, if it's running. It started. And it succeeded. So we should see the table here now. And here it is. So I kicked off the job from job server portal and on the target DB server portal. So that's how you create the Elastic jobs with portal and a hint of T-SQL, because not everything is possible in portal. And let's quickly talk about why someone might need to use the Elastic jobs. First reason is the SQL Server agent is not available in Azure SQL databases, which if you need some scheduling, some excuse me, maintenance tasks, well, you need to create this with the Elastic Jobs. It also helps you to automate management tasks, like it might be maintenance, it might be auto refresh, or any other task you have. Very similar to what agent does on premises. And it can also collect the data and store them in central table. So you can run the job on targets, and it will collect the information and save them on the central table, which is good for some kind of monitoring, I guess, or checks. You pull something from different servers and then have a report on the central database. And I'm going to show you now how to create the whole solution in PowerShell. And it's possible to do it within one PowerShell session. So let's switch to my PowerShell. Let's clean this. And one second. I will open new session, so just in case I've been connected there, it's clean. Elastic Jobs. Okay, here. And my file is loading. Perfect. The plan is exactly the same. We will do all this stuff we did in Portal and in Management Studio, but with PowerShell. To do so, I need the az.sql module. Currently, it's the version 3.5.1. I think it's 3 weeks old, and it works. I've tested that. Well, it worked yesterday. And I'm also, so I will just import this module, just make sure it's there. I'm also going to use DB tools to run some T-SQL where I cannot use AZ SQL commands, but it's still within the PowerShell. So it's a bit like a hacking. Let's see, the DB tools are here. So I'm going to import the DB tools from my local folder. Here I just installed from the PowerShell gallery, and you can do the same with DB tools, but I have a local copy of DB tools, so it might be a bit quicker than installing it from PowerShell gallery. And I had this line added yesterday because the Azure changes, it introduces the breaking changes to some of the commands, and I get the warning, and the Microsoft documentation says this will disable the warnings. So hopefully you don't see the all the orange warnings. So let's see my modules now. It's both installed, the latest versions. Awesome. Now a pre-step, I need to set my credentials for the Azure SQL servers. So that will be it. I did the same in the portal when I was creating the servers. Now I think I need to connect because I have opened a new session. So I need to connect to Azure account. And it will, yes, I'm connected. And now I'm going to create a resource group. Let me just double check if that first resource group has been dropped. Yeah, it's done. Perfect. So my resource group will be called AZConf 2021 in the UK South. And I'm using the command new AZ resource group, where I provide these parameters using PowerShell Splat. And when I save it to the variable like that, I can then see the details of the resource. So when you don't see the output here, but when you open the when you read the variable, you can see all the all the details, and then you can reference to this object by like this resource group dot resource group name. So I don't have to copy the name every time. So that's a pretty cool way to do this. When I change the resource group, I don't have to change this in the whole script, just in one place. And you can see the note, this task to create the SQL servers, Azure SQL servers, will take between 3 and 15 minutes. We'll see how it goes. And but since I have the backup, we will be fine. So I'm going to create in the resource group that I just created in the location and using my credentials. So I'm just providing all the stuff from before. And I will create a one job server because I only need one, and 2 target servers. So let me run this. And it will run for a while. I don't know exactly how long. It depends on the Azure. Sometimes it's one time I think it was over 25 minutes, but the next day it was running 5 minutes. So it's a mystery. But yeah, I can go through the rest of the script, and while this is being created, let me make it a bit bigger. As in the portal, I still need to add the firewall rules, and in the scripting library, there was a link how to get your IP address using the PowerShell. So I used one of the methods, and I'm intercepting the IP address from this API and saving this to this variable. So I don't have to put this manually, and I don't even have to know what's my IP address. So this is a very good way to run this on multiple different servers. So this will be next, getting my IP, setting the firewall rules, where I'm letting myself in, and I will add this rule to all the servers. So when I was creating this in the portal, I had to, well, I didn't have to, but I did this while I was creating the server. But here I can create the rules afterwards, after the servers are created. The other firewall rule is to allow all Azure IPs so they can communicate. So that will be done once the servers are complete, and it will take only a few seconds. Then, as similar to the portal, we need to create the database, the job database, and I'm using this plot again so you can see this. It's like in a better presented way. It's not in one line. So my name will be the database name will be JobDB. I'm using server O, and the edition is standard S0 because that's the minimum for job server, job database. And then I will create the database. It should take about 1 minute. We'll see how it goes. And once the job database is done, we can create the agent. So for all these functions, you can see it's new dash AZ and then SQL, and we have server firewall rule, database, elastic job agent, and that's good. There is some consistency with that. And once we create the job, the agent, then we can create the databases. And as I showed you in the portal, it will be basic. So I'm restricting the cost to the minimum. And I will create 5 different databases. So it might take some time. It's just for demonstrating the target groups later on. Then next on our list are the credentials and login and users. So for the job credentials, for the credentials in Elastic Jobs, we have the function new AZ SQL Elastic job credential. So I will create that with using this function. Just I prepared the credentials here. So the password is here, and the names are here as well. So I will create that, and the logins, we don't have, there was no function for login or users. So for that, I'm using DBA tools. If you are not familiar with DBA tools, you can check them out on dbatools.io. That is a PowerShell module that works like SQL Server Management Studio, but from command line from PowerShell. And it's open source and it's free, and there's a big community behind the tool. So yeah, go check it out, and it makes your life easier as a DBA. And so we need to create the logins, the users, and one of the command. So here I'm just defining my parameters for the invoke DBA query. This is a DBA tools command, and I need the database where I'm running the query. Like in Management Studio, you have to select the context, the database context. Then we need the SQL instance where I'm running the command. And here I'm running this against 2 servers. And what credentials I'm using, so how I'm going to connect to the server, because I'm not connecting with my own account from my laptop. So I need to provide the Azure credentials. And the query, what is the query that I want to execute on the server? And that will repeat a few times because I need to create the login on the once I created the credentials on the master on the job server, then I need to create this on the targets. So logins on the targets on master, and then user to refresh on master, and job credential on target. And the next thing will be, I'm sorry, this is login, so still on master database. And the next will be the credentials to be created on target databases. So on these 5 databases I'm going to create. And to do so, I'm getting all the databases from both instances, from both Azure SQLs, using the get-dba database, which is again DBA tools, and it will get me all the database names. And in a loop, I'm going to run the query and just create the user in each database. So on both servers, for against 5 databases, I'm going to create a credential and also add the role. And yeah, only like 8 lines, and you can do this on 2 Azure SQL servers. After that's done, we will create target groups, and here is the good part, comparing to the portal where I didn't have too many groups. So I will have a group with a whole server, which I'm just going to add 2 servers. And you can see for the group, I'm using AZ SQL Elastic Job Target Group. And it will create a new target group. And then AZ SQL Elastic Job Target, where I'm adding a target to the group. And it will add the whole server with all the databases. And for the server to see, for the job to see the database on the target server, I need the refresh credential. That's the one that's created on master database on a target server. The other group would be selected databases. So I'm just going to create a group and add a specific database. It's still from server 1 and server 2, but one database from each server. And I don't need the refresh credentials because this is just pointing to the specific database. So I don't need the server level refresh. And the third group is to exclude the database from a server. So I can add a new group. I can get the databases like here. I'm getting all the databases from server 1 added to the as a target, as the database. And then I'm going to exclude one of the databases. So you can see that I'm using still the same command, add elastic job target, add elastic job target. But in this case, I'm giving the database name and the switch exclude. So whatever was added here, I think there are 3 databases. Server 1, I think there are 3 databases. And I will exclude one. So we should have 2, I think. And we'll see. And once it's done, the final step is to create the elastic job. So my job name is job, and I'm using the new AZ SQL elastic job command and schedule it to run once. Very similar, very, very quick way to create the job as in the T-SQL. But in this case, I have 3 steps for this one job. And just to show you the how the target groups works. And so the first one, for each step will create a table for their own steps. So step 1 will create a table, step 1 table, and step 2, and so on. But each step will be directed to different target group. So within one job, you have 3 steps, and each step can go to different targets. And that's something you probably cannot do. Well, out of the box, you cannot do this with SQL Server on premises. You can code that or using the MSX, TSX. But yeah, with Elastic Jobs, it's possible. And then I'm targeting the different groups. So this group 1 should have the table 1, and so on and so on. We'll see that. Yeah, and the last bit is to execute the job. So let me see where we are at. We've just started creating the servers, and let's quickly see where is what we have so far. Oh my, just first target server. Yeah, it's taking some time. So maybe if you have questions right now, it's a good time. Are there any questions so far?
Hey, hi, Michael. So it seems there was some. I don't think this is a question.
Yeah, okay.
There was no there was no that kind of questions at present. So
yeah, okay.
Yes, go ahead.
No, go ahead. If you have questions, just go ahead.
Okay, sure. So on creating this elastic job, so what is the complex or where we need to take care some best practices while deploying these stuffs on the production, so that we could able to take care of those also some kind of practice we need to follow.
Oh, yes.
If you get it.
So one the important thing is the credentials and the security separation. So if for this demo, I'm using 2 different credentials, but yeah, if you create this just like when you start creating this, you can use 1 credential, but it might not be the best case because this credential will have too much access to the server. So it's good to follow some security guidelines to limit the access to permissions for the resources. And I haven't seen any guidelines about the good practice for Elastic jobs. But it's a good question. I will need to have a look closer at that. I always treated that as a SQL Server agent on steroids, like enhanced version of agent. So yeah, that's something.
Thank you. And you can go further if there was
Yeah.
any demos where we need to project. Thank you.
Yeah. So the server is completed now. I can add the firewall rules. Just add the firewall rules. It shouldn't be long unless the Azure doesn't like me today. And yeah, it's done. And I'm going to create the database, the agent job, and the 5 databases. Oh, interesting. So I see the warning message. Huh. Yeah. So I don't know if this worked or not, or is it session scope? But yeah, it didn't work. But we don't have to worry about this warning for this demo. It's just information from the Azure that there were changes, breaking changes. Yeah. Okay. So we're creating the databases right now. We have 7 minutes. Just to be on the safe side, I'm going to have a look if my backup setup has the jobs. Let me see. No, my backup doesn't have the jobs. So I'm going to create the jobs probably. So at least you see the whole thing. Where is it? I think I've created the jobs and the databases in my other resource group. So let's see. We have the servers, we have the agent, we have the databases. Perfect. All of them. DB, yeah, looks like all of them. So let's see if we can open a new session in PowerShell and use the backup. Maybe the database will be created soon, but just want to be sure we don't miss that bit. So you see the example of the target groups. Let's close this one here. So I think databases were created, and so I need to create the yeah, it might not work because I don't have the setup here. Resource group is this one. No, this one. the backup one. Let's see if I can connect. Oh yeah, I'm connected. And yeah, the problem with that will be that when I was creating the objects, I saved them to the object, but I don't have the details of the objects right now. Okay. So we need to wait. It will be just a few minutes, and once the databases are created, so hopefully we can manage. So when we run this job, we can also we run this job with PowerShell, start AZ SQL Elastic job, and then we can see the executions, and we can see the step executions, and yeah, some details about how the job is performing. And once it's done, hopefully we will see the using the db tools command get dba db table, the tables that were created using the target groups. So let's see how the databases are moving there. The databases should have 5. Oh, it's getting there. 1, 2, 3, 4. 2 more. 2 more and we'll be done. Yeah. The other example I wanted to show you, not the backup here, is collecting data. So for this reason, I'm going to create another credential, like job collection, just for this specific task. So, oh yes, we're done. So let me quickly run the other thing. So we created the databases. Now I'm going to create the credentials and logins. So credentials here. It shouldn't take long, at least not that long as before. And we're creating the logins. Perfect. So I'm going to create the logins and users. You can see with the PowerShell, it's much quicker than the portal. We have to wait for Azure, but if it's coded properly, you can run the whole script and just go grab a coffee or tea or anything, and it will just create this stuff for you. And the target groups as well. And jobs. Yeah, the target groups are being created, and we create the job. Come on.
To interrupt you, Michael.
Yep.
This is a great session. Thank you. A gentle reminder: we have 3 more minutes for our next session. Would you like to wrap up, please?
Yeah. So I'm going to show you this one example. Hopefully it works. So I'm starting the job with the different target groups. It will run in the background, and we can see the executions, the target executions as well. It just runs, but succeeded. Waiting for retry something is not right with this one. Oh yeah, I know why. And we should see the tables now. If they finished, we should see the tables. So they are going to pop up. It's always a lottery with Azure. It might be quick or it might be just slow. And it's loading. It's still loading. The script is still running. And you can see that the tables, like the step one was created a table on every database on the server, on each servers. So step one is everywhere on every database, and step two is just on one database because I've excluded the other one, and step three goes against the servers. Sorry. Yeah. So it goes here on the database on different servers, and here I just excluded one database, and it's not there. I think it was master. Okay, and the last bit, I'm just going to run this quickly. Collecting, create table, new table. And I will just run this, and it will it will start the job, and it should have a collection here from the central output soon. So I'm going to see if it's done now. If it's no, oh yeah, we can see it's done. So my query for this server was just select server name and get date from the server, and now I'm running this from a central place on the job server, and it has the server name and the time when it started. So it comes from targets from server one and databases, and this is just internal execution ID for the table. So when you create a central table, you need to include that column. Phew, we made it. And
it was a great session, and sir, you were able to know how the Elastic jobs and how to make triggering with a SQL database. So it was a great session, and thank you for your valuable time, and appreciate your time, and thank you, and have a nice day, Michael.
Thank you very much for having me. That was a great pleasure to be here today. And if you have any questions, reach out to me on Twitter or email as well. So thank you, and have a good rest of the day.
Thank you. So hi everyone. So we'll move with our next session, which will be build a chatbot to drive into the workplace inclusion. It's by Lygia Thomas. Welcome, Lygia Thomas. It's nice to have you in our Azure Community Conference.
Hello, Lakshman. Nice to meet you too.
So she's going to talk about how to build an awesome chatbot application. So the stage is yours. Hope you can
Thank you, Lakshman.
present it.
Yeah, can you see my screen?
Yes, I can see your screen. So
yep,
it's good to go, and the stage is yours.
Thank you, Lakshman. So hello everyone, and welcome to this session at Azure Community Conference. It's great to be with you all on this Saturday afternoon, India time. So a little bit about myself before we get started. My name is Lygia Thomas. I'm a technical manager with Valorum Reply, and you can find me and stay connected in the following places: in LinkedIn, Twitter, and my personal blogspot as well. I would also like to do an inclusive introduction. So I am a dusky-skinned Indian woman with long black hair, and I'm wearing a check shirt with gray, black, and white stripes, and I have a plain white background with two paintings on the wall. And I hope you're able to see my subtitles as well for my presentation. Cool. So a quick word of thanks to our sponsors, our title sponsor EY, gold sponsor Microsoft, and our community partner Elastic that makes all this work for us, our community conference. So today's session will be on building chatbots for workplace inclusion, and a little on the agenda for the day. We will be taking a step back and covering the history of conversational AI before we look into Microsoft conversational AI and bot framework composer. And then we will deep dive into a demo session and be happy to open it up for Q&A. So, we come from varied backgrounds and not everyone would probably be familiar with the conversational AI landscape. So it would be good to take a step back and kind of talk through the history of this space and set the stage sorts. So let's get started. So the evolution of chatbots follows this trajectory. So for those of us who've been here for a while, we'll know that from the PC era, it's been the desktop applications, and then in the internet era, we had the websites and the web applications doing the rounds. Come 2000s, we had the mobile era. So you have a smartphone application that you can download from Play Store or the App Store for all of your needs. And now all of a sudden, we are in the fourth industrial revolution, so to speak. We have the AI era or the chatbot era of the various kinds of AI applications. So for those of you who've been in my previous presentations and have seen these slides, please bear with me. This is just to sort of set the context for the audience, right? So again, taking one more step back to sort of address this before we, deep dive into this technology. What really is a chatbot? Because I hear a lot of terms doing the rounds, and you probably as well, virtual assistants, personal assistants, conversational agents, etc. So a chatbot is really a computer program. It's a piece of software. It simulates human conversations through text, through voice commands, maybe both. So you can have a standalone bot like you have Alexa or Siri, or you can even integrate that as part of your web application. So if you have a website, you can put a chatbot on that. Now, what does a chatbot do? Completely depends on you. So you can build a chatbot to do something as simple as setting up your alarm clock, or making your dinner reservation, or for your dentist appointment. You can have very simple conversations with a bot to having built very sophisticated conversations as well. Now, why chatbots? Right? So when we have desktop applications and web applications and smartphone applications, why chatbots? A couple of reasons. One, it feels less like using a computer and more like dealing with a person. That's probably the biggest selling factor. It's available 24/7. It does not take PTOs, no holidays. It is available for immediate response. It reduces the costs overall in the long run. You can reach new channels if you have audience in Facebook or Twitter or in any of the social media channels. You can deploy a bot there, and it's definitely increasing engagement. Now, the bottom line here is, one of the major reasons why people use chatbots is, or why you should be really excited about the space is this. When computers can speak like humans, every human can speak with computers. So this is probably the biggest selling factor as far as conversational AI is concerned. If you think about it historically, the way humans have communicated or interacted with each other is by conversations. That basic storytelling goes back to even the Stone Ages. Come the computer age, we struggled to make the computer understand what the humans were trying to say, and we knew we needed to come down to zeros and ones. And what started with the DOS programming and then other graphical user interfaces, etc. Now we are at a point, not just technically, but from a user perspective, a user need not understand the navigational system. You need not know which button to click and which text box to enter and which pages on a site is for what. You can interact with a bot just like the way you interact with another human being. So if, like in my school days, and I used to go to sleep, I could take out the phone and set an alarm clock and make a time, wake me up at like 5 a.m., 6 a.m. My daughter does not do that. She says, Alexa, wake me up at 6. So it's as simple as that. And it's a fundamental shift in the programming paradigm wherein computers have started speaking like humans, and this democratizes technology to an extent that every human can now interact with technology just the way we interact with each other. And I think that's the most captivating factor for this piece of technology. So historically, you'd see that chatbots have been there for a long while, from Eliza to Parry to in the last 50, 60 years or so. And the futuristically as well, it looks quite promising with a couple of statistics, one of which says 95% of those customer interactions are going to be using AI by 2025. And because of that, a lot of customers have already started jumping on this bandwagon. So you find small enterprises, large enterprises, major brands, offline and online cloud service providers really make use of an AI strategy or a conversational AI strategy. So you see the major brands already have a conversational AI plan in place. Now, apart from that, you also have very innovative chatbot use cases. Some of the ones that I like is shown here. Do Not Pay is a chatbot that started off like you could pay for your parking fees, your fines, and now it's a legal services chatbot, not here in India, but in the US and the UK. You can help claim compensation and even sue companies for your small claims. Margo is a chatbot that helps you pick the right kind of wine to go with your food. Wobot is a very different kind of chatbot. It's built on the principles of CBT, cognitive behavioral therapy. This is used to treat clinical depression in patients. So if anyone who's dealing with depression can actually talk to Wobot. So debunking a few chatbot myths as we close down this first section here. If you came into the session thinking that chatbots are a new technology, by now you know that it's not true. It was here, it was relevant, but it's just gaining a lot of traction recently. It does not just support customer service, that's a myth. The truth is, there are a lot of innovative use cases for chatbot, and we're going to use this to build a very innovative chatbot today in our demo. All bots use AI, not necessarily. Some bots, and you've probably interacted with this as well, does not seem to understand anything beyond those 2 or 3 very scripted question answers that they have been programmed to answer. An AI chatbot, the one that we want to build, should be able to answer or should be able to understand user queries irrespective of however you ask that. Chatbots versus humans is a little scandalous there. So we would not think about chatbots as replacing the human workers or the human, at least we're very, very far from that. What we may want to be interested is in thinking how we would work in a single team of chatbots and humans together. So even in the typical customer service scenario, right? Think about it as the first 40% of those queries being offloaded to a chatbot so that the human can free themselves up to do far more creative tasks with that 40% of time. And the chatbot can answer very simple questions, a better use of creativity. And then chatbots are difficult to build. So this is also something that we tend to hear a lot. It's quite difficult to build a chatbot from scratch, especially. We will leave you with that. We see how difficult or easy it is to actually build a chatbot. Let's take a look. So that kind of wraps up the first section. We introduced the conversational AI, and now we look at the Microsoft's offering in this space. So prophetically, Satya Nadella introduced this a few years back in a Build conference where he said, human language is the new UI layer and bots are like the new applications. And it's interesting because all those AI services that Microsoft has been invested on the last 20, 25 years coming out of Microsoft research, they put it into the Azure AI platform. So today in Azure, you will see support for Azure infrastructure, which includes data and compute. We have support for Azure AI services. We also have support for tools. Now, I want to take a pause here and sort of help connect the dots. One of the reasons why we're seeing the proliferation of AI and a lot of talk around AI in the last couple of years is because of a couple of reasons. Now, we know for a fact that AI really started, artificial intelligence really stemmed for 1950s and 60s, but it didn't quite take off. There was a period that was called the AI winter. And these days, we tend to hear a lot more about AI, and you might be wondering why. So that's specifically advancements in a couple of areas. So one is around data. We have big data, not just the availability, but also the possibility to harness, to store, to process this data. We have advanced computing power, which was not available during those times. And also, we have very powerful algorithms or statistical models. If you want to connect those dots here, and that's exactly what you see in the visual, you'd see AI on data, you see AI compute, and you have AI services. And this is probably the reason why you hear a lot about artificial intelligence in general these days. So for our session, we will focus on the conversational AI bit inside Azure AI services, and we'll deep dive into that. But I kind of just wanted to give you a very high level overview of where we're coming from. So Azure conversational AI. It's interesting that Microsoft thinks about it this way, that everyone deserves to have their own personal assistant. I mean, even you and I. So an assistant that helps us cope with everything, to just stay on top of everything. I mean, as a mother, on top of my kids, like what's on the menu, what's on there, my assignments, what's happening at work, what's happening in my projects, my tasks. There are battles that each one of us play on a daily basis. So it's great to have our own personal assistant, and that's basically Microsoft's vision going into creating these AI services. Now, interestingly, this would not be possible if only a few Silicon Valley engineers were able to create conversational agents, or if only a few Silicon Valley engineers were able to create chatbots, we would not have an assistant for everyone. So there are basically different ways in which you can go about building a bot today using Microsoft technologies. And let me introduce that one by one for you. So the first one, or this is perhaps one of the first offerings from Microsoft, we have the Bot Framework SDK. Now, this was a fully open source SDK for developer community, fully in code. You could use this SDK and a programming language of your choice to go ahead and fully code a chatbot from scratch. Very powerful SDK. And thereafter, a little while after that came the Power Virtual Agent. So this was a completely different offering. This was a low-code, no-code tool, mainly intended for business users. Very simple online application, graphical user interface. You could drag, drop, and you could build your chatbot interfaces. Now, in between the two is what we are going to discuss for the remainder of the session today, is the Bot Framework Composer. So the Bot Framework Composer is a low-code tool. It's not a no-code. It's a low-code tool that is essentially meant to speed up chatbot development. Now, especially the Composer and the SDK, it's never a question of either or. You can always use that in combination. Now, one of the challenges with the Bot Framework SDK for the developers, even seasoned developers, was they could not see what they were building. It was completely in code. There was no visual interface. There was no graphical interface to see the chat dialogues that they were building. So that is a space where the Composer really fills and makes good use of. So each one of these have got their own advantages, like the Power Virtual Agent. If you're a business user, you want to build simple, easy chatbots with no coding skills, perhaps the Power Virtual Agent is for you. If you're looking to visualize your dialogues and just actually see as you build your chatbot interfaces, you can start with the Bot Composer. And when or if you are comfortable, you can always move on, extend that by using the SDK to build, plug in additional integrations and more powerful features. So it's not throwaway code. From the Bot Composer, you can download the code that you are building. And then that C# code can be taken to your favorite IDE, say Visual Studio, and you can continue to develop your applications there. So these are the three ways to build a bot, but we will focus now on the Bot Framework Composer. Cool. So what is the Bot Framework Composer? The Composer is a visual editing canvas for building bots. As we said, it's an open source IDE which just helps you create and you can manage your conversational experience. So we'll look at a detailed demo of how you go about the Composer. What can you do with the Composer? So the short answer is you can create and you can manage bots, but the long answer is a lot. You can create bots, you can add text and speech responses, you can add Q&A facilities, you can add natural language understanding capabilities, you can publish your bot, a lot of things you can do with the Composer. why should I use the composer, right? Might as well just go in and start coding using the SDK. Fair enough. But if it means to you to actually see what you are designing, it's always easier to begin with the design, to design your conversational experiences. Composer provides a visual designer for you, and that's so much easier compared to a code first approach, especially when you sort of get started building a chatbot. And how do I get the composer? So go to your favorite browser and download Composer. You can install the Bot Framework Composer either as a desktop application, or you can use it also as a web-based component. So I have installed that as a desktop application, and we will dive into the demo of the Bot Framework Composer. So as was mentioned in the title of the presentation, we are trying to build an inclusive workplace using bots. And there are two ways we can go about this. You can use technology for building inclusion. You can build inclusive workplaces as well. Today, we're going to use technology to build, to see how it can help us build inclusion in our workplaces. So my problem statement for the day is that, and I'd be interested if you join me in creating inclusive virtual assistant, or IVA, as I would lovingly try to call her. And let's switch to our Bot Framework Composer. So here I have the Bot Framework Composer. This is the tool. This is a desktop application that I have installed on my machine. And as you can see, you have a couple of options here. Go ahead and click the Create New menu button. When you click that, you will see that you have a couple of options here under C# and under Node. So what this really means is, under the hoods, it is actually generating the code for you. So if you choose C# and you can choose any of the templates here, under the hoods, it is actually creating all packaging a C# solution for you, which you can continue to work on in Visual Studio or where be it. So let's start by choosing one of these templates. You can start with an empty bot, and you can read the literature on the right side to sort of give you what you get out of that. You can do a core bot or an enterprise assistant bot, and here's the empty bot, right? So let's do an empty bot today, which is fairly simple. And I would call this, let's see, the Azure Community Conference bot. Okay, and we got Azure Web App, and you can run it as an Azure Web App or as Azure Functions. We'll keep Azure Web App, and this is the location that your solution or your package will be available at, and you hit Create. Now, as that gets created, I also wanted to introduce you to another tool. Just like we downloaded the Bot Framework Composer, there is another tool called the Bot Framework Emulator. Now, the emulator is a tool that helps you interact with the bot, communicate with the bot. So if you work with the chatbot, you know that you would need to send some message to the chatbot, and the chatbot would need to ping you back or send back that message. So that is what a Bot Framework Emulator does. It's a free tool. It's an open source tool from Microsoft again. Just like you downloaded Bot Framework Composer, you can download the emulator, and I will show you that also in a bit. I have downloaded the emulator onto my machine. You can see the Bot Framework emulator there. So, as I said, this is also a possibility to bring in multidisciplinary teams. So if you have a strong business user, a business analyst on your side who's not very technical and who does not deal with a lot of code, the Bot Composer is a place where they can get started and can hand off the code to you, to seasoned developers on the team, and they can continue to integrate what they would want into that application. But there's a lot that you can do within just the framework of the Bot Framework Composer itself, and let's see what all we can actually do with using just the Bot Framework Composer. So we give it a minute. It's taking a time to create the project. Let's see. It is building a runtime. So behind the screen, there's a lot of packages that it needs to create, and it needs to bring up front, and probably that's why it's taking a lot of time. So we'll give it a second and we see if this gets built, or we will open right from it. Yeah, I think that's the final stage where it's merging the packages, and we'll be ready in a time. So meanwhile, if you do have any questions, please post them in the chat window, and I'll be taking all the questions towards the end of my session. And we be seeing. Let me see if you have any more questions for me. You do not have any questions for me right now, and we can do this. All right, I can maybe try doing this again so it doesn't take in a lot of time. And I will try sharing my screen once again. So there is my Bot Framework Composer. It's probably taking a lot of load on my screen because of a couple of applications. We'll see how this goes. Okay, it's running. I will just stop sharing and I will share it again so that I get to see the screen. Yeah, and I apologize for that. My composer is for some reason it's not turning up right now. So I will just close out all my applications and just make sure that this is running quite a bit. Give me a second here, please. Okay, I guess it's still taking quite a bit of time. What I will do is, Lakshman, if you don't mind, I will just join back in a minute, and I think I will just need to just restart my machine. I will just join back in a minute if that's okay.
Okay, that's okay. So we'll be having some patience on here. So just get back.
Yeah, sure. Just give me a minute. I'll be right back.
Sure. So hi guys. So as Richa said, we will be coming back just in 2 minutes of time. So just keep engaging in us so that you will get back to us. In the meanwhile, let's see. Hey, hi everyone. So Lisha Tom is going to resume this session as further. So
Hey Lakshman, thank you for putting me back, and
hi,
I'm sorry for the delay in that. There
no
was
further.
quite a bit of just sharing and stopping there. Okay, cool. I think
So we can start
we are
with the
back and
session.
we can start. I will share my screen again.
Sure.
All right.
And you can
Cool.
continue
Thank
the
you, Lakshman.
presentation from here. Thank you.
Yeah. All right. So here we have it. This is what the bot framework composer really looks like. You have the panel on the left hand side, and you have a couple of dialogues over here and a property window on the right hand side. Now, before we do anything to this, I just love to just run this app and just show you what it looks like. So we chose an empty bot template. It should pretty much not do anything other than what is really written here, which is a greeting message. So if you see here, now any number of new users or returning users, they would just greet the user, welcome to your bot, and that's pretty much all that it does. It does a greeting trigger. Now, this message itself, welcome to your bot, can be changed. As you can see here, I can go here and I can change this message to whatnot. So there's a lot that you can do in here by just using low code mechanisms. And as I said, you can interact with the bot also in a couple of ways. You can interact with it. Let me show you this. So this is, you have a panel that will open up within the bot framework composer itself. It's called the web chat, and it greets you, welcome to your bot. You can say hi or you can say hello, but at this point in time, it does not understand anything because it's a simple greeting bot. But you can add interactions to help it understand. For example, you can extend this flow chart in this diagram that you see here. You can add a couple of options. You can send a response, you can ask a question, create a condition, whatnot. So let's ask a question. Let's say, so when you say ask a question, it is prompting for a text, and it's and also entering a user response. So you can say, my name is Eva, and what is your name? So there, you can ask, what's yours? So that's something that we're expecting the user to answer. Now, inside the user response, you would go in and you can add that to any single property variable. Say, I'd like to keep that in user.input, and that's a variable that will contain that name. So I am greeting the user, I'm asking for their name, they would hopefully enter that. And I also want to, if the person has entered the name, I want to say, hey, whatever the name of the person is, so which would be user.input, and just greet them and say, nice to see you or nice to meet you. So it's as simple as that. Right. So these are a couple of things that you can do within the bot. And typically like this, you can add any number of intents or triggers to your bot. Like one of the greeting was a trigger that was available out of the box. You can also add your own trigger. But before you add your own trigger, I also want to show you around this. A bot, perhaps for a bot, the most important thing for a bot is to understand what the user is saying. Right? So the bot language understanding capability is very, very important for the bot. So the recognizers here, there are a couple of recognizers. You have default recognizers, you have regular expression. You can choose regular expression to just get started. So I can add my own intent, and for example, I can add a help trigger. Now, help is something that you would always expect your users to sort of ask you, and you can even expect the user to say something as trivial as, I am lost, I don't know what to do. And what would you do when someone says help, right? You would go in and say, I am Iva, and I can help you with da da da. So you can build that conversation or that interface as you would like, but that is the basic mechanism, or that's the intent behind that. So let's run the bot as we have right now. What Before we did that, so it says, initially it came as a greeting bot. Now it says, welcome to your bot. My name is Iva. What's yours? And I'm going to say Liji. It says, hey Liji, nice to meet you. And if you had to restart the bot again, you would see that it would also answer the help triggers, etc. Now, interestingly, let me show you this. And if I say, my name is Eva, what's yours? And I'm going to type help. I mean, genuinely, I need help. It would say just, hey, help, nice to meet you, which is not exactly accurate. So what we can do here is we can go in, and if you note for the prompt that we added, we also have an option to sort of set the prompt configurations. What that means is there is an option to allow interruptions, which is true. So in this way, even when a user does not give you the exact answer to what you are seeking, they always have an option to interrupt the conversation, which is building a very responsible or a very respectful conversational experience. So that's that. And likewise, you can go ahead and create any number of dialogues or any number of intents. And let's see how this pans out. So I have the bot which says, what's yours? I really don't want to tell it what my name is. I want help. It says, I am Eva. I can help you with whatever that response is. And it also says, my name is Eva. What's yours? So that's the way you can actually allow for interruptions. You can say all these are very small switches here and there, and you really don't need to, do a lot of bit of coding for that. Now, going back there, I have a couple of more things to actually show you. So these are the genuine responses that you can create, even for your welcome bot. I want to say that this is a very simple text. It says, welcome to your bot. It's a very simple text, but I can actually go in there and I can add attachments. I can add speech. I can add images, videos, audios, anything. So add a new attachment, you'd see adaptive cards, hero cards, sign-in cards. So these are the beautiful interfaces that you would typically see in a chat interface. And if you note, there are video cards, audio cards. I want to show you something that I built, or I'm actually building also the ability to add audio, is where you can actually pronounce someone's name. So imagine you really don't know how to pronounce someone's names. You can actually use the audio card and build out the audio card to pronounce someone's name. And I can actually show you some little project that I was working on, and show you that in a bit. So in the interest of time, I also wanted to share some of those other things that you can do using the bot framework composer. So one of the things that you can do here is, let's add a new trigger, and you can before that, I can probably go back to the problem statement itself, what we were trying to do or trying to accomplish using this, right? So let's go back to my slides. And, we were exactly at the composer part, and we did cover these sections and the bot framework composer, and we were looking at the free. Now, your bot is the face of AI, but what exactly is the brain? So all the brain that is powering your bot, all those Azure AI services, or those really powerful services, does not have to be built by you from scratch. So when a user asks a question, your bot needs to understand the user. The bot needs to understand what the user is saying. And for that, you have a service called language understanding service. You need to know what to respond. And for that, you have a service called Q&A maker. So similarly, you have a lot of pre-built AI services, no kidding, available totally out of the box for us to consume. You need not be an AI ML engineer or a data scientist to be able to do this. You can very well just consume these APIs and those services. So I've actually tried using these services, and I can actually show you an example of that in an inclusive language bot. So meanwhile, while that gets loaded, I can also show you this that I was trying to build. So this uses the audio card, as I was saying. So if you typically have a new member in your team and you do not know how to pronounce their name, you would usually walk up to that person and ask someone you know how to pronounce the name. And especially as we work in global diverse teams, it's quite difficult. It is a challenge to sort of pronounce someone's name, right? And it's very, very important that we do. It's very respectful, and it shows a lot of inclusivity. If you've noted a small feature in LinkedIn, what they've done is that they've given you the option to record an audio recording of your name and to upload it. And imagine if we did that for all the members on our team, and we uploaded that in the safe space in the cloud within your tenant. what you could do using a chatbot is anytime you want to know how to the best way to pronounce a person's name, you need not ask anyone. You can even ask a bot. So what I've done here is I've just entered my name, and it comes back with an audio card which tells you exactly how to pronounce my name. Richie Thomas. I don't know if you really heard that, but that is a feature that comes out of the audio card. It's very simple to build that using a bot framework composer. So as we were discussing, one of the things that I wanted to show you was the ability to, call an API. So this is an API that I called, and this is using the Azure Text Analytics Services, the one that we were discussing here, the last one. So the text analytics service is quite powerful. It helps you analyze the sentiments, analyze the emotions. You even get to understand what language you are talking in. So that is cool. So let me go back and show you that in the bot framework composer. In fact, I have tried that out in Postman. If you want to see that a bit, this is there are a couple of services that are available. So you have a languages services which will detect the actual language that the user's request is in. You have a sentiment analysis API which will return the sentiment. So you can do quite a bit with that. Now, what I have used here is a sentiment analysis API. So here, as you can see, I have called an HTTP request. Now, how I would have done that is access external resources and send an HTTP request. That's it. So if you look at this, I want to walk you through the properties here. It's very simple. It's a post method. This is the URL of your API service. This is the body of the document. And you provide your headers just the way that you would provide in Postman, right? So in Postman, whatever headers you're providing, whatever body you're using, use the same things here and just call it into a result object. Next, what I'm doing is I'm checking the condition. So I know that it will come back in the sentiment is going to come back in my content object. So I'm checking what the sentiment is. And if it is negative, the bot would probably want to recommend to the user, you know what, this could be perceived as negatively. Do you want to consider or do you want to reconsider doing that? So those are a couple of things that you can do. And likewise, you can do for the language as well. So if you are in a team environment and imagine in a group chat, right? And then assuming West Indian, inadvertently, we tend to use certain phrases that is quite common to us. And maybe some of our friends will not be able to understand that. So I might talk in my local language, which may not be comprehensible to the larger team. So especially when we work in a global team, in a diverse workforce, it might be important for us to keep or stick with the language that is commonly understood by everyone. So those are some of the things that you can do. So with that, you can actually use the language detection service to detect the language that you're working in. So let's do this. So I'm going to try and detect the sentiment. And when I say detect sentiment, I wanted to show you here. This could be perceived negatively. Would you like to reconsider? So I did not quite show you the body of the text that I put in. I wanted to show you this. The text that I entered here in the body is, I'm frustrated with the results. Now you can rewrite this for anything. It would detect sentiments for that. I'm angry and I'm not really happy with the results and things like that. Imagine you run this job in the back end of a group chat, and it's able to proactively tell you that, hey, you know what, that might be perceived negatively and you might want to reconsider that. Same goes for language detection as well. And so those are the ways that you can actually use API services within the context of the composer itself. And if you look at it, I've not written a lot of code for that. It's just very simple properties that I've called. I'd like to go back to my slides and talk to the next level of inclusion that we're talking about. So we also kind of talk about the inclusive language, and it's not just Microsoft. A lot of folks in this space are talking about inclusive language, including Google and Apple. It's very important now that we deal with diverse communities and we talk about inclusive language. And there is an exclusive initiative called the Inclusive Naming Initiative. Now, this was started by the Kubernetes community. This was born out of the efforts of the Kubernetes community. And what they have done is they have created a whole website of names or the recommendations that they have. I mean, instead of using this, why don't you use this? And the reason as well. So that's a great way to actually approach that. For example, if I were to just show you this part again, it may be because of our ignorance we could use words like crippled or lame or handicapped, whereas imagine having a bot in the picture where they kind of remind you, did you mean person with disabilities or persons with disabilities, which is a more appropriate language to use. So using person first language. Now, there is a way that you can do this. As you have seen, you can manually create the triggers for each and everything that you want to restate, and you can do that. But an easy way that we can also handle this is by using Q&A. So Q&A is a knowledge base. Over here, you can add multiple knowledge bases, as you can see. Now, how you add this is very simple. Let me show you. You can add Q&A knowledge base. I'm going to have, say, FAQ2. And if I click next, I am looking for a source URL. Now, if you remember, one of the things that we did talk about was the inclusive naming initiative. And the inclusive naming initiative had a lot of FAQs that were available on their site upfront. So let me show you that some of the ones that we can really use. So if you have a website with a good FAQ page, you can consider the same approach for this as well. You need not manually type in all the names, from scratch and then try to use this. Look at this frequently asked questions. There are so many question answers that are available here. Similarly, they have actually changed the tiers. Like in tier 1, which is very, very important terms, we should not use terms like abort. We could rather use terms like end, halt, stop. Similarly, instead of whitelist or backlist, use terms like allow list or deny list. Instead of master slave, use terms like primary, replica, so on and so forth. So you have a lot of terms like that, tier 1 terms, tier 2 terms. So what I've done is I've just taken this URL and I've gone back to my bot framework composer and I've entered that as the source URL and hit next. That's all. So that could take a while. It could take 2 minutes for it to ingest all those FAQs. But once it's done, this is what happens. So you have all the question answers automatically parsed for you and in the realm. So let's try that out really. So let's say a very simple thing that I could try to say is let's see. I go back here. Yeah, I could use something that we typically use in our daily lives, especially when we deal with Azure. Is let's a team member could say, can you whitelist this domain? Very, very simple thing to say. And if a person is, now this is also important that we set a very safe space. It could be good for someone else on your team to also say that, but if you don't want to be perceived as the bad person on the team, Iva can actually do that job for you. And Iva would suggest, may I suggest using allow list or deny list instead of using whitelist or backlist? So you could also go back to ICE and ask, what's the problem with the whitelist? What exactly is the problem or the issue with whitelist? And it could even give you the reasoning for that. So as to why you should not use certain terms, etc. So imagine having this kind of a repository within your team, and you can inject this and integrate this into specific places in your application wherever you deem fit. For example, to go back to my slides here, what all can I assess? So we're talking about creating inclusive workspaces here, but you can think about doing this for your source code, for your documentation, integrating this with your CI/CD systems. Think about having this for your PRs when you submit that, and all of this can go in for your naming, for your nomenclature. You might be using Grammarly for your spelling and for your pronunciation, etc. So imagine this to be an inclusive Grammarly that will take care of your larger set of requirements. Cool. As we come to the final leg of the presentation, I also want to invite your thoughts to this. We discussed a lot of features, a lot of high-end capabilities available out of the box. People typically ask us, what is our number one priority when designing a bot? Do we need to have this feature? Do we need to have that mechanism? I would think always it's about the conversational user experience. I mean, the reason why we're building a chatbot itself is to have that human kind of interface. So the minimal back and forth that you can have with regards to creating those turns, the better, the easier the devices and platforms, decide which one to target. Your language should be understandable by the bot, context should be made available, and how do you guide the user? If you're stuck somewhere, how do you help the user escape that path, allow interruptions, so to speak? So conversational user experience, or CUX as we otherwise call it, is perhaps the number one priority, I would say, for designing a bot. And I think that's the last. We come to the summary of the slides. And so a quick recap of what we did. We did the history of conversational AI. We did Microsoft conversational AI, took a look at the capabilities there, at the composer, looked at the demo and at the Q&A. And yeah, so that I am open to taking Q&A if any. And I also like to thank our partners and our communities who have supported us here. And and please leave in any feedback that you may have as well. Thank you. And over to you, Lakshmi.
Hi, Liji. That was a great session about explaining about how the chatbot works, and with all the how the communication and how the application which we are going to use it, how it can be. So it was a great session I'm having with you. So we'll wait for a couple of 4 minutes so that to get some questions. And
Okay.
and before that, I have some few doubts. So how this chatbot can be integrated with any channels or that via APIs, right?
Yes, they can. So we did not cover that in this presentation, but what we can do is we can publish it directly to Azure or to Azure, and then from that cloud, within a single click, you have the option to connect it to Teams, connect it to Slack, connect it to Twitter, Facebook. There are a couple of channels available out of the box from Microsoft, and with a single click, you can actually connect it to that. So it's basically the same source code that you write for your chatbot can run with minimal to no changes across these multiple platforms. And that's perhaps the most beautiful feature of the Microsoft Bot Framework SDK.
Oh, that's nice. So let us wait for a couple of more minutes so that there was any questions from the audience side, so that we can take
Okay.
it up. Yeah.
All right. Thank you so much for the time, and I apologize for the inconvenience once again. Thank you. Thank you, Lakshman.
Not a problem.
Thank you.
Let's wait for. Sure. Mm, let's see if there was any. And that was a great session so that everyone can able to use the bot options and they can able to integrate with their channel. So hope you have enjoyed this session, and we'll be coming back on the next session. Until then, Okay. Hi everyone. So hope we are going to have a next session which is regarding building microservice platform using task framework. And I let me introduce. Hi, Ratan. Hello.
Hello, good
Hello.
afternoon.
Very good afternoon.
Uh,
So, so he is going to talk about building our microservices using Star framework. So the stage is yours, Rafael. Hope you
yeah,
can
hello.
share your screen so that I can come.
Sorry, can you repeat that?
Yes, sure. Hope you can share your screen so that they can.
Um, okay, just give me a few minutes. Just give me a few more minutes, like 3 minutes, please.
Fine, sure. So let's hope you get some times, and I will get it there. Hi guys, let me add Rafael. I think he's ready. Hi Rafael or Riji, can we go further?
Oh, yes, yes, we can, we can.
Yes, sure. I will let me share your screen. So the screen
So,
won't
guys,
enter the.
today I'm going to be talking about a, a framework that I discovered that is very exciting and interesting, and is a member of the Linux Foundation. It's called TAS. So I'm sure that a lot of us have not heard anything about TAS before. So before I say anything further, I'd like to tell us. I'd like to give us a nitty gritty about everything that TAS is all about. It's the first question that anyone would ask is, what is TAS? TAS is a project of the Linux Foundation. So just the same way Kubernetes and Jenkins are members of the Linux Foundation, and they can help you scale your microservices. That's how TAS is. So hold on, just give me a minute. Okay, so hold on a minute. I'll be back with you guys. So, like I said earlier, TAS is a member of the Linux Foundation. So, if you go to the Linux Foundation website, you you type the list of projects, you'll find TAS there, and they actually have been in business for a while. It's a separate foundation on its own before joining the Linux Foundation. So, someone that has not heard this word TAS before might be saying, "Ah, what is TAS?" So TAS is a new generation of distributed microservices application framework. It was created in 2008. So they didn't just start today. It's been tested and they've been running. A lot of companies have worked with them before they actually decided to join the Linux Foundation. So it provides developers and enterprises with a complete set of solutions to build, release, deploy, and maintain the application at scale. So the same things you can do with Kubernetes, you can also do with TAS. So I know that a lot of us here, we like certifications. So the TAS Foundation has certifications for companies. They also have for individuals. Like as a developer, as an administrator, you might want to you might want to uh, you might want to, like, okay, where do I start from here? How do I go about this? The same way when you go to check the website of Linux Foundation and you want to register for Kubernetes, it's in the list. As you're scrolling through, you'll see that there are some of the options that you can get from Linux Foundation, and they're exactly the same price you find. No, it's not. It's not the same price as Kubernetes. This one is $250. Currently speaking, Kubernetes is 375. This one is 250, so it's a little bit cheaper. So now before we begin, the today's talk is all about TAS. And before we begin, TAS is all about microservices. I'm sure a lot of us that are here because we are in the development space and we know what a microservice is. But if you don't know what a microservice is, I'd like to go through it a little bit. Microservices a type of architectural style that are used for creating high, highly scalable uh, and testable, loosely coupled and independently deployable applications. You can use them to, they most small businesses most small businesses they actually use microservices because in the next slide I'm going to be talking more about I'm going to be talking more about this because you have a monolith, you have microservices. Currently, as we speak, there is more benefit to for your business to be a microservice. Because if you're not a microservice, that means you need to, if one little thing is having a problem, that means you need to work on the whole application, which might be costly, which might have a lot of issues. Okay, um, so the goal of task foundation, task foundation is there to address most common problems related to microservices application, including solving multi-programming language interoperability issues, mitigating transfer issues, and also issues with data storage. I'm sure that a lot of these things we can do with Kubernetes as well, but with tasks, it's a little bit robust and different. I'll As you go along with the lecture, you see why I said so. So as you can see, in a monolith, you have a complete whole application with all the components in a box together. But as a microservice, each component is independent of the whole big. Each component of the application is independent of the whole thing. So if there is a problem, you can easily remove one and work on it than to have to work on the whole thing. So moving forward, one reason uh, why I said task is different, as you can see, it's a it's a it has a collection of everything that you need. You can do CI/CD in it. You have option of so many languages. You can use C++, you can use Java, you can use Node.js, you can use Go, you can use Python, you can use .NET. It has flexibility for languages. You it's not like restricted to one language, so it's developer friendly. And and for the issue of governance, it's more flexible than. So the truth is, you might want to look at this if you're considering any other option for building your microservice. What I would advise is, uh, as a developer watching this uh, this session during this conference, I'll advise that you talk to your boss that you want to try something else, and just give this a try and see how it works for your company's workload. So another reason why you might want to try uh, task foundation is that it has a robust uh, it has a robust community as we speak. I know most of us in this side of the world might not be too familiar with us, but towards China, and one thing we should know is that the Linux Foundation is is open to a lot of projects. So so in China, actually, there are a lot of companies actually already using TAS. So the TAS Foundation, it opens is open to a lot of open source projects. So the members would work together with other members to make things move forward. So and and I really advise, that if you have option of trying out other frameworks for your business, you should, because TAS is friendly. TAS is uh, they have thought leadership. They've been tested and tried for over 10 years, and they're working for Linux Foundation to have approved them to be a member. That's to tell you that it's really good. So going forward in your models, you have infrastructure as service, your software as a service, and platform as a service. So TaaS framework uses the platform as a service model. You just bring what you need to do, and it will run on your. It can run on physical machines, though virtual machines and container. TaaS is very flexible, so you have all you need to make your application workload scale. So for the ecosystem component, when we look at storage, you would all agree with me that I don't want to talk the negatives, the pain points that I've had as a DevOps working with the popular ones. But with us, with us, you you can store data in cache. You can store in DB and file system based on your work need and your workload. So for cache, you can use Redis and DC cache. We all know what DC cache is. It's a distributed in-memory NoSQL system, which is based on task framework. So it was built just because of of task. But if you say that you don't want to use the cache, everyone is familiar with Redis. So Redis is still an option that you can use. Not only that, MariaDB, which is the database for Linux operating system, and MySQL, even Postgres, they work very well with us. So for file system, we can use either Ceph or HDFS. So when we want to talk about, I want us to look at another aspect of it. Okay, task framework can support SSL, HTTP, buffer, and customized protocol. So it's everything that you need to make sure that your application runs. Task will do it for you. So before I proceed, does any one of us have a question? I'd like to take. Do you have a question?
Hey, Rafael, I think there was no question or present, so you can proceed with your presentations. Once there was a question, I will take it from. I will make a notice of it for you.
Okay, no problem. But before uh, hold on, just give me a minute. So, guys, uh, um, I'd like to talk about some components of the task framework. We have the server, we have the task node, we have the publish, we have the heartbeat, and the client. So the thing is, everything comes bundled. Everything comes bundled. The server is a program just like as a conventional server is in the real world. A server is a program that provides functionality to other programs. So it's robust. It's not too different from what you are used to. It's it's like, it has a lot of similarity with, so even though you say that this came from China, but the truth is the components and everything are similar to what we are used to. So like task node is a process which manages server by starting and stopping publishing. The heartbeat is a signal generated by the hardware or software to indicate normal operations, just like it is in so in the real world, a client is a piece of computer hardware or software that accesses a service made available by server. So it's exact same processes that we have in the other stuff that we have in TAS as well. So it's not too different. It's not too different to learn. It's not too different to work with. it's it's not too different to work with. It's not too different to learn. All you just need to do is to try. And Task Foundation is actually very open and very flexible. So they give their courses. If you make up your mind to learn tasks, for example, just go to the Linux Foundation website. There are a lot of materials that can help you get started. Like a lot of materials can help you get started for free. And if you want to join as an ambassador, currently as we speak, the opportunity is available. You just need to go to the Task Foundation website, fill the form, and you'll be made an ambassador, because currently as we speak, it's not too popular in this side of the world. But so they need a lot of people that would want to push events, want to talk about tasks. So if you that is listening to me, you want to you want to learn, uh, you want to champion this in your organization, you want to convince your boss uh, on how they can use other frameworks that are friendly, faster, not expensive, that have been tried, just go to the website, look for the form, and fill it, and everything that you need to get started will be given to you. So um, uh, what is a node? A node is a computer that we can use to uh, run our service, that we can use to do our work, or work on our workload, just like as it is in Kubernetes. So in tasks, the node has a lot of components. I've only listed two here, but I've made mention that if we want to learn about tasks, we we are very free, because just go to Linux Foundation website, look for tasks, and and proceed from there. So two of the components that I've mentioned that I'm going to be talking about here is TaskWeb. TaskWeb is a web management system which monitors the runtime status of servers. It helps for start, deploy, and publish. So just like us also, in Docker you have Docker Hub, but in Docker Hub it's used for storing uh, images public accessible to the public. But in TAS, it, it's not for storing images. It's a control management server that's responsible for service configuration and service discovery. So TaskWeb uses the registry to start, stop, and publish services. I find the concept of load balancing in tasks very interesting. Okay, so but the truth about it is the same definitions you have for round robin, hash, wait, is everything. So nothing is different. So if you want to get started on your journey with tasks, your learning curve is not too steep. It's flexible. Uh, you can actually catch up very fast, because everything that you are used to in the real world is almost the same thing you'll have in tasks. So there's another one that interests me that I want you guys to look at, uh, to see if there is a system of handling overload. You see, it checks to see if the queue is overloaded, and it records them. I think this is similar to this is not too different from what we are used to in other systems. So it works efficiently. And the next thing I want to talk about is code management. It usually means code management means the management of changes to source code. Changes to code usually identified by a number of letters or letter code. Tasks can integrate with other uh, uh, source code management system like JIT and GitHub, and all that type of application that you can deploy in SaaS. So most application, regardless of the industry, can be deployed on SaaS, okay, on tasks. This include your AI, your machine learning, and a few others. So you will not say that because you're deploying uh, a different kind of workload. So every typical workload you can think of, you can use on tasks. The biggest users of tasks as we speak are the fintech companies. The fintech companies are usually faced with a lot of pressures because uh, in 2021, as we speak, we have, if we try to circle back a little bit, 10 years back, the banks would open in the morning and probably by 4 o'clock they closed. But currently, as we speak, with the use of mobile phones and others, the banks are expected to be on 24 hours, because when the bank is closed, your phone is supposed to give the service. So because of this, there's a lot of pressure on the fintech companies to they have to be efficient, they have to be available. So a lot of them have recognized uh, the benefit of tasks. It helps them to reduce their costs. It helps them to scale up and down, and there's data consistency with tasks. I'm supposed to do a demo right now, but I'm not going to be proceeding. As I told the organizer earlier, I'm going to be leaving early, but I hope that I've left you with quite a few things uh, during the explanation of tasks. Task is not too different from any other framework that you have. It's it's not too different from any other framework. It works is a member of the Linux Foundation, and the learning curve is not too deep, it's not too steep, because everything that you already know as a developer, the the terms, the terms, the words they use are not different. Everything you already know as a developer is what you meet here, and the framework is so robust that you whatever language that you know, if it's Node.js, it's Python, it's Go, whatever language that you can work with, class would allow you to work. So for those of us that want to get our hands that want to get started, I'll advise you to just go to Linux Foundation website and check tasks from there. You would understand more about tasks. So I hope that with these few points that I've shared, I've I've pricked your mind a little bit. Um, I've been able to kind of like show you another way that you can use to work with your microservices, especially if you are thinking of options apart from what is already available. And also, for me, I think that there's no harm in trying. So that's all for now. Thank you.
Thank you, Rafil, for your wonderful session without the circumstances. So hope the people is able to view and know what actually the TAR framework is, what they can able to do it, so where they can able to start those kind of stuff. And I really appreciate your time and really appreciate your the things which you have shared with our audience, so that they can able to learn and they can able to get start from the on the TAR framework using the on the microservice platform.
All right. Bye for now.
Thank you and have a nice day.
And you too.
I halt. So hope our next session will be on the stop 4 o'clock. So that till that we'll be on. Hello everyone. So hope our next session is going to be on the MLOps, how to manage your machine learning model. And the speaker is Abhishek Shukla. Hi Abhishek Shukla.
Hey, hi Lakshman. Very good evening. How are you doing?
Good, and let me share your screen, and the stage is yours.
Thank you. Okay, so guys, is my screen visible? Yeah, can you please confirm? Okay.
Yeah, your screen is
O-
visible.
Okay, so thanks Lakshman. Thanks for giving me this opportunity. Thanks for the entire team of AZCon. Uh, so welcome you all for the today's session, and the today's session is related to the machine learning life cycle. So it's in short, it is called as MLOps, and we will discuss that how MLOps can help us to manage our models. The entire life cycle process of machine learning can be managed by using the MLOps. There are a lot of tools available, but in this session, we will discuss more on the Microsoft Azure Machine Learning Studio. So let's begin. And before starting, have some brief about myself. So my name is Abhishek Shukla, and I'm a senior cloud architect in HCL Technologies. Those who would like to reach out to me over the LinkedIn, they can reach into my LinkedIn profile, and you can find it me over the LinkedIn. As well as those who would like to drop any message or would like to, they can also reach to me through this AZConf channel. And the agenda for today's discussion is like we will discuss about some background about the machine learning. Then we will discuss about that what are the various challenges which normally developers, or you can say uh, the anyone who is involved into the machine learning uh, faces such kind of challenges. And later on we will see that what is MLOps, how MLOps can help us. And in last we will see two demonstration. We will see that how Azure Machine Learning Studio can help us to achieve all or to handle all the challenges. And later on we will see that how we can create an automated pipelines by using Azure DevOps in combination of Microsoft Machine Learning Studio. So let's begin. And so if you can see, like in this slide, I have simply said that how we start, right? So whenever we used to start for anything, we have some kind of statement. You can say it's a problem statement, or you can say it's a business statement. And whenever we say that, okay, we have certain requirement, then we used to think about their solutions, that how that particular problem can be solved, how that business requirement can be met. And these solutions can have various technologies and tools available. So for an example, if we will consider the ongoing pandemic of this COVID-19, we have to predict like when the third wave will be there, how soon we can get rid of this COVID-19, or how soon a new variant of the COVID-19 will get emerge, and what will be the frequency or what will be the fatalness of that newly discovered variant. And now we have the problem statement. And if we would like to find out this problem, definitely we have to think about the possible solutions. It's a large problem. It needs a large amount of data. When we need a large amount of data, we need that how we will go to manage the data, from what are the various sources, from where we will get such data, whether the data will be correct, or we have to do some sort of cleaning operations with that data. And then we think about it, that what will be the best solutions. Do we need to use some sort of ready-made solutions available? Do we need to use uh, or do we need to develop our own solutions if ready-made solutions are not fulfilling our requirement? And later on we used to we come to know that okay, these kind of problems can be solved by using machine learning. So you can say that okay, we have the business requirement, and nowadays we says okay, let's explore machine learning as a solution for our business requirement. And from this particular point of time, when we said okay, we are going to use machine learning to solve our specific kind of problem, maybe it's related to COVID-19 pandemic, it's related to fraud detection, it's doing some sort of security analysis or behavioral analysis. When we said that machine learning, we are going to use machine learning, then a entire ecosystem comes in place that will be involved to achieve our solution by using the machine learning. And in short, you can say that machine learning project lifecycle begins as soon as you say that okay, we are going to use machine learning to solve our business requirement or the problem. So as you can see that in this, whenever you have that, you have to first define your requirement or you have to define your problem statement. So once you will define your task, you need the data for that. As I said, that data can come from the various places. If you can say that data may be stationary data, you have already some historical files, or data may be a real time data that is generated per hour basis, per day basis, or sometimes you can say bi-weekly basis or monthly basis kind of data. So you have to take all that data in a place, and then you have to do the exploration of data. In technical term, you can say that you have to do the exploratory data analysis on that data. Once you will explore the data, then you have to find it out that what are the various attributes of that data that can help you to solve your problem. Means you have to do a feature engineering. You have to identify that okay, these will be the features which can help you to predict, which can help you to build a specific model. Once you build a model, then the another challenges comes in, that how we will deploy this particular model, what kind of resources will be required to deploy this model. Are we going to deploy this model into a out of the box solutions provided by any vendor, you can say the AWS, Azure, or any other cloud, or you are trying to create your own infrastructure to develop your model? Once a model has been deployed, so job is still not over. You have to manage your model, and the real challenges begins here, that how you will try to manage and maintain your model, how you will monitor the model, because monitoring the model is not an easy task. You have to consider so many things when you are planning to monitor your model. And in the overall scenario, you can say that you have to manage the life cycle of the entire process, which we generally say that okay, we have to manage the life cycle of our models. Whenever you thinks that okay, we are going to build the model, and as I explained earlier, that a entire ecosystem, and ecosystem consists of so many stakeholders, so many engineers, different types of peoples. These types of peoples can be from the technical background, they may or may not be from the technical background, or they may or may not be from the specific area or the specific technology which you are going to use to solve your problem. So typically we can say that whenever we have to develop a machine learning models, we have to use, or we have to deal three different types of peoples. One, you can say the data engineers, those peoples who are responsible to orchestrate the data for you, those peoples who are responsible to collect the data at a single place, so that it can be further used by the other peoples, or you can say it can be used either by the data scientist itself, or they can be used by the data architect or data engineers. When you will see that what kind of task these two peoples will be do, so you can see that the very first things you have to do is the code management, right? So whosoever is the data engineer, or sometimes you can say the data scientist, they have to perform the code management, what kind of code they are writing, either for capturing the data from the various sources, or just uh, doing some analysis of that data. So the code management, then you have to manage the data, you have to do the versioning of the data. For an example, in the current ongoing pandemic, you cannot predict future by just using a historical data of that is 1 year old. You have to look for the various conditions. You have to see that okay, how many people are already vaccinated, how many people are already have the the complete vaccination course they have done, whether they have suffered with this pandemic in the recent past, or they have suffered this pandemic into the stage 1 or stage 2. uh, then you have to see that whether this particular data is the entire data is available, or the data is collected day to day basis. So whether the full data is available or the incremental data is available. Later on, you have to place that data into a centralized location. You If you are collecting the data from the various states, countries, or the geographical locations, they should be placed at a central location. So data management is a must part. Once the data will be available for you, then it comes to the data scientist. Sometimes it is also the job done by data engineers also, if they are well qualified for this particular section. But especially you need data scientists to that. And when the data scientist comes into the picture, they use to explorate the data. They have to perform certain iteration onto that data, and to perform these iterations they used various tools. In general, you can think about it that yes, we use the Jupyter notebooks normally, but if you would like to do the same things by using other tools like Python, yes, you can do by using the Pythons and the R also. But a generic solutions, or a widely used solution, is the Jupyter notebooks. And into this model building, you have to log all the metrics, you have to log all the artifacts which are getting produced during your model generations. You have to identify the various parameters, you have to identify these parameters for the various auditing, as well as you have to see that how many iterations will be required to achieve a fruitful solution. How you have to identify, how you have to modify your algorithms, your code, according to the number of features or the features selected. During this iteration course, you will find out that okay, sometimes you have to use some new features to predict your model, or sometimes you have to leave certain features. Then you have to manage the metadata, as well as you have to manage the data lineage for all. Then you have to think about the infrastructure provisioning. So you have to provision the infrastructure. When it comes to the data scientist or the data engineers, they used to as I said, they just use this Jupyter notebooks, and they say okay, this is the code, this is the data. While we are combining this data with the code, and here is our model. And right now the model is already deployed or running into in my local PC or anywhere else, and by here you can use to test it. Later on, once the model has been done, you have to do for the model management. You have to look for how you can manage your models. The model management has so many activities. The first thing is the centralized location where you will place all your models. So you can say that you have to register your models into the model registry. Then the versioning of your model. When we say versioning of the model, so it is, you can think about it like okay, it's more or less same as the versioning of the code, but it is not like that. It's like the versioning of your model. When we say versioning of the model, means you have to version that which algorithm you have used to build your model, or the specific version of a model, which data set you have used to train your model. So you have to do the versioning for all those things. And into this versioning, you have to log all model metrics. That confusion for an example, you can say the confusion matrix. You have to log all the outputs. You have to log if any images are getting produced, or any parameters which are used to train your models, the specific parameters, you can say the hyperparameters. Then the metadata of your model. Once your model has been created, to deploy your model you need computation power. And how you can decide that what kind of computation will be required to host your model, you have to do the model profiling. And this model profiling will help you to identify that what will be the memory and the processor requirement. In short, what will be the compute requirement which will be required to host your model when you will go and productionize these things. Then So we have seen that, okay, data engineer has done our task, data scientist and data engineers in combine have written the model is ready to productionize. Then it comes for the operational teams. So who is going to maintain and manage the model? So the very first things, the very first operation I will say, that's the governance of the model. Some authority or someone responsible have to approve or reject your model, whether they are going to use this model in production or not, or if some modification is required into the model. Then the notifications, if your model is not giving the correct output, if your model is not giving the correct uh, outcomes, then you or the developer, or you can say the responsible stakeholders or the respective teams need to be notified. So the notifications, then the model deployment. Operational teams will decide that, okay, the model will be deployed manually if you are just using a small problem, or you are running into a small I will say the machine learning life cycle, or you are in a very small organization where only one or two models are uh, getting used. Then yes, you can say that, okay, we will do our model deployment as a manual process. But if you are working in an organization where a number of models are running, numbers of models are running for the different purposes, then you should think about it, the automated deployment of the model. When we say automated deployment of the model, then it comes to the provision of the infrastructure. Whether you will do the provisioning of the infrastructure by manual, or you will do the provisioning in an automated way as soon as you are going to deploy a new version of your model. Once your model has been deployed, then it comes to the endpoint versioning. I have seen uh, that in a scenario when we were not able to trace back that where my model is running, or which version of the model was an endpoint serving to our test environment. So it's a practical problem. You have to think about the endpoint versioning. By having this, you can say that, okay, if you have a certain set of customers which will use a respective endpoint, you can say the endpoint A or the endpoint B. How you will divert the traffic, that's not the scope of this session. But yes, you can use any traffic manager, or you can say the in Azure, you can use Azure front door to divert the traffic. You can decide, okay, that how much traffic will go to the endpoint A or how much traffic will go to the endpoint B. So this you or your operational teams need to take care of, that how the traffic management will be done for your model deployment. So this is a practical problem which a operational teams need to take care of. Then the smoke testing of your model. Before productionize your model, you have to do some smoke testing. Or even after the productionize, you have to test your model, whether the model is working or not, whether the model is scalable or not. If the large number of traffic is coming to your model is ready to serve it or not. For an example, the fraud detection. If your model can detect a credit card fraud at a real time, it's good. But if it is taking, say, days or weeks to detect a fraud, your model is bad. You have to re-engineering your model. You have to think about whether you have to do the reiteration for your model. Then positive and the negative unit test. You have to see that your model should be reliable. It should give the accurate result in each and all scenarios. Then the data captures means like how your model is getting used, the real time input and the prediction captures. So you can see whether the model training algorithm was correct or not. All the results which are getting predicted from your model, they are correct or not. You have to store all such things into a centralized location. And yes, you can organize all these data captures in a timely manner also. So you can say, okay, that this is the data captured into this just 1 day or 2 day or in a week. Then the most challenging problem is the drift monitoring. Drift monitoring means the drift into data. When your data scientist develops or creates a model, it gets created into the standard conditions. We have is a specific data set available on which your algorithm is executed, your model gets trained by using one iteration, two iteration, or n number of iteration, and it deployed to the production. We cannot say that into the runtime or in the production when your model will get deployed, you will always get the similar data available. There are chances that your data will not be the same which you have used into the productions. So pre-processing of the data is definitely required. When you detect that yes, the actual data which is getting served to model is different than what you have used into your development environment, then you have to retrain your model. You have to iterate this process with the actual data which you are getting into a real life scenario. Then you have to see that your model should be consistent because your data is getting changed. Whether you will serve those data inputs or not, it's up to your I will say the decision that what kind of data you would like to serve it. But yes, if data is getting drifted from the standard data, you have to reiterate your models. So we have seen that we have three different types of peoples available. We have data engineers, we have data scientists. So engineers, they collected the data, they given the data to the data scientist. Then data scientists start working and creating the models, and it goes to the operational team, and operational teams start putting and start operationalizing the things for the end users. The challenges begins here. The very first challenge which you can think about it, like, okay, the how the model will get packages, right? So I will say that this is a challenge, but you can count it into the activities. So whenever a model has to be created, you have to package the model. Whenever a data scientist has written some Jupyter notebooks, and you before deploying it to the actual production, you have to package the model. You have to select that what kind of format you are going to use to distribute your model. Then you have to think about the performance monitoring, as we have seen that okay, whether your model is performing well or not. You have to version your code so that at later time when you think, for an example, that in a situation of the data drift, you can zero down that which algorithm, which code, and on which data set this particular model was getting generated, right? And what was the data which was used for train this model. Similarly, you have to do the scoring so that you can predict your data. Now, in this overall process, we have identified certain challenges. So the first challenge is the coordination challenge. We have seen that the data engineers, data scientists, and operational team, we have three different set of peoples involved here. Data engineer's job is over once he has put it the data. You have captured all the data and stored the data into a centralized location. Now when it goes to the data scientist is used to work onto the data. Data scientist is not think about it, okay, whether the data is coming from the right source or not. They always assume that yes, data is coming from the right source until and unless they find some anomalies in data which clearly says that okay, this is not the right data. And data scientists are used to have this their algorithms. They used to run their Jupyter notebooks. They place there into just one folder, or you can say they are placing that there into the data repositories or into your code repositories. Then it goes to the operational team. So operational teams is again blank for it. They do not know that what this data model does. They do not know that where is the data. They do not know that okay, what kind of infrastructure is required to productionize this model, how this model need to be deployed, how the traffic managements need to be done for that. So these are some challenges which you can say that's a coordination challenge between the different people's involved into this model generation process. The second challenge, as I said, deployment challenge. Nobody knows that, okay, how we have to deploy the model. Do we need to create a virtual machine? We need to deploy it into a containers, or we have to use some the clusters where you have to deploy. And if we are planning to deploy, that what will be the underneath infrastructure required to deploy this particular model. Iterative development and experimentations, like who will do the iterative development once your model has been deployed. Data engineers have put in the data scientist has created the model, and ops team has deployed the model for you. Now, how the iterative development is going to happen, how a data engineer will come to know that, okay, data was not correct or there is some data drift, how data scientist will come to know that, okay, there are certain new features available into the data that can be leveraged to enhance the model, and how they will come to know that they have to re-experiment to their models. Validations of model, who is going to validate the model, whether the model is giving the right predictions or not, who is going to validate the model. There should be the peoples who should validate. There should be a set of processes which should validate that, okay, this particular model which we are going to deploy into the production, it's valid, and it will give the right predictions, it will give the right output in all I will say in all scenarios. Then how you will go and do the maintenance and the management of your code, how an operation team will come to know that which algorithm was getting used to train this model. If a data scientist who has initially done this modeling, he is not with the team or not with the organization, now nobody knows where the data is and what kind of algorithm was there. If a proper versioning mechanism or proper code maintenance mechanism is not getting used, then nobody knows that how it can be tracked back, that, okay, to have this particular specific version of the model, this is the specific code which we have to look into it if we have to do any enhancement or modification inside that. Reproducibility of the models. Guys, just give me one moment. Okay, so the reproducibility of the models. If you need to reproduce your model, then how you will reproduce the model? How you will identify that what will be the steps required to reproduce the models? So these are the certain challenges which you have to take care of that. Then, as we have seen, the infrastructure requirement. So yes, it is also another challenge that how this infrastructure uh, can be meet up, how to identify that what kind of infrastructure will be required to have this. And the another challenge which we have, that is the model lifecycle management. So how you can manage the life cycle of your model. After seeing all such challenges, industry come up with certain solutions, and these solutions are named as ML ops. So you can say that ML ops is not a solution. ML ops is a set of practice that can combine the machine learning, that can combine the DevOps and data engineering, and the end goal of this is to deploy your model, to maintain your model in a reliable and a efficient way, right? So we can say that the ML ops is the combination of machine learning, the DevOps practices, and it's the combination of data engineering. So you can see here, like data engineering, the task of data engineers, machine learning, the task of machine learning scientist, and DevOps, the, it's again I will say the job from the operational side, but again it's a combined responsibility. When all these three stakeholders comes into one place, or they follow the best practices available for data engineering, DevOps, and machine learning, it's known as MLOps. So as I said, that MLOps is a combination of machine learning, it's combination of operational things. Then we can see that there is a the very much scope available for to do the automation of the things. So we can say the MLOps is simply the DevOps for the machine learning, and the automation can be done onto the machine learning side. Automation can be done onto the dev side, and automation can also be done onto the ops side, right? So the operational things can also be automated. Here you can see that when we have the data and the model, we can say yes, if someone has the data and the model, now developers means the data scientist can do the automation onto that, and they can create their model, they can plan, they can package the model, they can verify it, they can verify the data, they can verify the model also, and later on it can be submitted to the operational team, so that operational team can deploy your model, and operational team can plan the release of your model. Operational team can plan the configuration that is required to productionize your model, and once the model has been productionized, they can monitor your model, and if something found, they can go back to the developers, or developers can go back to the data engineers, or as a joint team they can zero down that what is the problem, where we have to see and how we have to rectify that problem. Whenever we are using MLOps, we have to follow certain guiding principles, like as we have seen that yes, it's a combination of machine learning, it's a combination of DevOps along with the data engineering, and there is a lot of scope available for the automation. But whenever you are doing some sort of automations, you have to follow some guiding principles. So the guiding MLOps also has the guiding principles, and the very first principle is the automation. So automation is like you have to automate as much as you can, and this automation get starts from the data collection, and it's get ended to the model iteration or the model deployment, and later on the model management. Now in automation you can say yes, we can go with the continuous integration, we can go with the continuous deployment also. As soon as there will be the changes into the algorithm, it will regenerate a model, the model will go for some sort of approval process or the various approval stages, and then your model will get deployed. So the automation is the very first guiding principle for the MLOps. The second guiding principle is continuous. Your model iteration process or your model management process should be continuous in nature. It is not like that you are creating a model right now for a frequently changing scenario, and you are planning to use the same model down the line for next 4 to 5 years. No, according as per the timeline or as per the down the line, when if you know that okay, things are getting changes rapidly, then your model deployment process or your model management or model building process, or you can say the entire process should be continuous in nature. You must version your models so that you can easily track down that what algorithm, what data is getting used, and a particular version of the model is getting used into which endpoint. So you can easily identify, or you can easily uh, give this to your customers, to the end users, that what version or what is the correct version which they have to use. Whatsoever model you are generating, it should be reproducible. As and when you need to regenerate the model, you should be able to regenerate the similar model. So it means your data, your code, everything should be available, everything should be tracked down. We have seen that there are multiple kinds of stakeholders available, and a collaboration is a challenge to having a collaborative environment between all these stakeholders. So if you are following the ML ops, it should be collaborative in nature. Every stakeholders or every team involved or the person involved into the ML ops operations, they should be collaborative. So your environment should be collaborative. It should be scalable. Whatsoever model you are using, whatsoever data storage you are using, they everything should be scalable. Whatsoever compute you are using to train your model or to deploy your model, they should be scalable in nature. As and when the demands getting increased, your compute infrastructure and other things should be scaled. You should be able to track down the code, the data, and the model. So tracking is also a major guiding principle for MLOps. Whichever tool you are using, whichever mechanism you are using, tracking should be the guiding principle for that tool or the entire set of process. As I said, testing, that someone has to do the positive and the negative testing, someone has to do the smoke testing. So testing is also another guiding principle of MLOps. Whenever or before deploying your model, you have to test your models. Once your model has been deployed, your MLOps says that you should be able to monitor your model. You should be able to see that how your model is getting used, how your model is behaving into the real life scenarios. Whenever we see the MLOps or whenever we use this MLOps practice, there are certain stages. So the very first is development and experimentation, exactly the same. You have created an environment and your data scientists are getting using it for development and the experimentation. It should be continuous. It should be designed in such a way that it should have the continuous integration. Whenever the data is getting changed, whenever the algorithm is getting changed, your model should be or your process should be able to generate a new model to test it. Then it should have the continuous delivery. So the continuous deployment should be there. So deploy pipelines to the target environment should be there. Automated triggering of the pipelines, sometimes it is needed, sometimes as per your requirement you can say that yes, we will use the manual triggering of this. But again, it says whenever you can say that okay, by weekly or by 15 days we will create a model, or you can say whenever the algorithm will get changed, or whenever we will do certain changes into our algorithm code, we will change our model. And your model should be delivered continuously, means it should be able to use by the end users of your model, and the monitoring and the collecting data about your model performance. So the MLOps has certain components. One is the source control. Source control, like where you will keep your source code for your ML. Means whichever language you are using, either R or PySpark or Python, you have to source control that language. You have a test and build service. You have a deployment service. You can see that okay, all these are the typical requirement of a DevOps site. We need a DevOps mechanism by which we can achieve all these components. You can use any of the DevOps tool available. For an example, Azure DevOps for all these three. Then the model registry. This is something different from the DevOps. This is from the MLOps side, or this is from a registry where you will register your models so that they can be deployed or they can be used by your end users. Feature restore, so that you can say that yes, all these are the features which we are going to use or which we have already used to train our models. ML metadata service, like you can say that the data or the metadata about your the model, like when the model was getting created, what was the source code used for that model. So these are the ML data stores. So these are the component of your ML ops. Now, when it comes to Microsoft Azure, so Microsoft has a very good platform as a service, or you can say machine learning as a service available for the end users, for the developers, for the data engineers, for the operation, the people who are from the operation side. So that is called Azure Machine Learning Studio. It's a unified tool that can be used by every person involved into the model generation process. A machine learning studio has all the features. If you are thinking about from the security perspective, so yes, it has security enabled into it. Only the authorized peoples according to their roles can go and see the entire process. Then it help you to identify and it will help you to deploy your model into the various compute targets. So you can deploy your models, you can use various compute targets uh, uh, to create your models. You can use various things there. Then it supports the experiments, and you can see that how many runs are there. You can see the snapshot, you can see what are the various output files generated, you can see the various metrics and the logs, which we will see all these things into the coming demo. Then it also has the deployment options for your model. So you can deploy your model as a web service, you can deploy model in your ACI, you can deploy your model in AKS, or you can deploy your model into the virtual machines as an attached node. And we have this security related things. So all it has a built-in data store available. If you would like to attach your own data store, you can attach your own data store there. It will help you to create the pipelines. You can say the machine learning pipelines. If you just want to create the machine learning experiments pipeline, you can create there, and you can register your data set also there. So your data sets will be versioned, they will be there. You can use these data sets to uh, train your future models or to retrain your models. And it also has a model registry, so you can register your model there. So let me jump to this Azure Machine Learning Studio to have a walkthrough of this. Okay, so you guys can see that I am inside my Azure space, and if I will go and search for a machine learning, I already have a pre-built environment ready. If I will go here and see this machine learning, I have this so many workspaces available. So first of all, you have to create a workspace. It's process the same as all or any other service. Once a workspace has been created, you have to launch this workspace, and inside this workspace, okay, so we are into this machine learning studio, and here you can say, as I said, that I have a pre-built environment. So we have some experiments here. If you will go and see the experiments, you can see that I have one iris experiments, and within that experiment I have so many runs available. So you can see that when this particular experiment was run, you can have all the metadata, all the history of that run is available to you here. And if you would like to see something related to this particular run, if I will go here you can see the metadata of this. You can see that, okay, whether when this experiment was run, the status of the experiment is completed. It was created onto the October 29th, the yesterday. How much time it has taken? What was the compute target? So I have given a name. What was the name of the file which we used into this experiment, or you can say the file which is getting used to train your model there. What was the input data set? Right, so input data set, you can see that iris data set version 1 has been used, and this is the environment. Now, Azure Machine Learning offers an SDK also. So if you would like to run these machine learning experiments from outside of the Azure also, yes, you can use Azure Machine Learning SDK to control the things from the outside. If you would like to see the various metrics related to this particular run, you can see that I have captured this accuracy, precision, and recall. So here is the detail of this matrix. If there is any image generated during that, so you can see the confusion matrix has been generated. It's not that good, so let it be loaded. Okay, this is the confusion matrix which is getting generated during my model generation, And here is the output. So you can see the confusion matrix output image here. If you would like to see the logs of this experiments when it was getting executed, so here you can see the logs of the experiment. The output, so here you can see the output of the model. So you can say a serialized model file or a serialized pkl file has been generated here. You can see the confusion matrix csv file, so the output of the confusion matrix. You can also see that what is getting generated. The snapshot will give you the details about the code, the what was the particular code that was getting used into this particular experiment, right? So and you can see the explanations, fairness, but these two features are still in preview. And if you would like to use this, you can embedded these two inside your machine learning pipelines by using the sdk, and they will start reflecting here. If you would like to rerun or resubmit this particular experiment, you can do that. Let me go here into the model. So you can see that these are the versions of the model. As soon as I will run a pipeline, a new version of the model has been generated here. And this is the versioning of the model you can see. If I will go and click here for an example like this, so you can see that this is the version 3 of the model. And you can see all the data, metadata available for this particular model that is created here. If this particular model is deployed to an endpoint, you can see that this particular model, okay, so this particular model is not deployed to any endpoint. Let me go and see. So yes, this is the endpoint where this particular model has been deployed. And if someone who would like to test this particular model, you can simply go and test it. You have to provide the input files here in a JSON document. So this is a sample iris data set. You have to provide it, and it will let you know that okay, which species this particular data is belongs. And if you will see the data stores here, so it supports all these three data stores, and here it is the default data store. You can see that what are the various data available. So my sample data set which I have used to run and to create this, it is already available here. If you would like to generate the same by using the CI/CD pipeline, the continuous delivery of the pipeline, so yes, you can also see here. So let me go here. Here we are into this Azure DevOps, and I have some repository available here. Those who are interested to see this particular code, they can visit this repository, and this repository data will be available here. So yes, it's a very good repository from one of my friend which I am using it. And into this pipeline, I have created a CI pipeline here. This particular CI pipeline is leveraging the Azure machine learning SDK. So let me go and open this pipeline. And you can see that the various steps which we have seen into our slide, that you have to create the environment, you have to install certain requirements. Then as I said, I am using Azure machine learning SDK. I need to use Azure CLI, so that particular steps is available here. Then programmatically I am creating a workspace, right? So I am creating a workspace inside my Python file. That Python file can also get found into the repository. But before having this connectivity, you have to connect your Azure DevOps workspace to an Azure subscription. So you have to create a service endpoint, or you can create a managed identity endpoint also. Into this step, you can see that to train our model, once your workspace has been created, means machine learning workspace has been created, or you can say the ML Studio workspace has been created. Then you have to call this for your starting your training of your model. So I am using some inline scripting, and this uh, here. Okay, let me open the another one. So if you will see it here, so that's a different pipeline. Okay, so if you will see it here, the similar things is happening into this pipeline also. The whatsoever pre-deployed models and the environment we have seen, all those has been deployed by using this particular pipeline. So here you can see that first you need, because I am using Python language in this sample to train my model, so you have to use Python. Then by using the bash scripting, you have to install the required component of your PySpark and the Python. Then you have to install the Azure command line extension for machine learning into your build environment. Because this is a cloud hosted build, the build environment will get created onto the cloud. So to train your model, or to run your Python scripts there, you have to install all the necessary things. So once you have to do this, you can create or use the workspace, right? So either you can write the exact code into your Python file, or you can use machine learning codes, or you can use as your ML SDK. You can use inline scripting also. Once it is done, you have to create the compute environment, means you have to create the clusters here. So if you will go here and see this compute environment, you have to create a compute environment here. So if you would like to create the manually, you can create the compute environment here as manual, or if you would like to create by using the CI pipeline, you have to write you have to write the command. So you can use this particular command. And because you have to train your model, so in previous step you have created the workspace, you have created a compute target where and into this particular target your model will get trained. So you have to submit your scripts. So you have to write certain command, and you have to upload your sample, this iris csv data, to the data store of your Azure machine learning workspace. And once it is done, here onto this the step, you have to submit your file, that's your Python file. If you are using the notebooks, then yes, by using a different mechanism you can create your notebooks there also, you can execute your notebooks there also. You can use any C# based SDK to execute your notebooks. You can use Python based SDK to execute your notebooks there. And other means, like if you are planning to use Azure Data Factory to execute there, yes, you can also do that. Then you have to, once your model has been trained and generated, you have to register your model into the registry. And once your model has been registered, you have to publish our artifacts so that later on you can download all these artifacts for your local use or for your auditing and etc. Or sometimes they will also get used to create the release and the deployed or the build pipeline. So let me execute this and save it, run. So a build environment will start getting created. So my build job, the CI integrated job, is now queued. And once the build environment or the build agent will be available, this job get start executing. So you can see that job is getting start executing Python. Now onto this step, the Python components are getting installed. And once this Python components will get installed, then we will have to use this as your CLI. So once this entire things has been happened here, we will see that a new experiment is getting executed here. So you can see that we already have the experiment. I am using the same name of the experiment, and the last execution was onto the yesterday. Once we will reach out to this particular step, this iris training, then we will see that a new uh, status of in progress will start reflecting here. So let me jump back to, and if we have any questions available, we can take the question also. Meantime, our build pipeline is getting generated.
Yeah, hi, Abhishek.
Hello. Yes, you are audible.
Able to hear me, right? So there was no any questions at present, so that you could go with your presentation as further. If there was, I will get notice to you. Sure.
Okay, sure. So let's wait couple of more minutes so that this particular pipeline will get executed. Uh, the roughly it will take somewhere around sometimes 8 minutes, sometimes 12 minutes also. So we will see that before closing of this presentation, it will get done. Okay, so right now we are on to this particular demo. Those who would like to refer this, they can go and refer this DevOps repository for the respective code. Okay, so if anyone have any questions, they can directly reach out to this chat section, or if they would like to reach out after this particular session, they can reach out there also. And let me back to okay, so let me see, like test data is available there. So you can see that yes, existing data set, it will say that data set is already existing. Okay, status complete, iris training, and let me go here. Okay, so you guys can see that a new experiment run is running here. This is currently queued, and I don't think so that it should take more than 2 minutes. So once this particular execution will be created, this experiment will run. And right now we have only the 4 versions of my model available. As soon as this will get created and we will reach out to this particular step, the registering model into this model registry, we will see a new version of the model that will be the version 5. If you would like to deploy that version, you can simply go it here and you can deploy it here. You can select whether you would like to deploy it into the web service. So you can select it, and you have to provide the container instance or the Azure Kubernetes cluster. You have to select your script file. So it will be the score file. So you have to go here and deployment. Mhm. And you can select your conda deployment file. So it will have your conda requirements. So all the dependencies, and you have to give this name. So I will say azconf demo, and a deployment will get created. Once a deployment will be done, so this particular model, of course, I am using the previous model to finish in time. So once this particular model will get deployed, so deployment started successfully. And once this model will get deployed, we will see a endpoint here. And that endpoint can be used to test our data, right? So right now this is under development. So let it be. So the pipelines is getting run here. And here is our sample script, which we can use to test our model. So let me go here and go to this model 3, version 3, endpoints. No endpoints here. So you can see this is our sample. And if I will put it here, my model will let me know that, okay, this particular specifications is related to the species 1 of this iris flower. If I will do certain changes here or any changes,
Sorry to interrupt you, Abhishek. We have a couple of minutes for our next session to get it started. Hope you could
mhm.
wrap it up.
Yeah, sure, Lakshman. So as you guys can see that as soon as I am changing some input parameters, my model is predicting that, okay, now the species has been changed here. So you can see that after the deployment, the model is working fine. So either you can use the continuous deployment pipeline for this model deployment, or if you would like to have, you can use the manual deployment also. By having this, I would like to conclude this particular today's session. So if anyone have any of the questions we can have, or Lakshman, we can I have done with this presentation.
Okay. Thank you, Abhishek, for your valuable session, and I hope there was no questions from the audience side. So maybe where they are able to know how the machine learning model works and how can they able to automate, because right now it's everything is going on automation. Hope this all the information which you are able to cover, a lot of people is able to gain those information and they can take it from there. So I really appreciate your time and for your valuable session. Thank you, Abhishek, and have a nice
Yeah,
day.
thanks Lakshman, thanks everyone.
So next we are going to move up with our next session. It's going to present by Andrew Zerban regarding development with Kinetic for Azure. Hey Andrew,
Hello.
this is
Hey,
Lakshman here.
how are you?
I'm good. How about you? Hope you had
Not
a nice day.
not so bad. I mean, for me, the day only starts. It's early morning for me.
Oh, sure.
So I need
So
to screen sharing. I need to select the correct screen. So do you see my screen?
yes. So the stage is yours, Andrew.
Hmm?
The stage is yours. You can take it
Okay.
from there.
Okay, yeah, your microphone is relatively quiet, so that's maybe why I didn't hear you well.
Sorry.
Okay, so well then, thank you, Lakshma. So we are. Am I the last session for today, or somebody after me?
You are the last session, and this will be a last session for the day, so
Okay,
that you're good to go. So
okay, all right. So well, thank you all for staying for the last session of the day and for Azure Community Conference 2021, India's largest Azure conference. So okay, let me click here. Yeah, so first of all, events like this would not be possible without sponsors. So we thank the title sponsor, which is a title I haven't heard before, Ernst& Young. Um, again, the gold sponsor is Microsoft and the community partner Elastic, Pact Publishing, DevPost, RSA, Fitian, and developers wrote ahead. And of course, all those great communities. I will not read the names of all of them that contribute to an event like this. So, to me, briefly, my name is Andreas Urban. I just, for fun, changed my title a little bit and call myself now CTO Metaverse and Applied AI. I deal with mixed reality and virtual reality also. I'm with a company called DayNet. Um, DayNet is headquartered in Germany, but I'm in the United States. I have over 25 years of experience, worked with virtual reality and those type of fun technologies already in the 1990s, but then for many years mostly focused on enterprise development and enterprise consulting. But I love geeky technology, and in the last few years, I switched back in a way and tried to incorporate those innovations like Kinect for Windows, Kinect for Xbox, Kinect for Azure, HoloLens, and so into enterprise backgrounds. So the talk of today is developing for Kinect for Azure, and I will start right away with the Kinect device, right? The Kinect sensor fundamentals. So Kinect is a device that has been released already in 2010 for the first time as an iteration of Kinect for Xbox 360, and it was a pure gaming device. Yeah. Why is it important? Because it was optimized for scenarios for gaming and for the living room. So think about a child or a grown-up person standing in front of a TV, looking at the TV, typically trying to interact with the TV, like waving, dancing in front of it, but generally facing the TV. Yeah. And when Kinect was released, people got excited and they early started hacking the device and tried to make it work with a non-Xbox device. So Microsoft had a few choices then. And again, I do not work for Microsoft, But Microsoft could have chosen to say, you cannot do that. But instead, they went all in and said, hey, this is an opportunity. And they created a device called Connect for Windows, which basically is the same device, but with an API for Windows developers. So that exposed tracking for bodies, for skeletal data, as part of the SDK, and let developers now in a supported way write software for enterprises or sports and so on. 2013, Kinect One was released for Xbox One for the new version of the console, and Microsoft 1 year later released Kinect for Windows version 2, which has improved body tracking and overall also improved skeletal tracking and so on. Now, sometime in 2017, 2018, it got very quiet around Kinect because there were some things with Xbox that Xbox was a little bit slower than the Sony PlayStation at that time. So, and Kinect took a little bit of the power and budget from the Xbox, from the processing budget. Plus, it was also made the Xbox about $100 more expensive. So in a way, basically, there were not a lot of Kinect be sold compared to the expectations, I suppose. And so there was less and less Kinect, and suddenly it in a way disappeared. But then 2018, Project Kinect for Azure was announced, and then Azure Kinect, the development kit, launched at the Mobile World Congress 2019, which again has new body tracking and so on. We will talk about the device, the new device, in more detail, of course, but this is just to give you an idea about the timeline for how long this has been already in development. So there's some maturity there. So look, this is the Kinect for Azure device, roughly. That's how it looks like. I have one right here. This is not plugged in. I have one that's plugged in also. And so we can talk about the device in a bit in more detail. So let's first of all talk about the features of it, the hardware features. Yeah, it has a microphone array, and this cover here is removable. Inside it has a gyroscope, an accelerometer similar to a phone, which enables it to be mounted, let's say, to a robot, or and then you can get data about the position of the Kinect, the angle of the Kinect. I mean, not the position, but the angle of the Kinect. Is it moving? Is it stopping? And so on. Then the most important part for our talk today are the cameras. We have the RGB, red, green, blue camera on the left side. Think of it like a webcam in a way. Then there's a little streaming indicator, a light that is supposed to be on when you're transmitting or recording. Then we have the depth camera and the infrared emitters. On the back side, there's there's the power jack, which is basically a USB cable. On the other side, that connects to a charger. A power indicator, is it on? A USB-C connection to connect to your PC. It needs USB 3.0, and this 3.5 millimeter sync in and sync out. Now, why is that important? So one of the use cases of Kinect is that you may have more than one Kinect in a room. And the way the technology works, that causes a few interesting challenges. One of the challenges is that, of course, you want to take pictures in a way or video that's synchronized, that you do not have a lot of movement between two images from two cameras, so you can actually do logic on top of them or fuse them together and so on. But the other reason is also that the way the underlying depth technology works, it emits infrared signal in a specific modulation, and it makes sense to try to coordinate emitting this infrared signal. We will get to that infrared signal in a bit later also, but that's part of the reason you can minimize the overlap or crosstalk between the signal, right? If you would disassemble it, that's a slide thankfully provided by Microsoft. This is how it would look like. That's the microphone array. That's the main processing board. This is the main RGB camera. This is the depth camera, and those are the infrared emitters here. Yeah, makes sense? And I will actually I just had a quick look at the comments, but in general, let's keep the questions and answers towards the end unless something is super important. Now, briefly talking about the concepts of the underlying technology. Yeah, so the RGB cameras, okay, we understand that, right? But there's another part of it, which is this slide is from the Kinect for Xbox One. So the technology has improved, but the fundamentals are the same. But there's an article that I found online in a magazine that explains how that works roughly. Think about it like, okay, there's a pixel array in a sensor that is able to understand light, right? But then what does it have to do with those infrared emitters and so on? Now let's look at it a bit closer. So you have here the pixel array basically that understands the light coming back, and you have the sensor lens that fuses or projects the incoming light onto the pixel array. And then you have the light emitters, light source driver and lasers, diode and optics. So what this does is there's a timing generator. The timing generator generates a modulation for this light source, for this infrared light source. But there's multiple light sources actually, and there are multiple of those emitters, and then the sensor array gets the signal back. Now, knowing the timing and knowing the timing of the emitted light, then an algorithm can deduce based on the signal strength when was a specific pixel emitted that has been reflected, and based on how fast light moves, it can calculate the distance to an object in 3D. Okay, that was a little bit deep, but I thought it's helpful to understand what is this whole time of flight thing. It measures the distance to an object with light, yes, but to do that with so many pixels, you need to have a few tricks basically, and this is multiple light emitter sources and a modulation on top. Okay, so roughly, we will spend a lot of time talking about the body tracking in the end, but roughly let's talk about the fundamental how it works, right? You connect the Azure Connect development kit device to a PC via USB 3.0, and then you have the sensor SDK sitting on top of it to interact with those cameras. You can also, since it represents itself as a microphone to the system, you can use Azure Speech Services or any other thing that understands audio data to look at the speech, but we will not talk about the speech capabilities and the microphone array too much today. It can be very powerful if you would use it right, and if you can do audio processing, but that would be a different type of talk. So on top of the sensor SDK, you could use just the Azure Vision Services, for example, based on camera pictures you get from it, or you could use the body tracking, or you could use user build skills that can just work on the raw sensor data. Oops, I'm sorry for skipping the slide quickly. And on top of all that, your user applications, your solution set. Now, what does the device emit? So you get, first of all, the color image. That's pretty normal, right? You have then this what I call the IMU, the inertia measurement unit, that was again, remember the acceleration and gyroscope. Then the microphone array channels, which we will not talk about today. Then you have a so-called active IR image. So what is cool about the active IR image is that because of the unique type of the light source, which is the modulated infrared light, we can actually remove ambient light from a picture. So you will get a grayscale image of something you're looking at without, without a shadow being cast by good or bad illumination in your room. There are some light sources that can compete with this, of course, like sunlight is very strong, or if you would be welding something maybe. But in general, you can remove regular ambient light and get a clean black and white image. And why is it relevant? Because on this you can then also use artificial intelligence, because you know the quality, expected quality of the image and the characteristics of this image. And there's a depth map. This is a visual representation of the distance with different colors, just encoding how far something is. This is something you get in the viewer tool. We will look at the viewer tool also later on. Now, what is interesting about the fundamental sensor SDK, it is open sourced. Yeah. So it doesn't help me too much because I usually do not develop in C, which is the language it's written in, but it's cross-platform, it's low level, and it provides all the fundamental access and the device synchronization controls and so on, right? It has support for Linux, which is best supported for Ubuntu, I think 18.04, I'm not entirely sure at this point, or newer, and Windows. Don't ask me for the Windows version now. Windows 10 works. Windows 11, I just tried, it works also. And the SDK is available first in C, then C++, and C#. There have been some people wrapping it also in Python and so on. But since it's open source, you can also contribute to this whole thing. It is also, by the way, if you look it up on GitHub, the primary location where you as an end user or customer or enthusiast can interact with the product team. That's the best tip I can give you. If you ask questions there or raise an issue there, there's a good chance that someone will look at it. Better than email, or it's probably better than if you have an account manager and try to ask them for help. Now, the Sensor SDK tools have a few tools built in that come when you install it, and it's available in the source code. The Connect for Azure Viewer, you can view the sensor data and experiment with the settings. We will demo that a little bit later. A recorder, where you can record the sensor streams to a file, and you could theoretically replay that file. The file format is documented. You can open the file. So you could have your own test environment and have repeatable tests if you would want to do software on top of this. And you have, of course, a firmware tool to query and patch the firmware, which I just needed to do yesterday on one device. Again, you can contribute here in GitHub primarily. I have a customer voice, and Stack Overflow, I think, is actually less important than GitHub. Yeah. Body tracking, briefly. Well, actually, too much slides. Let's jump to the demo quickly. Yeah. So connect. So let me make this a little bit larger here. Okay. So this is what you get in when you install the Connect for Azure SDK. You see it typically in program files, Azure Connect SDK, then the version, and then there's there's the SDK itself with a few things you can reference in the application, and then you have the tools that come with it. Again, back to the tools, we have the Connect for Azure Viewer. Okay, and it opens. Okay, so it opened, and you could here, by the way, now see also open recording. If you would have recorded something with that recorder that I mentioned, you can open it in that viewer and view it later on. And you see here open device. So you can press refresh device if it doesn't find anything. If I would disconnect the camera, let's the Connect. If it would disconnect the Connect, it disappears. If I connect it again, it should appear again. And why is this relevant? This means they implemented this without needing a third-party driver. All the interaction with the device goes directly over the USB protocol and knowing the device ID.
Interrupt you, Andrew. Your
Yeah.
screen is not Could you zoom in as your screen a little bit so that the audience can?
Is this? Yeah, I can try. Geez. Um,
Thank
geez, what's the shortcut again? Okay.
you. Sorry for the interruption.
No, don't worry about it. I think it was Windows Plus, wasn't it? Or Control Windows Plus? Yeah. It's interesting. So the viewer now moved to a different. Okay. Do you see it here? Because I seen my system view is now totally messed up. I don't know what you see, but right now I zoomed in on my device. Does it work for you?
Yes, it's quite a bit. Thank you.
Okay. So I have to warn you, we will have to zoom out because otherwise you don't see the videos that I will show. But okay, so you get the serial number displayed if you have multiple devices connected to one computer. You would also have serial numbers here, and in theory, you could connect multiple devices to one computer. That is a big difference to the Connect for Windows version 2, where only one device could be connected to one computer. But on the other hand, what happens when you click Open Device? You own that device. Nobody else can connect to it. If another application would try to connect to it, and remember that if you develop that, you will get an error message. And then you have all sorts of settings here. Yeah, you have a depth mode in 2 versions, and with bind and unbind, and by passive IR mode. Let's talk briefly what that means. You have basically a near field view and a wider field view, right? So one is optimized to see further meters or distance out, and one gives you a little bit more precision for closer for things that are closer to you. And then you can choose bind and unbind. Bind means that basically 4 pixels, 2 by 2 pixels, will be combined to 1 pixel. You have less noise. And unbind means you get the raw pixels. You can enable the color camera with different formats for the color signal and have a resolution for those cameras. Select the frame rate, enable, disable the IMU, the microphones, external sync. You can look at the firmware versions of the device and so on. Yeah, so let's just try to start it, and I will try to zoom out again because otherwise it gets a little bit difficult to see the actual output. So you see actually the Kinect camera looking at me from the back. Yeah. So let me show you something briefly. Actually, you have, as I mentioned earlier, there's this removing of ambient light. Yeah. So if you look at my phone here, that I'm holding close to the Kinect camera, you see how my phone basically shines the flashlight into the camera. Yeah. So here on the lower left side, but you will not see the light here doing anything on the upper side. Yeah. So this light doesn't bother anybody. If I would shine it on my hand or anything, like there's no difference. Yeah. Okay. So again, this is a color camera. This is the infrared image, and this is the image representing the distance. Now let's look at this briefly in 3D. What does it mean? You can now have a 3D look of what the camera sees. If I would move the camera now, you could see things in a different angle, and it basically tries to give you a 3D representation of how far something is in the room here. Oh, okay. Let's stop that for now. And let's make sure I close the device, because otherwise later on I will get error messages if I try the other demos. Now here I can also do the recorder briefly. So I'm recording a file, and that file is output.mkv. Has been recorded. You have seen probably in the, I don't know if you saw it, but I was trying to wave around a little bit here. So this is basically what I recorded here in the background live during the session here. And you can just play it in any video player. The big MKV format can include additional data like the IMU data and so on, but also just a regular video stream. Okay, that part of the demo was relatively simple and dealt with the main video sources of the Connect for Azure, or the Azure Connect. Now let's talk about body tracking. Yeah, just an overview. Like, it has been designed from the ground up for Azure DK. Why does it matter? As I said earlier, the initial Kinect was developed for the Xbox, meaning nobody thought about what if somebody turns their back to the camera, or what if somebody lies down. Yeah, this is not a scenario it was developed for. So, and since it's used AI, if you meanwhile, probably if you train AI with something, the results are only as good as training data. So if you never train it for seeing the back of a person, it will never understand that there's somebody facing the back to them. Yeah. So what we're getting is we get an instance segmentation map. What does it mean? It means you get the outline, the shape of a body in pixels with basically a number representing that. You get the 3D joint positions. You get a unique ID for each person, or for ZSCs, and it has improved quality over Connect version 2. And you can, it supports cross-platform development. Windows is supported. Linux is, I believe, still in preview. Maybe it's released meanwhile. And you can develop against it with C, C++, and C#. Behind the scenes, it uses an Onyx runtime with support initially for NVIDIA 1050 Ti with hardware acceleration, but also supports now other devices through DirectML on Windows or TensorRT. So you have a little bit more option for the support now. Now let's talk about the training. So this is roughly how Microsoft approached it here. First of all, Microsoft knows how the data from the sensor looks like, right? So they built a sensor model and modeled to get best possible data quality. They were able to optimize or build a model. How does expected data from the sensor look like? Yeah. And then what they did, what you see on top of it, this is all machine generated. Those are not real people. So think about those. Those are animated people with artificial trackers on those bodies, who are animated to do real human emotion with modern software that can simulate like even flow of clothes and so-called inverse kinematics and so on. Now, if you combine this here, those motions that you model, and then project it to the sensor model that to render it basically for an AI that it looks like a device, then you can train for the device without actually having to physically record thousands and thousands of hours of video with real people. And most importantly, you don't need to label them, right? You get labeling automatic. You know where the arm is, you know where the leg is, you know where the head is. You know all this because those are artificial models. And if you do it right, you can account for human diversity. Yet you don't need to find children of all races and body shapes. You can model someone who has a disability without needing to potentially have very strange conversation with people, finding to people with specific disabilities to film, and and you can simulate multiple environments. So this here is more like a gym, but you could simulate it in a doctor's office or in examination room, in a living room, and so on. You can do all this with this specific training data. One question that typically asked is like, does it recognize dogs or other pets? No, it does not. It has not been trained for that. So from what I see here, Microsoft probably has infrastructure to do something more with it, but at this moment they don't. It's not optimized for that. So here's a comparison with Connect for Windows version 2. I will not get too much in detail here. The core is for you as a developer that it has a little bit of higher requirements on the processing side, but you get also something back for it, right? For example, what you get back for it, that you have no practical limit about how many bodies are tracked, but the limit comes from a more natural situation is you cannot usually fit more than 15 people in the frame of the camera and still get an idea and still have them with enough distance that you can actually recognize them. Yeah. For developers, it's a C API that's built on top of the sensor SDK. It's easy to wrap, and we have a C# high language API also. There are some people who did Python bindings, and there's a Unity 3D scene also that uses this. And now let's look at the body frame. Yeah, the body frame. What is that? It's a collection of body structure. We'll talk about what the body structure is, and this is a body index map that I mentioned before, that shows you which pixels belong to a person. You can use it, for example, for a green screen effect to remove a background and just show the person there. And you can capture that input and record people moving around and so on. Yeah. So 3D skeleton. Is basically the visual representation here of where the joints are. Yeah. Let's talk about the architecture briefly. Yeah, how does it work? So the architecture works with the Azure Connect development kit, sends then data to the sensor SDK, and then you have the active infrared image. Remember that which was not impressed by the flashlight. Then on top of that, a convolutional neural network runs the Onyx runtime and gives two-dimensional joint positions that it derives from that. And it also gives you the segmentation map. So that's what gets outputted by the whichever AI acceleration you have. This is basically also the bottleneck for this GPU, for the graphics processor, or for TensorRT or whatever you use. And then the next step is you have the depth data coming, which also comes from the Kinect SDK. And then you do something called model fitting. So that means you know the position in 2D and you know how it should be in 3D. So you can then, with some knowledge and some constraints about how human bodies usually should look like, you can then, with very good precision, fit or create an accurate representation of the skeleton of what's this. So behind the scenes, how it works from a processing point of view, you have the Connect for Azure capture, which is a frame coming from the sensor device. Then you put it in a data queue, and then from the data queue, like in the background, it gets pulled out, be processed by the convolutional neural network. Then the CPU does model fitting, and then the results come in another queue, and you will pop the results from the queue and process this. Now, talking about the skeleton, this is just I will show that only very briefly. It's an expansion of the previous number of joints we had in the previous versions. And it gives you basically coordinates for each of those joints, and you know the relationship between those joints. And you have in the SDK an enumeration that says, for example, hip or pelvis, spine, clavicle. That makes it easier to access those. Yeah? Okay. Joint definition. This is roughly the data you get for each of those joints. You get a float value for the position in 3D, and you get a quaternion for the orientation. I have a slide about quaternions later on. Just think about it that it's a orientation is like a fancy rotation. So it tells you in which direction the joint is pointing, or relatively to the previous joint initially, but in this case, relatively to the camera origin. So yeah, so both position and orientation are relative to the depth camera coordinate frame. So that means each depth camera has a coordinate system, and you can do then math based on the difference to that coordinate system to the origin of the coordinate. Talking about a few scenarios that you can do: kinematic analysis, you can do posture analysis, rehabilitation, fitness, patient monitoring, fall detection, sports instruction, human understanding, like understanding shoppers in an environment, person detection, counting. You can see, like, is somebody grabbing for a specific item and do they still hold it? You can interact with smart spaces, or you can have more generic human computer interactions, like interacting with signs and video walls, like the typical grab motion, and interpret that in a way and then move a virtual object on that screen. Or you can have more artwork installations where birds follow your hand movements and so on. So a relevant scenario that I have heard a few times is also machine safety. For example, a machine is only allowed to run if the persons seen are in a safe space, in a known safe space, for example. Yeah. Now, a brief walkthrough, again, roughly, how does the whole developer process work? You start the camera first, you do the query capture, then you, if it's a new capture, then you update your point cloud into render the whole thing. So in C, that would look like something like that. You give it the device configuration with some settings. You remember the visual modes I mentioned earlier, the 2x2 bin, for example, and then you start the cameras and verify that you get a good result. So our hands-on demo will be with C# also. Yeah. So let's look at the demo basics briefly. So I will jump to the second demo right away, actually, because it also shows the simple mode. So remember I said earlier that you need to you own the device. In this line here, if you try to open the device and it is owned by another process, then you get a failure. Then here you start the cameras and let's just step through. Maybe that's easier. So we start the camera, give it a specific device configuration in the C# SDK, which you can get through NuGet also. So it's available through NuGet Package Manager. It takes a second maybe. Then you initialize the so-called transformation engine. What is that? That is something that helps you translate, for example, between the camera, the points that exist in the different cameras. Remember, we have an RGB camera and a black and white camera. You need something that's able to correlate, hey, this position in camera black and white is that position in camera RGB. Yeah, so you get the calibration, you get how tall the color data is. You then initialize, that's Windows development. You initialize a bitmap or .NET development and set some parameters and start the UI. The UI starts, and basically here you see something rendered. Yeah, so you see basically here some shades of color depending on on how far something is. Okay, now this is a part that gets called whenever when the window gets loaded and the task is initialized. the way they did this, they run a task and basically have it running forever, and they get capture data. Yeah, so let's put a breakpoint here. I hope it fires, and yeah, so we can step through it. You get the device timestamp from the device. You then can transform, like use transform on that depth image, so you get it in the format that you want. We transform it to the color image basically, and then we do a little bit of math here. And I will not go too much in detail here. This is just manipulating the bitmaps that exist in storage in memory on your device. And what they do basically here is they assign and rotates through colors based on the depth data. And that's how basically you think about every, I don't know the exact distance, but every maybe 10 centimeters or 20 centimeters here, the colors start again. Yeah. And then, of course, they have a different modulation for when it's a little bit further away. That's very simplified, this demo. Yeah. Let's look at another demo that's is a little bit maybe clearer. Let's actually close that, otherwise I get confused myself. The second demo, dealing with the sensor streams directly, looks at, it's called segment color. It does something a little bit different. Again, it opens, the opening parts are pretty much the same. I will not need to show you again. It initializes everything, gets the calibration data, creates a transformation, and now let's jump hopefully to the right breakpoint. Oh, I removed them. That's typical demo. Oh no. Okay. That's a breakpoint step yet. Okay. So now let me show you how it looks like. Sorry, my system is a little bit slow right now. One thing I forgot to mention, is about performance. I will get to that in a second. So this is basically what the camera does right now. What you notice is the image is kind of cut off, and it's cut off after exactly 1 meter. So everything that's further away than a meter gets ignored. The way that works is that here you have this loop. The loop goes over all the pixels in that transformed depth buffer. And so we have the depth pixels and the color pixels now correlated in the same matrix if you want, and we're stepping through it in the same speed. And now if a depth pixel is less than 1,000 millimeters away, then we continue. Then we do not do anything to the color pixel. But if it's more than 1,000 away, then this pixel will be zeroed out and will be ignored, basically. That's how the basic manipulation works. Okay, now let's get back to the meat of dealing with more advanced concept with body tracking. Yeah, as I showed earlier, body tracking has this concept of the queue. So we have the capture of the image, then we pop the result from the body tracker when it comes, and then we do something with that result. So input capture, collection of structs to the body index map. Again, this is the definition of the parts of the body in an enumeration, so it makes it easier to develop against. And again, the joint definitions. Now look quickly at a very basic demo first. Yeah. Which is again those demos I'm showing right now. They're all available to you. You can download them from the Microsoft website. They're part of the SDK. Okay. So I didn't show starting the camera and so on. So we're already at the point here where we want to initialize the tracker. The tracker is basically the component that comes from the body tracking, has a device calibration, has a processing mode that you can set. We set it to you want to use the GPU, and has a sensor orientation, which I believe you can change it to upside down, and then you get the sensor capture and queue the captures, which I said earlier, and then you pop the results. And when you have the result, you set basically that result frame that you get, the frame reference, to, let's say, the visualizer, and do something with it. Now, the do something with it is where it gets interesting. Actually, I can try to put a breakpoint here. I probably have, yeah. So we can, we cannot look at it right now in this context. Let's move on to, oh, I can, let me turn around so it actually sees something. So you can see that the camera actually recognizes me. And now let me, what I forgot, to put the breakpoint in the right spot. Okay, let me restart the whole thing. Be easier if I look for what? There's no for loop? Okay, my demo gods are really bad right now, and I confused myself now that I don't remember in which source file the relevant part is, but I will find it in a second. Actually, okay, of course. Yeah, that was my level of concentration went a little bit down here for a second. Okay, so here's a loop that goes through the list of bodies, and we will briefly look at basically when we find a body. We need to put the breakpoint inside. How that data looks like. So okay. So here we have a skeleton coming back, and you see the skeletal data is just some unstructured data at this point. Yeah, it gives you a number of joint counts and so on, and you need to access that data by going through the enumeration. In this case, we're using it by joint ID, by the number. So you can use the ID, or you can also use the enumeration values that are defined in a definition file. But in this case, we're just using the IDs. and here's then the joint data for this. Interesting enough, you get a confidence level for each joint, which is relevant for sometimes for if you want to reason or do math on joints to have an understanding how well is this position guessed versus is it a good guess or a bad guess. So this is a position again. It is just a float, and this is a quaternion, which has 4 parameters. Yeah. Okay. I apologize for that hiccup in starting that demo here. Just to show it here again, I'm gonna turn around the camera. Yeah, this is how it looks like. Okay. So how we on time? Okay. So let's talk about, now that we looked at the demo, is like an example use case that I built quite some years ago, even with the previous version of the Connect. So I'm clicking through it. So this is roughly an application. Think about that is trying to do something with Connect. Yeah. That means you need to have some levels of abstraction on it, right? You have a sensor system. The sensor system is a Kinect. You have some high-level processing, and then you, as a developer, probably want to have some event handlers that react to that processing, and you have some rules to it. You want to do like posture classification, understanding who's sitting in front of you in what posture or doing something. You want to visualize the whole thing. You may have you need to have some model or understanding of the world, which consists of physical formulas, a body model, a model of the physical body, rules like acceleration, and then combining all this like to understand is somebody falling down, for example, and so on. I mean, this is just a very, very rough overview. So some body joint considerations, yeah. So you should consider tracking state if available. This was a precision I mentioned earlier. You can understand the joint hierarchy, and you can do mathematics for more advanced scenarios. Consider utilizing a game engine or physics engine to do some of the math for you potentially. Yeah. So some of the things we did to understand the human body is we went and did some research, and we looked at an example. What is a typical distribution of body mass in a typical human body? Yeah. So assuming like body parts have a shape like a rod, and you have here the typical the body mass distribution in for a typical human being, and so you can build a model based on this, let's say this stick figure or this model, and then assuming a muscle efficiency to be 20%. Yeah. Then quickly quaternions here. This is math is being done with quaternions. They represent rotation. They're a little bit more complex than complex numbers. If you remember the square root of -1, then we had the introduction of the I. This is similar to this I. And this is basically gets us to the next level and is able to represent a rotation in 3D space that is immune against so-called gimbal lock. There's a lot of great YouTube videos that explain that in detail, but I think there's some formulas that you can use to work with those, and you can simplify those formulas and adapt them. One important concept is the concept of doing math on motion observed. Everybody knows velocity, acceleration, and then like the difference between two coordinates and the difference in time. Then the difference between two velocities and the difference in time is acceleration. Then you have force if you have a mass and acceleration, power if you have a force, and then again the velocity, and energy if you have the power, and the energy is the power over time. But you can do similar things also for angular motion, for things that happening. Let's say you move a joint. Yeah, what happens here to move this, like this rod, my hand, to move it in this way, right? On my arm. You can use formulas like this. I will not explain them in detail, but The concepts are velocity, acceleration, torque, power, and again, work and energy. So this is a demo we built then a while back, and you see basically here me moving around, jumping around, moving around, and you see different arrows, different green and purple lines. The green and purple lines, this is not live, I recorded that, represent velocity and acceleration. Yeah. So yeah. And then you see those circles. The circles represent the calculation of force in that joint based on angular motion and based on regular positional motion. Yeah. Do you see, for example, this joint here, right? This this shoulder joint here. I don't move much here, so that you see in some motions only angular motion and angular energy expenditure because of angular motion. Now, this is important, so because sometimes you may not move physically a lot in a specific part, not a lot visible, but you can still calculate energy expenditure based on it, based on this specific joint, yeah, or forces on that joint. Sometimes a force on the joint is important to understand to predict or to prevent it, like your joint from breaking. Yeah, so this type of math can be important. This demo does a lot of other things also. It was able to detect falls and so on, but I cannot show that to you in too much detail today. One other important concept was handling jitter. It is common in computer vision and in all sensor systems that you have some type of jitter being present that may make your data messy. Yeah. So what we did was introduce a filter, like we did a double exponential filter to try to remove some of the jitter from the calculations. And that gave us good results. And I will show you briefly what I mean with that, with good results. Like this is, you see the acceleration, the velocity vectors, and how they are when I move around. You can see some of them are pretty stable here, right? Yeah, because I have the filter on. So if I turn the filters off now, and I go into the camera again, and even if I don't move, you see, even though the joints itself are relatively stable and you don't see a lot of motion, it was flickering around like crazy because the calculations on small differences, like to calculate acceleration and velocity, and small differences can already be drastically if it jumps around too much. Yeah, I hope that explains it a little bit. Some concepts for example, that we used was activity levels. Activity levels we build categories by using kilocalories per minute. And if you remember earlier, I had some assumptions like muscle efficiency, like 20% and so on, that we used for that. We also did fall detection in two different models. One model was to try to understand, let's say your head position moves downward more than a specific threshold number and to the base of your spine. So basically your back is all close to the floor. That means probably you're down, right? And then you don't recover within a recovery threshold distance in a specific time. Then you had a slow fall, you're on the floor. Versus a violent fall, you look at the forces, at the sum of the forces on all the joints and how they move that would occur when you impact, when you hit the floor and suddenly you decelerate. Yeah, you decelerate, you get a lot of forces and a lot of joints in a short period of time. However, there are a lot of gotchas, there are a lot of false positives. Like if you would jump on a sofa because you're tired, you want to watch a movie and the sofa is comfy, the system might detect that at a fall. So be careful there. Posture recognition, and I'm almost done, is
And since we have 2 more minutes for the
yep.
completion of this session.
I'm almost done, yeah. Posture recognition can be done in a very sophisticated ways, but you can also do very good posture recognition with very simple assumptions. Like say you have standing, And standing could mean, hey, my spine is relatively straight and my legs are probably also relatively straight and not more than a 45-degree angle. Similar with sitting would be spine is straight and maybe upper legs are more parallel to the floor. And lying down would be my spine and my legs are probably not more than 45 degrees upwards, but more parallel to the floor. Yeah, makes sense? Give you an idea, we validated all this in this energy expenditure measurement with some real data and jumping around, and we compared the energy measurement from more accurate devices with the calculations we did. We saw that we overestimated things a little bit, depending on the type of motion, and recognized that we had to adjust it. So we adjusted the formula a little bit based on that observation, and we were able to get closer um, to accurately estimating. If you want to do that yourself, our learn was that depending on the type of motion, you need to have a slightly different formula. So if you want to measure running in place, use one formula. If you want to do squatting, use another slightly different formula, and so on and so on. Okay. I hope that makes sense to you. So with that, we don't have much time for question and answers in this session, but I believe the chat can be used after that even. Is that correct?
Yes, it is.
Okay.
In the respective channels, you can able to answer the questions on the chat.
Okay. So we'll gladly do that. I'm available for questions and answers. Please submit feedback. With that, I thank you all for attending the session. My contact information is here, or you can just search for my name online. Thank you.
Okay. And it's a great session and having you, Andrew. It was a pleasure to have you in the Azure conference. So a lot of people able to know what are all the things that I can do using the kinetics. So on reading the body motions, there are a lot of stuff which are shown. It's great and it's nice to have you here.
Okay, thank you also, Lakshman. And I hope to be back next year.
And thank you and have a nice day.
Yeah, okay, I'll stop sharing.
Hey, hi guys, that wrap up the end of the session. So there was a keynote going on the track one, so you can just follow over there. Thank you.